last summer, we worked with the General Assembly to take the program to the next level. And that's when we kicked off a new water initiative, the H2 Ohio Rivers Initiative. And so a whole new level of funding was provided just to focus on Ohio's streams and waterways. And so this initiative includes money in three basic areas, right? For monitoring and data collection, for restoring river health where rivers are degraded, and for preserving healthy rivers. How do we protect those waterways that are already pristine? And so to get a good understanding of how to protect our rivers, it's important to understand the quality of the streams. So we are improving and upgrading all our monitoring and data collection activities. We have a large-scale mussel survey. We have a number of collection sites that we have set up already for the survey. We want to restore river health for the waterways that could use our help. So this includes things like we have several projects underway to reduce acid mine drainage. We have projects already in Perry, Jefferson, and Belmont counties on that front. We're focused on removing dams where it's needed. And this is something I'm going to ask the audience. We could use your input and help with that. So we know where all the dams are, but the next trick is where will it make the biggest difference, and where do we have a willing dam owner that will work with us to remove those dams? So I'm sure you'll hear more about this later, but that's sort of the tricky part of it, finding the places where we can do this work. We have the resources, and now we just need to make it happen. And we also want to take steps towards maintaining and protecting our healthy rivers by acquiring either the land or easements in important riparian areas. So a significant amount of the money was set aside for that. And we project that by this summer, more than 8 miles of stream bank and 17 acres of riparian lands will be further protected. This includes mature forests, wetlands, bluffs, oxbows, and more. So we're excited about those opportunities to protect what's already good. Now onto the important news I referenced. So today, we are formally kicking off action on what we're calling the Healthy Rivers Litter Program. So since we received this funding last summer, we spent all this time putting the program together, and we want to share a few of those details with you today. So for the first part of the program, we're going to roll out the Healthy Rivers Litter Grant Program. Was I supposed to be doing that?
No, it's there's a freeze up, sorry.
So this is a pretty unique idea that the staff developed after many conversations with livery owners across the state. And those folks are often our greatest conservationists, right? It is in their interest. It's in their business model. They want a beautiful river so people will come and enjoy it. So this is a program where commercial liveries can apply. It's for a grant, and it's designed to provide support for their efforts to clean up river trash. So the idea is that they encourage customers to participate in cleanup efforts, or they go out and solicit groups to go out and clean up the rivers. These folks are great stewards and recognize that a beautiful river only makes their enterprise more successful. So they can apply for up to $10,000. The program is live on our website. It's been up for a week, maybe 2 weeks in that area. You can find the application, you can refer friends to do it, and the livery is awarded the grant, and you stole my prop.
Sorry.
And we give them a whole bunch of bags that look like this. And so if you are out, at a livery with your family, with your friends, with a group, you can take these along and collect litter as you go. So that is one, I think, really unique, and I want to congratulate the staff for coming up with a fun, super idea that liveries assure us people are going to participate in. The second part of the program is to get the word out on the importance of keeping our rivers clean. And this is sort of a marketing campaign that we're launching starting this spring. So it'll be social media posts like, I hope there's one up there. No? Right, so we'll be doing a lot of social media. People have mixed feelings about social media, but I'll tell you, at the Department of Natural Resources, with all of our different divisions, we actually have hundreds of thousands of followers. People kind of like our posts. So we have really good, we touch a lot of people with what we do. So we're really going to make an effort this summer to promote the program, to promote general river cleanup. So posts on Facebook, Instagram, Twitter, it's not called X now, will help encourage people to get out on the waters and clean up the streams. We'll be putting up signage, using other communication methods to discourage illegal dumping and littering, along with cleaning up what's along the waterways. So the goal of the campaign is to engage with an even wider audience than what we have in this room about the importance of keeping our waterways clean, to discourage bad practices and encourage people to join in the fight by connecting with libraries across the state. So, another part of the litter program will include cleaning up large accumulations of street-side trash and illegal dump sites. Primarily, that will be contract work, and we have several of them in contract now. But to clean them up, you actually have to find the dump, right? And that's exactly what John Horn, I think back in the corner, I think he's speaking later today. He's our H2 Ohio River Initiative Manager. That's what he's doing. So he can tell you, he gets tips about dump sites that are in the middle of nowhere. He has to go out and check them out. He has become our dump detective, finding the best places where we can contract that work out. So again, I encourage this audience, if you know or see areas that need attention, we are happy to investigate them. So call John, call me, call someone at ODNR, and we'll get the information to John and we will check it out. But we're taking very seriously this part of the program. So we're tackling our goals aggressively, and we believe this is important work that just can't wait. We know the way forward is by working with a wide range of agencies and organizations. Many of whom today are here as speakers, sponsors, exhibitors, and we appreciate it. So I think it's a beautiful bag. I think our exhibitor is here with these. And the bag's a good deal because I can tell you, I know some of the folks here. I saw Hope Taft, and one day Hope Taft talked me into a canoe trip. I don't see her right this second, but I know she's out here. And we went on this canoe trip, and I am not a great canoeist, so I always pick a staff person who is the best canoeist, so I don't dump the thing. So Erin Rourke, I think, is here too. So poor Erin had a canoe with me, and as we went down the stream, we ran across a giant tire, which we thought was a great idea to pull out of the lake and put in our canoe. It took it down about 6 more inches, but we did make it to the end. So these bags of litter will be much easier to pull in those tires out, but we will bring back contractors for the big truck tire dumps. So we are committed to making it happen. So, none of this is new to us though, right? Restoring, protecting our rivers. ODNR has been around for a while, and in fact, this year we are celebrating our 75th anniversary as an agency. So ODNR was created after more than 200 years of policy making, where conservation efforts were implemented bit by bit on a really wide variety of agencies and commissions. So when I say 200 years, it's back in the 1700s even. There were already conservation laws in place for the Northwest Territory. So it scattered around for a long time, but eventually lawmakers decided it was time to put all those efforts under one umbrella agency, so the mission could be carried out with the unified voice. And so ODNR was created in 1949. And at that time, it had 7 divisions. Geological Survey, which is the oldest, sort of the first division created in the very early 1800s. Wildlife, forestry, parks, water. Clearly missing a couple on here because I said 7 and that's 5, but don't quiz me on that right now. And since the late 60s, the department's been working with local communities, landowners, and river enthusiasts to build one of the nation's leading scenic river programs. And we're really proud. Bob Gable does a terrific job of keeping focus and importance and making things like the Symposium happen. And his feet are on the ground every day out in the field doing the hard work. And so today we have 15 rivers designated as wild, scenic, or recreational. 3 have national designations, and we are studying yet another. We are ever hopeful that we'll be able to designate another scenic river in the near future. So this division has accomplished much in the last few years. But let me give you just a few accomplishments that Chief Johnson and Bob Gable and others in the division have achieved in the last couple of years. So in the past 9 months, we've dedicated 2 new state nature reserves, which are really designed to protect hundreds of acres along the Little Darby Creek in central Ohio and the Little Beaver Creek in northeast Ohio. those stream systems. So those new nature reserves were really designed to partner with our scenic river system and protect those areas. Each offers recreational access, and each also protects the waterways, or plant communities, geologic features. Now, the Little Beaver Creek is especially close to me. So there is a beautiful waterfall in the Little Beaver Creek. I've been told about this waterfall, and I've now visited twice to try to see it. And the second time, I even toured, I brought along our communications chief, and we followed the preserve manager to go find a beautiful waterfall. We never found it. We were covered in mud, and I had an event immediately after that, which I went to, covered in mud, but it was okay because it was with a bunch of school kids, and they didn't care. They thought it was great. They wanted to go back with me to where all the mud was. But I know there is a beautiful waterfall there somewhere. There's a lot of going back and forth. So let the record show, I love a good waterfall. I love our great scenic rivers. I'd like to spend time out there on them, with them, searching for them. So another accomplishment with the division, they just completed acquisition of the William Budd Hill Scenic River access along the Ashtabula Estate Scenic River. Protects 54 acres of stream corridor, featuring waterfalls, a hemlock forest remnant, vernal pools, gorgeous bluffs. We're really pleased we can do that. We've learned how to effectively conserve Ohio's best streams, and it takes protecting wooded stream corridors, educating the public about best management practices, and for development, and remaining connected to those rivers through research, monitoring, community engagement. So momentum. I mentioned a little bit earlier, but it's a perfect theme for a day like today. You have an excellent slate of speakers after me, and I ahead of you. I'm looking forward to hearing what they have to say, and then I hope each of you hears something that motivates you or your organization, and gives you some action items when you leave. So thank you for being in attendance. You're doing important work, and I know I speak for our department when I say we are honored to share in this work with all of you. So thank you.
Technical difficulties we have to deal with?
Yeah.
Thank you, everybody. Thank you, Director. I appreciate those kind words, and I assure you that under your leadership, the Division of Natural Reserve Preserves and the Scenic Rivers Program has a great deal of momentum. So we appreciate your support and encouragement, and I still owe you the Scenic Rivers. So I'm going to keep that promise. We'll get one before next 3 years are up. My name is Bob Gable. I'm the Scenic River Program Manager. I'm going to be the moderator for today. I just want to go over a few background housekeeping items before we get started. If you don't already know, the restrooms are through the double doors there to the left. We have coffee and tea back here. I think that'll be available throughout the day, and water. If you need Wi-Fi, the password is Villa Guest, VILLAGUEST, all lowercase. We have several sponsors that helped us put this event together today. So please, during the breaks and lunch, please look at all the displays that our sponsors have up. We really appreciate the sponsorships that they help out with the funding and getting this symposium together. We also have 4 poster displays by students back here in the corner, so please take a look at those as well. We have some banners up here we have 4 scenic rivers this year that turned 50. So we had 4 designated in 1974. That was, I think that was our best year to date. So please take a look at those. I also wanted to recognize the people that helped put this together. There was a lot of work that went into this, and admittedly, I didn't do much. This is my role. I get to stand up here and have fun and talk to you all and meet you all throughout the day. So I want to recognize some of the folks that helped out. So WAMO, Water Management Association of Ohio, is one of our biggest partners in this. They handle all the registrations and everything. So we really couldn't pull this symposium together without their help. So And I want you, please stand up when I call your name. Sarah Saylor with Water Management Association of Ohio. Lindsay Talaferro with Ohio EPA. He's also associated with WAMO. Heidi Hetzel Evans with our Division of Natural Areas and Preserves. I don't see folks. There she is. Heidi is party planner extraordinaire. So if you want to have an event like this, Heidi's the person you need to look up. Melissa Murney with Maneri, I'm sorry, with our Division of Water and also with WAMO. And she's our technical expert, so she's keeping everything running up here. Jenna Winters with the Division of Natural Areas and Preserves. And Liesel Fenstermaker with Natural Areas and Preserves. Where's Liesel? So I'm gonna embarrass Liesel for a minute. Liesel just passed her Ohio state muscle test, so she's now certified. So we now have a certified muscle expert in DNAP, and that's something that I've been saying we're going to do for about 10 years now. So maybe Liesel can give me the motivation to get that done myself. And then Elizabeth Mack, who's I don't think is here with us today. So with that, we're going to get into our first speaker, our keynote speaker, and that is Craig Nelson, who is a hydrogeologist and supervisor with the Ohio Geological Survey's Groundwater Program. Craig performs groundwater mapping and groundwater modeling and develops tools for hydrologic data processing and visualization. Craig has an MS in graduate certificate in water policy and hydrology from the University of Arizona and a BS in environmental science from the University of Maryland in Baltimore County. So Craig, welcome. There you go. Thank you.
Thank you very much. Thank you, Director, and thank you for everyone for inviting me to speak today. So I supervise the groundwater program at the Ohio Geological Survey. And because we're going to be having some interesting talks today about groundwater's relationship to our rivers, groundwater in the West with all of its important challenges, and then the interaction between groundwater and surface water, which is so important for our rivers. I thought I'd start the symposium off with kind of a high-level overview of Ohio's aquifers. So there are folks here from many different disciplines and different areas of expertise that might not have a lot of familiarity with Ohio's aquifers. So I thought we'd kind of set the stage with talking about them. I'm not going to get every single one of them. That would take longer than 30 minutes, but hopefully to touch the surface on most of them. I got about 500 million years to cover in 30 minutes, so I'm going to be kind of quick. I'm taking this from a sort of a historical perspective as a geologist, so bear with me. First, I'm going to do a little terminology. This is our hydrogeologic settings of Ohio map. It maps Ohio's hydrogeologic settings in overarching terms. And throughout this presentation, I'm going to use a couple of these terms interchangeably. I'll say consolidated a lot, and that basically just means rock. Unconsolidated means your sand, gravel, silt, clay, those materials that you could conceivably put your hand into. And then unglaciated and glaciated, as most of you know, 2/3 of Ohio was glaciated and 1/3 of it was not. And that has pretty important implications in terms of groundwater yields, groundwater flow, and its interaction with our rivers. And then at the most basic level, these are our primary consolidated bedrock aquifers in Ohio. We have shales in brown, limestone in green, sandstone in yellow, and then we have all these interbedded units. So this dark red is where we have interbedded sandstones and shales. Purple is where we have interbedded limestones and shales. And then this kind of salmon color are interbedded sedimentary rocks, limestone, sandstone, shale, coal, clay. When I say interbedded, think kind of like a layer cake. It's never that simple, but think one thing over another. So you have sandstone, shale, coal, clay, sandstone, limestone. And then for unconsolidated, the aquifer media is going to generally be sand and gravel. Now we do have areas like the Oak Openings, which is almost pure sand. There are areas that are almost pure gravel. We have a few aquifers that are more silt, where there's really kind of poor bedrock below it, but the majority of unconsolidated aquifers in Ohio are standing ground aquifers. And they come in various forms, which we'll talk about a little bit later in the presentation: buried valleys, glacial complex, outwash, alluvium, beach ridges. Most of the most productive aquifers in the state are unconsolidated aquifers, with some exceptions. And this is our bedrock geology map, and it shows the units at the near surface. Obviously, you can't read the legend here. It's a lot of information there. What I want you to kind of walk away this slide with is just a sense of awe and appreciation of the time scales we're talking here. So when we talk about bedrock aquifers and bedrock in our state, 500 million years ago, you know, geologists are, I think, tend to be, or hopefully are humble people, because you realize that humans in our lives are very, very small and short. And compared to these time scales, it's everything that we do and see, it's very ephemeral. You'll notice, so all these bolded periods we're going to talk about, and the aquifers that were deposited in those periods. We don't have Mesozoic or early Cenozoic deposits in Ohio, either because they weren't deposited or because they were deposited and then eroded away. And that's why we don't have any dinosaur fossils. So I'm going to start with the bedrock. Again, I'm going to take this from a historical and depositional perspective. So all of our bedrock in Ohio, at least near surface bedrock, is sedimentary. And that means it was deposited by water. So either in lakes, seas, river deltas, etc., lagoons. And because it is deposited in water, the environment in which it was deposited is extremely important. Sea levels throughout these 500 million years have changed quite a bit, you know, with tectonic activity as well. And that depositional environment drives the lithology of the aquifer. So where we have deep or stagnant water during deposition, you get your shales, your siltstones, your mudstones. Where you have beaches, deltas, high energy environments, you get sandstones. And then in your reefs and your lagoons, where you have all your, you know, critters with their shells dying and falling down, and all the shells compacting and consolidating, you get your limestones, dolostone, etc. This bedrock map also, sorry if I'm blocking you guys over there. It also depicts the unit at the surface. So using this kind of layer cake analogy, it's important to remember that many of these units span the entire breadth of the state. So you can see these units cross all across the state, but from a groundwater perspective, it's typically only the first couple units that are of use or utility, from especially a drinking water perspective, because, you know, as you go deeper, obviously things get more saline. The first period to talk about is the Ordovician. So these are the oldest rocks near the surface in Ohio, 500 to 430 million years ago. This is a paleo map of what we think Ohio looked like at the time of the Ordovician period. It was near the equator, and it was in the shallow marine environment. Now, this is a large time span, 70 million years. So during those 70 million years, the sea level rose and fell, excuse me, and there's also tectonic activity. So it wasn't always shallow marine. At times, Ohio was in deeper water, or parts of Ohio was in deeper water. And other times it was in these kind of lagoon, kind of tropical environments. And what that means is when we have the lagoons and the reefs and the shallower water and all the critters dying, we get our limestones. When Ohio was deeper underwater and the energy was much lower, all the silts and the clays were depositing that were becoming the shales. So the Ordovician is characterized by these sequences: limestone shale, limestone shale, limestone shale. The limestone beds are typically pretty thin, so we don't have these massive beds of limestone because there's a lot of change. You get limestone for these smaller intervals and then shale on top of it. And what that means is it's pretty bad aquifer. So if you live down this part of the state, you want to be living, and you have a well, you want to be living in the valley, because then you're going to get a lot of yield out of your wells. But this rock does not typically produce a lot. And that's because you have these thin beds with this shale in between it that kind of prevents a lot of the downward movement. It also doesn't have a lot of storage. This is the Miami, you guys probably can't see that over there, I'm sorry. This is the Miami Shale and Grand Lake Formation. You can see the fossils, fossiliferous limestone here, and then the shales in between it. Here we have the Little Miami River. So I tried to put each of our 15 scenic rivers in this presentation, just as kind of a way to show these as they relate to some of our rivers. This is in Warren County, and Little Miami River runs through this Buried Valley, and again, I'll describe Buried Valleys a little bit later. So it's actually sand and gravel where the river is. But you can see in all the uplands that flank it, we have these blues and dark blues. These are areas of Ordovician bedrock with some till on top of it. So precipitation that falls in these areas typically tends to run over ground into the rivers, or takes these shallower pathways into the valley because the Ordovician is so interbedded and unproductive. That contrasts pretty starkly with the Silurian period, which came next, 430 to 395 million years ago. And this has some of the better and best aquifers in the state, especially the limestones aquifers. So here, instead of having these continuous changes of deposition where you get the limestone and the shales, it's mostly limestone, and the beds are quite thick. So the shallow marine environment with abundant reefs, you get the dolostones, limestones, evaporites, some shale in there, and it tends to get shaler as you move south. So the yields up in the north and the west, you can almost always get between 2,500 gallons per minute. You can get a lot more than that at a well, especially in some of the deeper wells in the Salina or the Lockport. And then it kind of lowers as you go south to where you're going to be getting more like 10 to 25. And then once you get down to Highland and Adams County, it becomes much shalier and the beds are not as productive. Here's the Sandusky River in Seneca-Wyandotte County. Not a lot of topography to speak of here, and it's also, the scale is we're much more zoomed out here. But I wanted to show you the bedrock units in the area. Moving from left to right, you kind of go up the layer cake and kind of forward in time. So the Lockport is the oldest unit here, and you move to the east with the Greenfield, the Tamaki, the Salina group, which is all Silurian limestone. The base of the Salina group in the Greenfield, there's a zone called the Newberg zone, which is kind of famous for drillers and people in search of water supplies. It's a very productive zone. There's a lot of solution features in it. So you can imagine, these carbonates, part of them can dissolve out. And as they dissolve out, they leave these pores through which groundwater can flow. And those make very productive aquifers. Moving to the Devonian, so we're really going through the years here. 395 to 345 million years ago, we had a lot of significant sea level changes. So parts of the Devonian we have again, deposition of these limestones, and other times, Ohio was in much deeper water and it's oxygen poor shales. So we have your silts and your muds. So you have the Prout limestone, the Columbus limestone, Dundee limestone, Delaware limestone, which are all quite productive. The Columbus is actually one of the most in the state for rock. And then dramatically you move over to the Ohio Shale, which is probably our least productive, least worst, I guess you could say, aquifer in the state. So the Columbus, I thought I would speak about a little bit in detail. It's a gray fossiliferous limestone, so there are fossils. It has thick to massive beds. So here's a quarry where you can see the Columbus. Some of you can see the Columbus over here, and then probably the Delaware above it. It has a lot of these solution features. This core shows the Columbus limestone without a lot of solution features, so there are parts of it that don't have these, but massive caves, a lot of buggy zones do form in the Columbus and can be quite productive. So you can see yields are almost always in the 20 range. 100 to 500 plus are very easily attainable in places, and you can have over 1,000 gallons. You can pump. I mean, if you imagine putting a well into this, or it being connected to a river, it's almost an unlimited volume of water. So what you're seeing here, this might take a second to kind of parse, are two maps of the exact same extent. So I'm showing the exact same viewing extent right here. This is one of our aquifer yield map that's currently undergoing publications. This won't be out for the public until probably December. What you're seeing is the Olentangy River here in Delaware County. And we have primary aquifer and secondary aquifer. So we map what we think is the primary aquifer people use. That's usually the highest yielding aquifer, unless for some circumstances it can't be used or is not widely used. Either it's too thin, it's too deep, you might have some natural water quality considerations. So right around the area of the Olentangy, you can see we have it mapped as the primary Columbus limestone. And then this is a Silurian limestone and the Devonian shale to the east. We also have these secondary aquifers mapped. If you think of a well, it's going to have an open borehole. It might be producing out of multiple units. Multiple units might be contributing to this river's flow. So we map a secondary aquifer at the same time. One thing to see here is that we have this map as the primary shale in this area, secondary Columbus. And what I've just said is that the Columbus is really productive and the shale is really unproductive. So why is the primary the shale here? Well, it's higher up in the column. So if you have you're putting in your house well here, the Columbus is down there, in our cape, but it just might be so deep that it's too deep for your average well, or it might be deep enough that the TDS is a little bit higher. But nevertheless, if you're putting in a municipal well field, or you're an agricultural user and you have the capabilities to drill a deeper well or do some treatment, it's down there. Another unit of interest in the Devonian is the Berea sandstone. Here you can see the contact between the Berea and the Bedford. So here's the nice Berea up here, and then the Bedford shale below it. And that was deposited along shores of the Devonian Sea. It's fine to medium grain. You can see the Berea here and here with the shale interbed. And the grain size again decreases as you move south. So you can get really good yields out of this in Northeast Ohio. It's quite productive. But as you go down towards Central Ohio, it kind of lowers and lowers. This is the Chagrin River. Chagrin, apologize if I mispronounce some of these. In this kind of pistachio green color is the Berea sandstone. Then you have this kind of bright red is where we have the Berea, Sunbury, and Bedford all mapped together. And then further down the column, you have the Ohio shale. Above it, you have Mississippian units. And what I wanted to point out here is that this is an aquifer map, not necessarily a bedrock map. So if you were, in the river right here, and you were to look at a stream cut and see some rock there, you probably wouldn't see the Berea. The Berea might be, 50 feet down, but it's the dominant aquifer there and the most productive one. And you can see this gets quite complex when you start layering all these different aquifers on top of one another, in addition to all this glacial material. The system and the interchange between these aquifers becomes quite complicated. Following Devonian is the Mississippian. This is a time of mountain building. This is when the continents, if you think back to like science class in high school, this is when Pangea was starting to form. The Acadian mountains were rising to the east of here. And as these mountains were building up, the rain was falling and washing all the sediment, eroding them all down. Again, if you think in geologic timescales of these 20 million years, a mountain rises up, and as the rain falls and washes it all down, it starts to erode away. All that sediment that's eroding off of these mountains is being deposited in Ohio. And where it's depositing in these river deltas and these near shore areas, you get this high energy environment with the sands all becoming the sandstone. And where it's further off the, if you think of a modern beach, further off the beach, you're going to get your shales and your mudstones. So most of the Mississippian rocks are not very productive, but there are a couple important units that I'll touch on. So you see yields here kind of between 5 and 25 with a couple exceptions. I'm not going to try and pronounce this. Well, maybe I will. Pymatuning? Pymatuning, thank you. These are some shales along Pymatuning. So there's actually a buried valley that runs through here. That's glacial material. The river doesn't always follow it. It kind of goes in and out of it. And we have Sunbury, Berea, Bedford here. So the Sunbury is a Mississippian shale, and the Cuyahoga next to it is a Mississippian shale. Then we have the Berea in there, and then the Buried Valley. This right image is a map of hydraulic conductivity. And that's an aquifer parameter that basically tells you how easily does the aquifer permit groundwater flow. So you think highly conductive, it allows flow. Less conductive, it does not. It kind of acts as a, it could be a confining layer, or it prevents the groundwater from moving either downward or through it. And you can see generally the shales are lower, the sandstone is higher, and the Buried Valley is the highest of them. The Black Hand Sandstone is a pretty important aquifer, especially in central and southern Ohio. This you probably know if you've ever been to Old Man's Cave in Hocking Hills. This is the kind of terrific big wall of sandstone you see. If you go to Clear Creek Metro Park with Wooden Rock, there's a really impressive showing of Black Hand Sandstone. It was deposited in deltaic or nearshore sand deposits, and it can be quite thick. So these are two maps. This is a structure contour, so this shows the top of the Black Hand Sandstone in terms of its elevation. And this is an isopack, which shows how thick it is. And it can be up to 330 feet thick in some parts down in Hocking County. And it's quite productive. So if you look at this core, you can kind of just tell even from here that's a very coarse grained sandstone. And you can imagine the pore space there is much higher than a shale, which is really tight and muddy. This is the Kokosing River flowing through Knox County. Kokosing again is in this valley, this glacial Buried Valley. So it's all sand and gravel throughout here. But if you get outside of the valley, just like with the Ordovician example, the main aquifer in this area is the Black Hand Sandstone. And if you look at wells in this area, they're all sandstone wells. It's very productive, it's very thick, and the drillers also target it pretty intensely. Underneath it is the Cuyahoga. It's technically a member of the Cuyahoga, but the Cuyahoga is the shaly part of it. So you can see kind of in the topography, as you move down off these hilltops into the valley, you get down to the Cuyahoga. And then we have this sandstone dominant areas of interbedded that aren't Black Hand, but are most likely Logan, another sandstone unit that's not quite as productive. Next is Pennsylvania, so 325 to 280 million years ago. This is a terrestrial swamp, shallow marine environment. You can imagine like a prehistoric jungle where, the trees are all falling down and, fungus hasn't evolved yet enough to actually decompose them. So you just have all these trees falling on one another. There's cockroaches like, the size of this screen. It's probably pretty hellish to live then. All these were deposited in coastal wetlands and deltas. And we have interbedded shales, siltstones. This is where all of our coal comes from, the Pennsylvania. And the yields in these aquifers are typically pretty bad, except there's some important exceptions in the Allegheny and Pottsville group. The Conemaugh and the Monongahela are not productive. One of those is the Pennsylvania Sharon sandstone. This is Nelson Kennedy Ledges State Park, which is a really good place to see Sharon sandstone. It was deposited as a river alluvium. So if you think of our rivers today, you look down the bed of it, you see all that sand and that gravel down there. Give that a good 300 million years with enough pressure and heat, and it'll turn into something like this. So it's a conglomerate or a sandstone conglomerate. You have these really big, like gravelly pieces in it that are fused, and then the little sand grains in between it. And it's quite porous and widely used as well. So you can see 100 plus gallons per minute in some places, but typically 10 to 25. Here we have the Cuyahoga River in northern Portage, Portage County. And this on the left is again primary aquifer. Everything in the yellow is Sharon sandstone. That's where the primary aquifer is at Sharon. And then we have some buried valleys going through. You can see the river follows that valley at some point, but actually then goes over the sandstone in parts. Again, there's probably a lot of alluvium there, but the actual aquifer is the sandstone. This right figure is what we call aquifer yield. So that's kind of the amount, if you were to pump it, or the amount you could say could contribute to a river reasonably without there being a significant decline in the water levels. You can see it's the highest in these valleys and then low in these other units, but the Sharon sandstone actually is quite productive, especially along near areas near the river because of the induced recharge. And then even some of these other areas, you can see you get 50 to 100 gallons per minute out of it. And then coal is also, whether we want it to be or not, is an aquifer. These are coal wells throughout the state. So these are wells that are actually reported as producing out of the coal primarily. They're typically older wells, because a lot of that's not allowed these days. Or, you have these interbedded sequences where you have shales and siltstones and sandstones and then coal. It sometimes is such that the coal is actually the units that's producing, that's contributing to your well. Here's a Little Beaver Creek. You got Columbiana County. And you're seeing the Conemaugh in yellow, Allegheny Group in the pinks. All these little blue dots are water wells, and all the black dots are water wells that are reporting to be producing primarily out of the coal. Now, obviously that requires some treatment. You don't want to be drinking just the cold water, but and they're also older, as I said, typically. The wells, that is. And then finally is the Permian. We don't have any scenic rivers in the Permian, so I couldn't find one for this one, but it also doesn't take up a huge part of the state. And it was a mostly terrestrial, tropical environment, interbedded mudstone, shale, siltstones, really poor yields. You want to be near the valley if you want to drill a well out here, or even for the rivers. Probably what's contributing more is the overland flow. It's not this aquifer. And kind of an interesting thing about the Permian is at the end of it, there was an extinction event caused by volcanism where 98% of all life on Earth was eradicated, which is kind of incredible to think about. So I'm going to skip some time. We're now going to 2.6 million years ago. So now we're skipped about 200 million years. And again, with the Cenozoic and the Mesozoic, early Cenozoic and Mesozoic, we don't have rock record for them in Ohio. So now we're talking kind of, the landscape looks like it does in modern day. We have our glaciers, and all the glacial aquifers are formed as a result of this glacial activity. Here we have the Quaternary geology map that shows some of the glacial features. You can see some of these moraines. You can see this ancestral Lake Maumee deposits, and a lot of these different outwash trains and buried valleys, which I'll talk about in a few slides. And most of our aquifers, our glacial aquifers, were deposited in the Pleistocene. So this is kind of the classic ice age. This is one of our illustrations from our geologic series that has all these different periods. I encourage you to get on our store and look at these. These are some pretty cool posters. And the important thing here is that all this material is deposited or affected by the glaciers. So as the glaciers moved in, they scraped up the land surface, either the rock or whatever was there before, churned it all into this diamicton or till, so this clay matrix with all these little sands and gravels in it, and then left it there. They would proceed and stop, form these end moraines with these little lumps of ground where all the deposits would accumulate. They retreat a little bit, then they proceed and retreat and proceed and retreat. And as they're doing that, they're kind of, churning up and mixing all the unconsolidated material. And then importantly, as they're retreating, they're not just moving, they're actually melting. So think about this big wall of ice here. When this thing retreats, it's melting. So there's trillions and trillions and trillions of gallons of water that are coming off these glaciers and running out. And as it runs out, it washes all these fine material away. So if you have this till of clay with sand and gravel in it, and you have trillions of gallons of water being, it washes all that clay and that silt away and leaves these coarser materials that we call outwash. But before that even happened, there was an ancient scenic river in Ohio known as the Tays. This is a map done by Wilbur Stout in the 40s. He did this by horseback, and he got it pretty good too. I mean, this map holds up today. There's parts where I think we improve it. It isn't exactly right, but it's really impressive what he accomplished with this map. So the Taze was there before the glaciers came in. Its headwaters was in North Carolina, and it flowed west and north through the state, out this way and then down to the Gulf of Mexico. It was a mature, low gradient stream, so it had been there for a while by the time the glaciers came in. And we see evidence of it today. So here's Big and Little Darby Creek in the Pickaway, Franklin County area. This is a bedrock topography map. So instead of the land surface, this is showing the surface of the bedrock. So we make this using well logs, geophysical techniques. And you can see evidence of the Taze. So it came up from the south here and flowed west along this and then west up out of the state. This is Madison County, and if you've ever driven through Madison County, it's quite flat, right? You don't see these 400 feet valleys in the middle of it. But if you took a really long stick that was really sharp and like walked along and poking it down, you suddenly start poking that thing down 400 feet, where the old Taze River used to flow. But then the glaciers came in and kind of messed all that up. So there's a pre-Illinois glacier, glaciation that happened about 2.5 million years ago, and that dammed the Taze River. So the river was happily flowing this way. This big glacier moved in and dammed it. So suddenly it's facing this big wall of ice, and the flow of it actually reversed and formed a big lake back here called Lake Tite. And then as that lake formed and just filled up, the water started to kind of overfill its drainages and then spill out and initiate these new drainages. It also deposited all of these silts and clays where it's backing up, and you still see evidence of that down in Southeast Ohio. And that new drainage system that formed, we call deep stage drainage, so it's an interglacial drainage. We have regional uplift, and then all this water pooling from the Taze now forming its new rivers. And it reaches this new equilibrium, which is, I think, really kind of cool. So the glacier was, not necessarily always right there, but up there. And we have this new drainage system forming. The Middletown and Newark rivers were big ones. The Newark, followed the Scioto in some places and then deviated it from it quite a bit. We actually think it went through a little bit further west in Licking County. You can pick, there's probably 400 or 500 feet down to bedrock in parts of western Licking County. But this map captures the general flow of it pretty well. This is the Stillwater system. I'm going to move over here so maybe you guys can see for a little bit. So this is in dark Miami County. On the left is the modern landscapes. This is what it looks like today. This is the land surface. It's fairly flat. You have the rivers going through here, eroding away some of this material. On the right is a drift thickness map. So takes the difference between the land surface and bedrock and tells you how thick the drift is there. And what you can see right away is nothing that you see here is necessarily captured, right? There's this network of different pre and interglacial drainages under the ground that you don't really see from the surface. The Illinois glaciers were next. That was 300, 130,000 years ago. 3/5 of the state, about 20 feet of drift. They were not as thick as some of the other glaciations. And when they melted, they didn't produce as much outwash and really good aquifer deposits as some of these other glacial pulses. So the Ashtabula, this area was actually not glaciated by the Illinois, but I wanted to put it here just to show you all these different glacial, approaches and retreats, and all this melting layered all these different deposits and created a very complicated glacial landscape. So here in this one figure, you can see there's beach ridges from the ancestral Lake Maumee. There are these glacial complex deposits that are probably end moraines from the glacier stop. One of the glaciers stopped there at one point. Then you have modern streams going through that are cutting through all these materials and reworking them. Brown dots here are shale wells, and then orange dots are sand and gravel wells. So you can see the sand and gravel wells are pretty well associated with these glacial complex areas, but it's not really clear cut. There's a lot of fuzziness to it. because there's still glacial material here, but typically it doesn't have, a lot of sand or gravel in it. And then the final glaciation was the Wisconsin, so 24,000 years ago. So this is like a blink of the eye ago geologically. So this just happened. And it was a thick and more massive glacier than the Illinois, and it produced really large quantities of outwash. So when this thing retreated and melted, the amounts of water coming off of it were truly incredible. And as that water melted, a lot of the meltwater followed some of the existing channels. So they didn't always cut new ones. There's already a valley. The meltwater tended to typically follow that existing valley. So you can see the Muskingum, Tuscarawas, Muskingum, Hocking, Scioto, Little Miami are all at this point pretty well established. Here's the Mohican, kind of right at that margin. Left is a superficial geology map showing just the units that are above bedrock in their thicknesses. So we have some tills. So that's again that matrix of clay with sand and gravel in it. We have some outwash terraces. So these are areas where outwash was deposited and has not yet been eroded or will not be eroded. Alluvium, it could be modern alluvium, or it could be alluvium that's both modern and glacial. And we have some like organic peats and silts and clays that are being from times when the glacier has blocked water and it's kind of pooled up into a lake and deposited silt. On the right is a map of the Vados zone. So that's all along this glacial margin. So you can see anything that's like dark red here has not been glaciated significantly. And the Vados zone is just anything from the water table up to the soil profile. So it's essentially the material that precipitation has to go through to reach the groundwater. And it has pretty important implications as to how much recharge the aquifer might get or not get. So I guess the point here is that you can see it's quite complicated, and there's all these different glacial depositional environments create this environment that's at times difficult to understand. And that takes us to the modern landscape. So it's a digital elevation model. This is what Ohio looks like today. You can see it's mostly, relatively flat in the glaciated areas, and then in the unglaciated areas, you can see it's more what looks like it's mountainous here. You can still see some of these moraines coming through, so not all of that has been erased. And then modern streams tend to follow most of the historical valleys, but not all of them. And then the Tays, so that pre-glacial valley, you can actually still see evidence of an unglaciated area here. But then once it hits the area affected by the glaciers, it kind of dives in the ground and goes out sort of that way. This is just a figure that kind of gives you a sense of how these things fit in the landscape. So it's it's obviously a cartoon of it, but outwash and cames, these deposits are the sands and gravels deposited by the glaciers that are still in these terraces. Cames are a different landform. You have all these different sands and gravel aquifers throughout the state. And a lot of the modern rivers have these deposits around them. And then buried valley, I've used that term a couple times here, so I thought I'd at least define it. This is an area kind of like the modern Scioto River, which had sands and gravels in it, probably pre-glacial. Then as each glaciation came in, deposited the till and melted, more and more sand and gravel was deposited there, and more of these clays and fines were washed out. So it has a real thick sequence of very productive sand and gravel. But in other areas, like shown in this diagram, you have either pre or interglacial sand and gravel deposits that were later then covered up by the till and the clay and not reused, for lack of a better term. So they're truly buried. And you'll go through a bunch of clay that is not productive and is kind of a confining layer or weakly confining layer, and then reach this buried sand and gravel. And that still has interplay with the rivers and streams. So it can still act as an area to recharge or be recharged by our modern rivers. And then the last one I wanted to touch on is glacial complex. We have glacial complexes throughout the state. This one we call the Machindo. I don't like that name, but that's the name that it's been given. And that's a complex kind of really heterogeneous sequence of deposits. So you'll have clay with little lenses of sand and gravel in it, or little seams of sand and gravel in it, covered up by more clay, and then another lens, and it's really hard to kind of track it laterally and horizontally and vertically. And this is Northwest Ohio, so this is Williams, Fulton, Defiance County. This is a really busy one, but I'll describe it to you. Areas mapped in green are what we're calling glacial complex. So you can see the green is basically the Machindo. The brown is shale. And the greens are both limestone. And here's the modern Maumee River running through it. The dots on here are, again, water wells. Orange are sand and gravels, brown are shales, and these greens are limestones. So what you see in the Machindo is that it's quite thick in the northwest corner of our state. And then as you go to the southeast, it thins and thins and thins. And you can see that in the wells. Up here, you have only sand and gravel wells. And as you go further in southeast, you start to pick up some shale, and then it's predominantly shale here until you hit the Maumee River. So a lot of the flow also, the groundwater flow direction is towards the Maumee. So a lot of this, gets recharged up in Indiana or Michigan, flows through the Machindo, and then discharges into the Maumee. And then, a little over, I think. I just wanted to capture the last two scenic rivers. I couldn't get aquifers specifically for them, but I thought I'd get some interesting figures for them anyways. This is the Grand River. Here we have the aquifer yield. This is for all the aquifers in the area. So you can see there's a wide range from Sharon sandstone down to the worst Ohio shale, but mostly the direction of flow is kind of towards the Grand River. And on the right, we have again the hydraulic conductivity, which kind of tells you how easily that groundwater will flow through those materials. And you can see they're loosely correlated, but not perfectly. There's areas of better yield that have lower conductivities, but mostly the more conductive the material is, the higher it will yield, and more it will contribute to the rivers. And then finally, I put a slide for groundwater vulnerability in Conneaut Creek, excuse me. This map sort of sums or compiles all these other things I've talked about. So for these maps, we take the aquifer itself, the vadosome, the soil, the topography, all of those parameters, and weight them, sum them up to give a qualitative and relative number called the index that tells you kind of how vulnerable that groundwater is. So it's a very qualitative map, but it gives you an interesting perspective, and it also has some regulatory impacts. So OEPA used it for their source water protection areas and so forth. And in conclusion, I'll just say, this is that map in full. Ohio's diverse aquifers result from complicated hydrogeologic history. So these millions of years in the different depositional environments, understanding them can help you understand the characteristics of the aquifer and how it relates to surface water features. If you have specific questions about an area or a specific aquifer, feel free to contact me or the survey. If I don't know the answer, I'll direct you to someone who does. And thank you again.
Thank you, Craig. We have time, 2 minutes for some questions. If I have some questions, Bill, I see you back there. I wish we had a second microphone.
My question is, what are we doing to protect it once you get shot at the Great Lakes Street? So, what are we doing to stop people from putting big straws in it, pumping it out, and exporting it to other places that need water in the state?
Sure. This gentleman was asking, what are we doing to protect the quality and our resources, especially in reference to buried valleys that we have in Ohio? I can speak from a quantity perspective. So ODNR does not handle groundwater quality concerns. I'll just talk about it. OEPA would probably be better to answer the quality considerations. But for quantity, we do a lot of mapping,
monitoring, modeling of these aquifers. I think it's on, try that.
Oh, thank you. So from the Ohio Geological Survey, what we want to do is we want to map these aquifers. We want to model them. We want to monitor them. So we have a network of observation wells, and we do build groundwater models that give you kind of estimates of what these aquifers are capable of producing. So when it comes time for their use, so we promote the wise and responsible use of these resources. They won't be overused. It's a concern that I think is highly in the public's eye at this time. I think they're seeing what's going on out west, which is that the West is having a lot of issues and concerns with groundwater and water in general, which we're going to hear in the next presentation. And so Ohio's in a pretty good place right now in terms of our quantities. What we need to do is continue to monitor them, map them, understand them, so that from a planning perspective, we can be prepared for ups and downs of the hydrologic cycle. I think that's a good question. I think that's a question that most citizens of this state have, and that's the most common thing people ask is, what are we doing to ensure that this resource, we can sustain it?
Is there any protections in place to keep other people from drawing our groundwater and taking it, like shipping it out west?
The question
that was
was-
part of Bill's question.
The question was, is there any protection there to keep people from using it and pumping it elsewhere? There are interstate and international policies for that. There was a case in Ohio in 2018, I think it was, where there was some interest in piping some water from Williams County to Toledo, and the public outcry was such that that project got shut down. I don't think economically it works at this point, but more work and more legislation or interest on the part of legislators is certainly needed to protect these resources. We're blessed, I guess you could say, with abundant groundwater at this point.
We have one more question. Dr. Miller?
I'm just curious what the age of our waters is. Out west, the Oklahoma, California, they're mining glacial waters that are 10,000 years old. How old is our water?
That's a good question. So the Ogle, I'll repeat it. He was asking what is the age of our water in Ohio, and the Ogallala is kind of an interesting one. That's you used a great word, mining. That water is not being recharged. So the groundwater in the Ogallala is there, and when you use it, it kind of is gone. All of our aquifers are being recharged. So, the degree to which they're being recharged depends on the precipitation and all these other factors that I was going into. And the actual age, so if you were to, take a drop of water out of your aquifer, really depends on the aquifer. And I hate to kind of sidestep the question like that, but in places, it could be a pretty shallow pathway, like I said, in the Little Miami. If you take some of the water right out of that aquifer, it may not have fallen, too long ago in human terms. But there are places where deep flow paths, we're talking thousands of years. So it really varies from place to place in the state, from aquifer to aquifer. Thank you.
Okay, thank you again, Craig. Craig, you gonna be here for a while?
Yep.
For other questions? Okay, great. So feel free to ask Craig the other questions you might have. We now have a 15-minute break, so we're gonna reconvene at 10:30. I just wanted to point out that you should all have a stack of these programs for the symposium on your table. Please look at those. Look at our speakers, our great lineup of speakers, and some of their background. When I'm introducing them, I'm just giving an abbreviated bio sketch. So there's more information about our speakers in here. Feel free to get some coffee, refreshments up there, and look at our displays from our sponsors and poster sessions, and we'll get back together here at about 10:30. Thank you.
Get a little high on the end.
for groundwater. Thank you.
Thank you. We're trying to find the clicker and the laser pointer, but I'll go ahead and start talking while we figure out where that ended up. And that means that the stress on our urban rivers is also increasing. And historically, we've tended to build our cities along waterways. That makes sense. Water is an important resource for cities. It's important for transportation. It's important for drinking. It's important for waste removal. So we've used these in a lot of different ways. And so as our cities are growing, our density is increasing, we're putting more and more stress on these systems. Now, when I approach this thinking as a hydrologist and a biogeochemist, I think of lots of different ways that cities can be affecting the rivers and the streams that run through them. We change them physically, we channelize our streams, we bury them underneath the ground, we line them with concrete and prevent interactions with the groundwater and with riparian zones. So we really make a lot of physical changes to these streams. But then also change them chemically. We have various storm drains where runoff from fertilizers or oil on the street, for example, can get into the rivers. We have treated wastewater that gets to the rivers, all these different ways that chemical changes get added to these streams. We have a lot of different emerging contaminants. We hear about PFAS and plastics and things like that. All these can change the chemical composition of these waterways. And then we change them biologically. We introduce invasive species as riparian plants or as fish or insects in the streams. We also do things that stress these species and remove them. And all these all interplay together. The physical, the chemical, the biological changes all interact with each other. So when we're thinking about these streams holistically, we have to think about how one of these is going to affect the other and drive these changes. Now, if I go to Google and I image search urban hydrology or urban runoff, I tend to get images like this. So we tend to see, okay, so when we urbanize, we put impermeable pavement down. So when it rains, instead of a lot of infiltration down into those aquifers we were just hearing about, it's running off the surface instead. Or if I look at stormwater diagrams, I see, okay, it's raining on the roof, it's running through the gutters, it's running along the ground, it's going into drain, and that drain's going into the river. What's noticeably absent on these diagrams when I do an image search is groundwater. So we have this tendency, if we think about how we draw our conceptual diagrams as imaging as a representation of how we think about these systems, we have this tendency to conceptualize urban streams and urban rivers as pipes. We think, okay, so, oh, wrong button. So we have various runoffs that go into a pipe, that pipe goes into the stream, and once the storm drains go in the stream, that water is just being carried down the river and that's it. So if that's true, then if we want to try to think about managing urban water quality, a lot of the focus should just be at these pipes. But if I think about work in catchment hydrology and natural systems, we know that in these systems, the streams are definitely not pipes. We know it's not just solutes go into a stream and the stream goes down. We know that as a river or a stream is flowing through the landscape, it's constantly interacting with the groundwater. I had a colleague who tends to say that surface water is just groundwater that's temporarily above the ground. And so if we're thinking about these interactions, if we want to understand the controls of the surface water, to really understand these interactions with the groundwater and how the water is moving back and forth. And just because we've urbanized our landscapes, it doesn't mean we've gotten rid of all of those interactions. So for example, I like to think about urban rivers, and part of the reason that they're really fun but really challenging is they're this complex interaction of this natural hydrologic system that existed before we built our cities. And then we added on our human engineered hydrology on top of that. So we have our natural flow paths that were already there, and then we added new flow paths with all these sewers. So a lot of people call these sewer sheds, the idea of, okay, what drains into the sewer, similar to the idea of a watershed, but now we've had these human pipes on top of it. So what makes urban hydrology research really challenging but really exciting is figuring out that interface between this human engineered environment and this natural system that was built on top. So as a biogeochemist, as someone who studies chemistry and water, I tend to think of, okay, if I'm looking at a stream and I'm sitting here in my urban stream, this is a really nice looking urban stream, right? There actually are fish in there. And I'm thinking, okay, if I'm measuring high levels of nitrate in the stream, and I want to know where did that come from, there's a couple different things I need to think about. One is, what's the original source of that? One is, what flow path could that have taken to get to the stream? And then one is, what are the in-stream interactions? What could be removing the nitrate along that flow path? What could be adding to it? And so I think about what are these different things that control my chemistry. So I think about, okay, if I'm thinking about flow paths, I could have groundwater feeding in, I could have flow from upstream, I could have overland flow, and I can have precipitation. And the cool thing is that every one of these has different chemistry. It's running over and interacting with different rocks, different plants, different soils, and these different flow paths are going to have different chemical constituents. So I can use water chemistry to start to identify which of these flow paths are more important, which ones are contributing at these different locations. To take you out to Utah. So this is the Great Salt Lake, the star is Salt Lake City, and this is the Salt Lake City metropolitan area. And Salt Lake City has 7 big canyons of rivers that feed into it, that are the main, all the drinking water source for Salt Lake, which feeds into the Jordan River, which is one of the main sources of water for the Great Salt Lake. We're going to be focusing on one of these creeks. It's called Red Butte Creek. It's this little one right here. If I zoom in on Red Butte Creek, Red Butte Creek starts in the mountains and is in a protected area that's maintained by the U.S. Forest Service, so only researchers are allowed in there. So it's a fairly, it's not pristine, nothing is pristine, but it's a relatively undisturbed stream system. As soon as it flows out of the mountains, it flows immediately into a dense urban area. It goes right through the University of Utah and into neighborhoods that have been in existence for over 100 years. So it's going in a really quick gradient from relatively undisturbed to significantly urbanized. This is the urban rivers I started working in. When I moved to Ohio, I suddenly realized most of our urban rivers start as agricultural drainage ditches and then move into urban systems, so I'm having to completely reframe my thought of these gradients, but it's been really cool to think about it in that way. So this kind of examples of where Butte Creek looks like. Up in the canyon, we've got a pretty natural looking stream. We've got some erosion in the banks, but natural interaction, there's no control about where it wants to go in the channel. At the mouth of the canyon, we start to see some urbanization occur, and then the last kilometer starts to look like this. So we're really changing what the stream looks like as we go through this system. So at that canyon mouth site, the USGS has been collecting water samples for over 50 years. And so we have long-term data sets for flow and for some of the basic chemical constituents. What we see is that Red Butte Creek is what we call chemostatic. And what chemostatic means is that over large ranges of discharge, so we're going from less than 1 cubic feet per second to 100 cubic feet per second, so big changes in discharge, the water chemistry is not changing very much. And this is particularly looking at various cations that are mostly sourced from bedrock. So what we're seeing is that the chemistry is largely the same over these huge changes in discharge, just telling us that this is a groundwater-fed stream. Essentially, when the discharge goes up, there's more groundwater going in, and because the groundwater is consistent in the chemistry from its interactions with the bedrock, the chemistry itself isn't changing with that increase in discharge. So suggesting we've got this really mostly dominatedly groundwater-fed stream, it's not really changing chemically. But when I zoom in, I want you to look at mostly this plot of the stream. This is several locations along Red Butte Creek over lots of samples. We see with chloride and with sodium, pretty consistent, really small variability over time, pretty consistent levels, and then all of a sudden, at this lower site in the urban system, it totally changes. So it's really chemostatic, and then suddenly it's really not. So we wanted to dig in and figure out what was happening. Why would this sudden behavior change occur? So we got together with some other scientists and we developed a bunch of synoptic surveys. So we went from the start all the way down here. We sampled at every one of these dots all in one day, trying to understand how things were changing as we went up and down the stream. We did this in several different seasons to see across the lake. So this is looking at the different data we have, and in Utah, snowmelt is really one of the big drivers of hydrology. So I have categories as pre-melt, which essentially means the snow is still on the ground. Snowmelt, which is usually our highest flow, we've got this giant pulse of water coming in as that snow is melting. And then post-melt, which was summer, there wasn't any snow on the ground anymore. And first, we're just looking at discharge here. And this is the canyon, this first 5 to 6 kilometers. And what we see there is that pretty consistently from the top of the canyon to the bottom, we see slight increases in discharge. We don't see huge variability across the seasons. So what we're really seeing here is we're seeing a gaining stream. We're seeing a stream where groundwater is feeding into the stream As we're going down the canyon, there's more and more groundwater entering. You can imagine the streams getting, lower and lower compared to the water table. And we're not seeing huge variability. Then as we go to this upper urban sections, this is that University of Utah, that first big area where the stream comes in, all of a sudden it's totally different. So within any individual season, from this section to this section, it's losing. So we're actually seeing stream water feeding back into the ground. One of the big clues we have for that, which I'll show you in a minute, the University of Utah has a big pile of road salt that they store pretty much next to the stream that's next to a storm drain that goes into the stream. We don't see chloride increase in this section, which is kind of weird to think about. And that's because this is losing. The water in the stream here is really heavily feeding back into the aquifer. We also see huge variability. So we're seeing really big differences in surface input and groundwater input. It's causing huge variability across the seasons and flow in this location. Then when we get down to this bottom area, it's very different. We go back to seeing evidence of gaining, so going up in discharge from here to here, but we go back to low variability. So we have these sort of three different hydrologic regimes as we go along the stream. We then looked at water isotopes, and for those of you who aren't familiar with this, oxygen can either have a weight of 16 or a weight of 18. The vast majority of your oxygen atoms have 16, very small fraction is 18. And so when you look at water molecules, oxygens that are 16 are going to evaporate a little bit faster than oxygens that are 18. Oxygens that are 18 are going to rain out a little bit faster than oxygens that are 16. So we can actually use the ratio of our 16 to our 18 oxygens in our water molecules to look at different sources. Rain that fell at different times is going to have a different ratio. Water that's been evaporating in the stream is going to see an increase in its percent of 18s as more evaporation occurs. So I can use this to trace differences in sources of water. So as I go through the canyon in this gaining area, what I really see is this slope is evidence of just an evaporating source. So I see a stable source. I don't see a big shift in my isotopes telling me I have a different source of water. And I just see this very slow increase in my percent of O18, which just tells me that once this source has gotten into the stream, it's been evaporating a little bit as it goes downstream. Utah is not humid. It's not really surprising we have some evaporation happening from that stream. When I get to that variable source, I see a lot more variety in my O18. So we can see a bigger range of O18 values, which is indicative to me of these sort of different potential sources of water mixing in this location. And when I get down here, where I'm getting to the smaller range in discharge, I'm also seeing a more stable source. I'm seeing I'm converging down to less variability across my seasons, and yet I'm still seeing some sort of mixture of this and this kind of mixing together. So I've got this idea of sort of stable evaporating source, a variable source, and then moving back towards a stable source of water. Then I'm adding chloride in. Chloride is a common indicator of urbanization in places that put down road salt. And Utah is one of many places that do that. And we can see chloride concentrations are very low and very stable up here. We're not putting road salt where we don't have many people living. We don't have a road up there. There's a little dirt road. We could barely get our pickup truck up. That was about it. Then in this upper urban area, in spite of this big increase, in spite of the university having a big road salt pile, we don't see a big increase in chloride in the system. We have a bunch of storm drains that drain parking lots that flow right into the stream in this location. And in spite of all of that, we're not seeing a big change in chloride. It's not till here, when we get to this new stable source, this new gaining system that looks like groundwater, we suddenly see a really big change in chloride, a big increase. And so if we think of this together, we're kind of thinking, okay, we've got this evidence of this stable groundwater that's not contaminated by human activities yet down here. We're seeing this mix of sources here, and then we're seeing this evidence of something's really changing in the system. So what could it be? So we look at some other, now I'm taking each of these three different regions and summing them together in a bar plot. So the blue is all the canyon samples all together, the red is all that upper urban, and the purple is that lower urban section. And I can see my calcium really changes. Calcium is mostly sourced from your bedrock sources. So we're seeing the sort of really big increase in calcium concentrations. Now that lower urban area is on a fault line, and it's when the Great Salt Lake was a bigger ocean that was down there. So there's gonna be a lot of water, a lot of unbroken up limestone that can create a lot of calcium for your water. And if I look at my carbon, my organic carbon, my nitrate, and my DON, I see nitrates really, really low in these areas, and then I suddenly jump up in my nitrate concentrations. Probably an indication of fertilizer, animal waste, anything like that could be increasing, but why is it suddenly high? My carbon's pretty low, my organic nitrogen's pretty variable. The cool thing is in this location, there's a whole bunch of little seeps of groundwater that's coming out that we can sample. So we can easily get samples of what the groundwater looks like without having to dig wells, which is really nice. And what we can see is, look, this new calcium concentration matches the calcium we see in our groundwater. So there's a lot of evidence there that what's coming in that location is the groundwater. Groundwater there is also high in nitrate. And so there's evidence here that, okay, this new system that's now feeding down here is now this nitrate contaminated aquifer. What's cool is if we look at the nitrogen and the carbon, we know that denitrification, the way that nitrates removed from surface water systems and groundwater systems, is largely a microbial process that needs to happen when there isn't oxygen. It needs carbon as an electron receptor. And so we know that often the denitrification rates can be limited by how much organic carbon is present. And so we can see that the groundwater is actually really low in organic carbon. What we think is happening is these microbes are trying to denitrify, but they're running out of carbon. So the carbon's pretty low, which is why we're driving down the carbon concentration here in that lower urban section, while we're still seeing this increase in nitrate. And we can see evidence that those microbes just ate up all the organic nitrogen, which is the easiest source of nitrogen first. So we're seeing this real evidence that this new water source that's changing our water chemistry so much is this alluvial aquifer that now has urban contamination in it, where that aquifer didn't have it up higher up the mountain. The cool thing about being able to work in urban environments, which was sort of an oh no what happened and then we turned out to be really cool, is that sometimes the city turns off your stream. This does not happen in normal systems, but it creates a really cool experiment for us. So we went to a sample. And these had labels on my computer, so different times of sampling doesn't really matter for this graph. We started sampling these gray dots, and we started sampling, and we were like, okay, this is May, and we had a record snowpack in winter, so why don't we have any water in our stream? We got a little bit higher, we discovered the city had actually turned off the stream, so this is normally underwater, you can't see it, but they needed to do some maintenance work in some of these sewage areas or tunnel areas underneath the stream, so they diverted this creek into another stream. So what this meant is we actually were able to then go walk this dry stream bed and see what we could find. And the really cool thing is, as we kept walking down, we found the point where groundwater was starting to upwell into our stream bed. You don't normally get to see this. It was really exciting. Like, you know, it's happening, but it's usually doing it underwater, so you can't see it. But we actually found, all of a sudden we saw groundwater start to upwell. And as we got further downstream, we saw more and more groundwater coming in. And we can measure that groundwater, and it completely matched the water chemistry of those seeps. And it matched the location where we start seeing these changes in water quality. So, you know, at first we were like, oh crap, we went to the sampling and the city turned the stream off, but it actually turned out really useful. It let us really ground truth what we thought we were seeing. The other cool thing we did is this is sensors that measure every 15 minutes at that downstream site. And this is just stage, so just height of water. And then this is the nitrate concentration. And if I'm conceptualizing what's going on here, I'm having a mixture of surface water and groundwater. The surface water coming from upstream, we know is low in nitrate. And this groundwater coming in from that aquifer is higher in nitrate. So when I see the high nitrate values, I'm having more groundwater. When I see it low, I have less. Now, a little bit upstream, there's a really old cemetery that has some water rights to this stream. So periodically, they divert a fraction of the stream to run the sprinklers in the cemetery. And I can actually see changes in my water level from when that cemetery turns their sprinklers on and off. So when they turn their sprinklers on and divert water from upstream, the level of my stream drops because there's less water coming in from upstream. When they turn their sprinklers off, my water level goes back up because now that water isn't being diverted. And I can see my nitrate having a complete opposite reaction to that. So when they divert some of that surface water in the cemetery, my nitrate concentration goes up because there's less clean surface water to dilute that contaminated groundwater that's coming in. When they turn the sprinklers back off and there's more surface water coming down, my nitrate concentrations go back down because the surface water has less nitrate than the groundwater. So this is one of those really cool examples of, oh, hey, we have this natural hydrology that's happening, and we have these human engineered things we added on top of it. It's totally changing how the system works. Apparently watering dead people makes a big difference in your stream quality. I really, 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 really want to figure out how cemeteries are affecting groundwater quality. That's a whole different, ball of wax. So we used our isotopes. I didn't want to bother showing you all the nitty-gritty details of this, but we did a general calculation. What we said is, okay, up in the mountains, we have what's called mountain recharge. So we have clean groundwater from snowmelt, from the river that's feeding into the groundwater, into this aquifer. And some of that aquifer is feeding into the stream as it goes downstream. And then in this upper urban area where we're variably losing water back into the groundwater, there's a lot of contaminants that are in that. There's all these storm drains that are draining parking lots and things like that. And there's lots of fertilizer applications, and all of that is getting into the stream, but the stream is a losing stream. So all that's getting into the stream is going into the groundwater. So we're adding these urban contaminants into that aquifer. And then as the stream gets further downstream, now that I have this urban aquifer that now has these urban contaminations, and it's feeding back into the stream. And we estimated that at that location, that aquifer is about 20% urban recharge water, about 80% water from the mountains. So it's kind of sort of ballparking sort of what we're seeing at that location. We then went around and we just kind of were like, okay, are we on the right track here? So we took a bunch of samples. We went out when it's raining. So we were all driving around with water sampling kits in our cars because it doesn't rain nearly as much in Utah as it does in Ohio. And we kept, the whole summer we were trying to collect rain samples, we kept watching these storms come in and literally divide and go south of our watershed and north of our watershed and avoid our watershed. Lots of fun and adventures. But we did manage to collect some storm events. And so we went around to parking lots and we found places where it was like getting towards a storm drain and we collected some water samples. We lowered bottles down into places where we could actually lower down into storm drain systems and collect water samples. Because it was off the roofs of buildings, runoff off of some turf fields. So trying to think, what are the different ways that water ends up in our sewer shed, that water ends up in our stormwater control systems? What are the different chemicals that these different systems contribute? So I can imagine the water coming off the parking lot is going to have a different runoff than what's coming off the fertilized turf walk. And so I made a bunch of different measurements, and obviously we couldn't figure out the percent contribution of each one of these, but we could see that, yeah, the measurements that we're getting are kind of in the range where I can imagine if I mix these numbers together, I could get this number that I'm seeing in my aquifer. And so, more and more evidence that, yeah, we can explain what we're seeing based on what's going on in our river. So in sum, what we found is we found really 3 distinct hydrologic reaches. We saw sort of a gaining, relatively clean, evaporative source. We saw this really mixing seasonal system, sometimes losing, sometimes gaining, usually losing over the time period, but huge variability in how much surface water or groundwater is coming in. And then we saw this lower system where we're back to a gaining system, back to groundwater fed, but now we have this urban contaminated aquifer that's really changing the chemistry of the stream in this location. And so we're seeing this urbanized shift to a subsurface biogeochemical environment that's feeding into that stream. So coming back, I showed you earlier, we have all these images of thinking about the urban system as a pipe. And so if we think about urban hydrology and we think about how do we understand these urban systems, if the stream was a pipe, then there'd be no flow boundary between the stream and the watershed. And so any contamination we see would be at the time scale of an event. It would rain, it would carry contaminants into the pipe, into the stream, it would go to the stream, and you wouldn't see any impact after that from that storm system. What if we thought just a pipe-radic exchange, just of, okay, the stream is coming down, and it's just exchanging a little bit with, subsurface water just next to the stream. If that was happening, then the scale of our impacts would be meters. We only have to worry about what things look like within a meter or two on either side of the stream. And the time scale of when I'd see impacts would be minutes or days. So what this also means is when thinking about restoration is I only have to worry, if I'm worried about water flow, I don't have to worry about what's right next to the stream. Anything I do should affect the stream really quickly. But what we're really seeing is evidence of this alluvial exchange, this much larger alluvial vadose, and we're going to think about its system, where we have to think about potential contaminants from a lot further away from the stream of what can get in there. And we have to think about what goes into the stream having an effect underneath in the alluvial system further away. In that case, we think more on a kilometer scale when we're thinking about where impact's coming from, where do we might want to focus our restoration efforts. We have to change our time scale to more of days or years or decades, which makes things more complicated. We're thinking about, where do we want to focus restoration efforts? Where do we want to think about time frame of expected changes to occur? So thinking about this, we probably have this we know the subsurface has a much longer residence time than the surface, so it's really expanding the time and space scale of the impacts of things that we do to our urban environment. And also this urban subsurface is a biogeochemical reactor. We saw this evidence of microbes using carbon to try to denitrify. So we can take advantage of that. We can remember that we really have this really big biogeochemical processing happening underground. And so we can think about maybe we can think about, I don't know, fertilizing more with carbon to let more of that nitrate removed, for example. It's spitballing idea, I have no idea if it would work. But there's things we can think about as this biogeochemical reactions occur. And these are also things we just want to think about as we're building more green infrastructure. A lot of green infrastructure is designed to minimize that runoff from impervious surfaces, that surface runoff to do flood control and things like that. But that's changing the interactions with the subsurface environment. So we just have to keep that in mind as we're thinking about these processes. Okay, so that was Utah. Utah's really cool. You should go visit if you haven't. It's a beautiful area. There's lots of great hiking, some pretty good streams. Salt Lake still has water in it for now. But you guys are all in Ohio. And so I want to just do 2 quick little vignettes of some work that's currently going on in my lab in Ohio. So a lot of these graphs are like really, really hot off the press. We're just starting to analyze this data, so this is really preliminary work. But this is Megan Greaves. Megan Greaves is a master's student working in my lab, and she's been looking at some tributaries of the Olentangy River. So right now where are we? Right about here. So I drove over 2 of these tributaries on my way here today. I was like, oh, I know that stream. So she's looking at Rush Run here, Adena Brook, and Turkey Run. These are all small tributaries of the Olentangy River. They're in an urban environment, and she's trying to understand how, across a year, how we see changes in chemistry in these both through an entire year, how the chemistry is changing, but also how it's changing as you go up and down these streams. So Turkey Run, for example, is really interesting because it starts in like a big commercial area. It goes through neighborhoods and parks. It goes through a golf course. It goes underground for a while, comes back. It's pretty short, and you really change the landscape as you go through it. I don't know if anyone's ever walked the whole length of it, but you have a chance. It's really cool how much it changes in just a short time period. So we want to see how these different things are affecting our stream chemistry. So we're looking here, and this is just really early data where we haven't really dug into it yet, so I don't have answers for you yet. But we're looking at Turkey Run. We flipped east and west here to have everything go from headwaters to the Olentangy, and Rush Run and Adena Brook. What you're seeing here is density. So the darker red is more dense urbanized areas based on land cover database. And then sort of lighter colors are less dense, or parks in the case of the golf course. So this is and this is 11 months of data. So she went out once a month and sampled the whole range of these streams. And so we have chloride in these graphs. We can see really different patterns between these different streams, both from the start of the stream to where it flows into the Olentangy, and from one stream to the other. So Adena Brook is kind of deeply incised and protected. It's an area that doesn't put down quite as much road salt as some of the other areas. We don't see a big difference in chloride between the different time periods. Turkey Run, which starts in an area with lots of shopping, lots of big parking lots, we see this big increase in chloride in the winter, but it really starts to go down as we get further downstream. So we're seeing sort of evidence of these different interactions, and we're still working on trying to piece out what's going on here. So I don't have any answers for you yet, but I want to show you that we are seeing these changes in chemistry. It's pretty cool that, Turkey and Adena are almost, they end in the Olentangy almost at the same location. They have really different behaviors. When we look at the carbon, we're also seeing really different behaviors from these different streams. Kind of similar patterns to the chloride, where we're seeing higher at the start of Turkey and lower as we go down, lots of variability in time. And then in Rush and Adena, we're seeing a lot less variability. So again, don't have any answers for you yet, but we're seeing some really interesting changes, and we're starting to dig into, using some of the other data we have to try to piece out, is this groundwater source control, those differences in what's coming in the storms, what's happening to explain these changes. And then this is Katie. Katie's defending her master's degree in 2 weeks. And she's on a really ambitious project. She drove from Detroit to Buffalo, and she found 80 different tributaries that feed into Lake Erie. She stopped for 10 minutes at each site. She threw a bucket over a bridge. She collected water samples. She filtered it. She stuck it in a cooler of dry ice, and she drove to the next site. She did this 4 times. So we did this in March, May, August, and October. So we wanted to see different seasons about what's going on. And her big questions were carbon and nitrogen. How is the watershed size? How is watershed land cover changing? What's being exported into the lake through these different watersheds? And these are all her different watersheds, looking at just general land use. Is it mostly agriculture, mostly urban, mostly forested, or mostly wetlands? So we can see the proportion of each on all these different watersheds. And our watersheds range from 3 to almost 17,000 square kilometers. So we wanted to see, was watershed area a big driver of these chemistries? Was land cover, was soil? What would drive these different things? And our discharge similarly had a really big range. This is an example of just the year hydrograph we seized from 4 of our rivers. So the Maumee was our biggest watershed, and these dots are just one we sampled. So we tried really hard to get seasonal base flow, but you're trying to sample 80 rivers in 5 days and you're trying to work around your class schedule. Sometimes you miss and you hit some storm flow. But we can see we've, different seasonal base flows, different highs and lows at different times of year for these different rivers. And so this is all the data, so all 4 samples from each river, from Detroit to Buffalo. And we see a pretty big range. This range of carbon and nitrogen is as big as you see across watersheds from different climates and different geographical regions. And yet we're seeing in this system of things that are all experiencing the same climate, so it's pretty cool. But we see this sort of huge variability in carbon here around Ohio. And then when we get to sort of the Pennsylvania border, we start to see a much smaller variability in our carbon. And nitrogen's the same way. We're getting big nitrogen inputs, and most of these are driven by nitrate in this section, and you have really tiny variability in lower concentrations here. And we started to see, okay, one of the big drivers here is land cover. Agricultural systems, which are darker yellow on these graphs, had the higher nitrate values were mostly in these agricultural watersheds. Most of them, nitrate was the driving factor in this increase, but we found a handful of them are it's organic nitrogen instead. So we're going to figure out what's going on there. That's really explained a lot of the variability. The non-agricultural watersheds are holding on to their nitrogen. They're not really letting it go, and you're not getting that annual variability in these watersheds. When we look at our carbon, our forested watersheds are our lowest carbon, which we're like, the carbon's coming from the leaves, right? But they're holding on to it pretty well, and they're not having that big variability over here. We're seeing this huge range of carbon in these other systems. Some of that is your soil. That's where the Great Black Swamp was. You're going to have this really carbon-rich soil, so it makes sense. We're seeing these variabilities. Another thing Katie's just working on figuring out too is she's finding that besides this land cover being one of the big drivers, the soil infiltration type is a big driver. So the areas where soil is able to infiltrate a lot more groundwater, soil is able to infiltrate a lot more surface water, so you're going to have more groundwater inputs into your systems. She's seen that's actually a big explainer on these controls of these carbon and these nitrogen. So land cover is really important, but so is that groundwater interaction is what she's working on finding. So just sort of taste of, I did a lot of work in Utah, but there is some cool stuff happening here in Ohio. We're just kind of early in the early stages, trying to see what aspects of these watersheds control this water chemistry. So on that note, I don't want to take you forever, but science is a team sport. Worked with lots and lots and lots of students, working with practitioners in different states. Just want to thank everybody. There's a small fraction of everybody involved in these projects.
So we have time for a couple questions for Dr. Gabor. We got a microphone floating around there somewhere, right? Found another one? Right there, Heidi, behind you.
Yeah, hi. It seems like scaling up the concentration of investigation there would be pretty costly. Can you recommend ways to triage creeks where you might find this phenomenon?
Yeah. Is this still working?
I don't know if our batteries. Try it now.
Okay, that's what I got loud. Yeah, so yeah, the work I was showing you from Utah, it was very personnel and time intensive. It was mostly students, which is cheaper than technicians, but you don't want to use student labor. We pay them, obviously. I think some degrees, we already have really great networks out there from various agencies at state and federal levels that are collecting a lot of water data already. So one thing we can start is starting with that data that we already have to try to figure out where to focus these efforts. I think one of the things that I've been working on too is we don't necessarily need all of these different samples to figure it out. Like I put my detective hat on and use all these different pieces of evidence, but some of those pieces of evidence are more useful than others. So we can start fine tuning and taking down what we are collecting. But yeah, this level of detail that we were doing isn't something we can do to every single stream. We were working with the Utah project, we worked really closely with their Department of Water Quality, and this was a stream that they were really interested in trying to understand better and didn't have the manpower or the finances to do it, and we were lucky enough to have the research project to do it. So that's definitely one of the biggest challenges, is how do we expand this with limitations and personnel and funds, and really not actually an infinite number of streams out there, but close enough to do that. So not the best answer, but I think there's a lot of potential with interactions between researchers and practitioners and helping, if we have a lot of students who want to do a lot of research, and some of that stuff can be done relatively cheaper. So if we can get ideas of, hey, this would be a stream we really want to know more about, then we can kind of work on that with class projects and things like that to start things out. May or may not be a helpful answer, but yeah, it's a hard problem for sure.
Got time for one more? Yep.
I think when this one's on, yours is off. So.
Oh, okay.
That makes sense. We don't want a mic battle, so.
Kind of reminds me of one of those television talk
Works
shows.
now?
Thanks. We have a national scenic river around in Columbus, Big Garvey Creek, and one of the ways that the Ohio EPA is trying to mitigate the effects of urban development in the watershed is to encourage infiltration on those properties. You now have me concerned that could be contaminating groundwater, and if I'm understanding what you're saying, that could lead to a more permanent impairment or permanent impact. What are your thoughts on that?
Yeah, my thoughts on that are unfortunately that it's complicated. Yes, we do have to worry about what is coming in the infiltration, what can contaminate the groundwater. So it's definitely something we have to think about for sure. But there's a lot of potential for remediation to happen because of that longer residence time. If we're worried about nutrients, for example, we can think about how can we have nutrients get removed from the groundwater along the way. So one thing we talked about a lot is if we can really restore riparian zone, the riparian zone, all that riparian vegetation, that's where the groundwater is coming closer to the surface to feed into the stream. So if we're worried about nutrient pollution, if we have a really strong riparian zone with a lot of plants, maybe they can take a lot of those nutrients out before they get into the stream, and then we don't have to worry as much. That's one place where we can really activate, remove some of that contamination. Some of the question becomes, are you worried about things like PFAS, you're worried about things like nitrate? One of those is in some ways more difficult than the other for contamination. And that I still think that infiltration, like encouraging more infiltration from a stormwater perspective, is a good thing in the long run. But I think we also have to think bigger picture about what is on the ground that's infiltrating down and what can we do to try to minimize what gets down into there. So yeah, that is $1 million question, and it's a difficult thing to answer, but I don't think it becomes an intractable problem. I think the other thing to think about is that it is just a different time scale. We might have to realize that when we restore a stream, it might take 10 or 20 years to start seeing that impact because of the groundwater. The difficulty there is that's a lot longer time scale than the time scale of elections. And so how do we convince the public that, yeah, putting this money to this restoration project is worth it, but you might not see a result for 10 or 20 years? And how do we explain that in a way that they're still going to support these projects? Because they're really important and they are going to make a difference. And that's not something I have great answers for yet. But lots of other people are thinking about it too. So.
Okay, thank you.
Cool, thank you.
And you'll be here for the rest of the day? Great. So we'll have other opportunities for questions.
So our next speaker is Mike Eckberg. I've known Mike for a long time. I don't see him very often because he's in Dayton and I'm in Columbus, but Mike is with the Miami Conservancy District, been there for 20 years and is currently the manager of its water monitoring program. Their hydrologic data collection networks include precipitation observers, tipping bucket rain gauges, stream gauge stations, observation wells, monitoring wells, and automated river sampling stations. Mike is also responsible for managing various research projects addressing water quality and quantity in the Great Miami River watershed. As a BS in geology from Lehigh University and master's in geology from the University of Cincinnati. So welcome, Mike. Thank you.
Thank you. Thank you very much. So today I want to talk about groundwater and surface water interactions as they play out in the Great Miami River watershed. And what I want you to come away with today is understanding that these interactions, you know, we really have to think of at least the shallow aquifer system upon which that river drainage system is kind of superimposed. That aquifer and that river, it's a coupled system. Okay, we've got exchange of water between the aquifer and the river and vice versa. And so these interactions play a crucial role. And I think I just lost the mic.
Yeah, I don't know what's happening with that. Hey, Heidi, you got that other mic, maybe? Can we use that? Oh, here it's back on. Sorry about that. I don't know what's going on there.
All right, I'm back on. These interactions, as they play out, they have a profound effect on the water chemistry in in the aquifer and in the river. And the interactions probably also play an important role in providing the kinds of habitat things that help the fish in the macroinvertebrate communities. So let's get right into it. So first thing I want to do is I'm talking about the Great Miami River watershed, and I got to talk a little bit about characteristics. So there's a map of it, and when you look at it, it's about a 4,000 square mile area. You see a lot of brown. The brown areas in that map are where we've got cultivated crops, basically row crop agriculture, primarily corn, soybeans, over 6,000 miles of rivers and streams, and about 1.4 million people. About 70% of the land roughly is used for agriculture, and a little bit shy of 20% of it is urbanized. You see more urbanized land as we get down here into Clark, Montgomery, Butler County. So the Great Miami River starts up here at Indian Lake, flows through Shelby County, comes down through Miami. As we get into the more second half of the reach, it's more urbanized. It ultimately empties out into the Ohio River here in Hamilton County. Now, the watershed actually, you know, you look at that and you say, okay, wow, you know, 70% agricultural land, a lot of urban land, not too much forest. I wouldn't think that the quality of rivers and streams in that watershed would be very high. But when you look at, we actually have several rivers that meet exceptional, Ohio EPA's exceptional warm water habitat standards. Okay, they are designated as meeting those criteria, and that's you know, that's close to as good as it gets in Ohio. And so when we look at the upper Great Miami River flowing through, starting here about Sydney down to Dayton, we've got exceptional warm water habitat. The main stem of the Stillwater River, which comes up through here until we get into the headwaters, also meets exceptional warm water habitat. I believe that main stem is also part of the Scenic Rivers program. And then we've got Twin Creek here in Montgomery County, which meets exceptional warm water habitat. And then my understanding is the last large river unit survey that Ohio EPA did, a lot more sites now in the Great Miami, maybe in the lower Great Miami now, meet that EWH designation. So I don't know, we'll see, but maybe more of the Great Miami will get designated as such. So we do have some high quality rivers and streams. But I want to get into today is more of the aquifers. And Craig did a really good job of introducing kind of aquifers in Ohio. I'm going to talk primarily today about the Buried Valley Aquifer System. And so the Buried Valley Aquifer System is all these areas you see here in light blue. And Craig touched on the complicated history of the drainage systems in Ohio. And we had a pre-glacial drainage system. In fact, at one time, the Ohio River kind of flowed up through this area here and then rejoined. Ice advances into this area changed how that area drained. But these light blue areas are primarily kind of valleys, where there are bedrock valleys that have subsequently been filled in with sand and gravel. And what I've got here is kind of, if I would draw a cross section through here, this is kind of a layer cake sort of cross section of the different geologic units that would be there. So at the basement, we have Ordovician shales. We have Silurian. When you get to Dayton and north, we've got Silurian carbonate aquifers, okay, which you can get, you know, some 50, 100 gallons per minute out of, sometimes a little bit more. Then we've got on top of that in the upland areas, we have glacial tills with some sand and gravel in them. And then here is where the main Buried Valley Aquifer System is. And if I go back, the last ice advance into this part of the state, the glaciers got to their maximum about 20,000 years ago. They actually reached down as far south as about Cincinnati, not quite, the northern suburbs of Cincinnati. And as they were retreating, we kind of had a Great Miami lobe here, and we had a Scioto lobe of ice here. And this area up here in Champaign and Clark County was kind of an interlobate area where there was a lot of glacial meltwater drainage, a lot of ice contact kind of environments, and a lot of sand and gravel deposition. Okay, as the ice continued to retreat out of this area, the main Mad River and the Great Miami River channels was the main outlet for meltwater to get ultimately down to the Ohio River. And thick sequences of sand and gravels from pre-Wisconsin to the Wisconsin age were deposited in these valleys. And this kind of cartoon that I've drawn shows sort of schematically what that looks like. The brown areas are all sand and gravel aquifers. And what I'm showing here is sort of labeled 1 through 4, 4 kind of hydrogeologic settings for wells in this aquifer system. So we'll start with number 4, wells in the Silurian aquifer. And I mentioned before, you can get yields, maybe 50, 100 gallons per minute in that. Good for small village or business industry sometimes. A lot of private wells are in zone 3 here, where we have little sand and gravel lenses in the till on the uplands. You maybe can get 3 to 10 gallons per minute or so from that kind of thing. It's the Buried Valley here that is really our primary aquifer producer. And we have some deeper wells that are sometimes partially confined by fine-grained sediments. And in these zones, maybe we could get 500, 1,000 gallons per minute. But the zone I'm really interested in today is zone 1 here. These are, you know, wells that are typically, you know, not much more than 100 feet in depth. The sand and gravel unit is alongside or on the floodplain of the Great Miami River or other tributary rivers. And in these zones, groundwater redox conditions, commonly oxic, and we can get yields in these areas of 1,000, 2,000, 3,000 gallons per minute. And we can sustain that 7 days a week, you know, 52 weeks out of the year. And the reason is because we've got a hydraulic connectivity between the aquifer and the river here that helps sustain that. So that's what I want to delve into a little bit more now. If we wanted to look at what does that aquifer look like, it's not completely homogeneous. We'll have sand zones in it, interbedded with zones that have more cobbles and coarse gravel. And if we're looking at, if you're a hydrogeologist like me, and you're looking at hydraulic properties of these materials, hydraulic conductivities in the 500 to 1,000 gallons per day per square foot. So if you think about that, a square foot of aquifer thickness in a day can transmit 500 to 1,000 gallons in it. And then if you're thinking transmissivity, if we cut a slice through the aquifer all the way to bedrock, and maybe we have 100, 150 feet of thickness, it's not uncommon to have transmissivities in the 100,000, 200,000 up to, in a few places, 300,000 gallons per day per foot of aquifer thickness per, in a slice through the aquifer. So if you think about that, the groundwater could fill up maybe like an Olympic-sized swimming pool. The groundwater flowing through a 1 foot thick slice of this can fill up an Olympic-sized swimming pool in a little over 2 days. Okay, that's a lot of water moving through this aquifer material. And I just want to kind of give you an idea here of sort of the complicated nature of the land use on top of the aquifer and in this river valley. And so I'm zoomed in here to the Middletown area. I'll back up a couple here. We're going to go right here where Elk Creek comes into the Great Miami River, and we're going to look at this in Google Earth. And these light blue areas, that's where the Buried Valley Aquifer is. These almost white sorts of areas, these are source water protection areas for different public water systems. So these are areas where groundwater modeling says it's a 5-year time of travel. So a particle of water somewhere in this zone reaches a municipal well field, in this case Middletown. It reaches a well within a 5-year time of travel, okay? So I'm showing you this to show, here's the aquifer system, the Great Miami River is flowing through here, through this stretch, okay? And on top of that, look at all the land uses we've got going on here. So we've got 4 public water systems that are drawing groundwater from it, okay? We have Cleveland Cliff Steel right here. It used to be AK Steel, big steel manufacturing site on here. We have sand and gravel mining operations going on here. We have a dense highway network. We have railroads coming through, an airport, all these land uses. So imagine if you're one of these public water utilities and you're trying to protect the groundwater that's coming into your well field and you're trying to deal with this. We've got a lot of land uses here that have the potential to introduce contaminants into this aquifer system. And okay, the soils on this aquifer, I mean, they're soils that developed in sand and gravel. And the properties that make the aquifer so transmissive, allow to produce a lot of groundwater, those same properties make it highly vulnerable to contaminants. And so any contaminants that are going to get in to the aquifer along here, or any releases of chemicals, gasoline, solvents, things like that, they have a high potential to reach the water table and be transported in the aquifer system. Now, I want to look a little bit at the dig into that aquifer a little bit. So we did a study with Terran Corporation. Brent Huntsman led this, and we wanted to kind of look at groundwater levels in that aquifer system. And the first thing we did was we looked at Ohio Department of Natural Resource well logs. And so each one of these yellow dots is a well. And I've got my little cartoon here to kind of remind us of what's going on. This light blue area is kind of like this, where this Buried Valley system is. And these red lines, we looked at well logs for this, and when we could find the depth of bedrock, we noted it. We also had a couple of USGS scientists back in the 60s, Andrew Speaker and Stanley Norris, did a lot of work in this area, and they did some seismic refraction surveys, a couple of transects across here. And we were able to, with these red lines, Brent came up with the contours for the bedrock system. So each one of these numbers here corresponds to the elevation above sea level of the bedrock contours. And so we can see the deepest part of the bedrock valley runs through here, okay? It's not always coincident with where the Buried Valley Aquifer is actually mapped. It actually runs up through here a little bit. So the main Great Miami River channel kind of deviates off from the path in this area, comes down through here, and then we've got another part of the Buried Valley that branches off this way, okay? But what we want to do is each of those wells, we measured the depth to groundwater, and we wanted to look at what the groundwater level contours look like. So here they are. And what this is showing is groundwater flows perpendicular to the contours. So here we're at 674. Down here we're at 616. So groundwater is flowing down valley, okay, going perpendicular to the contours. It's also that we see that these contours often V downstream as well. Okay, and what I'm going to do is I'm going to zoom into this area here, where this dashed rectangle is. Okay, and keep in mind, again, here's my cartoon of the cross section. So this is this is where the Buried Valley Aquifer is, and we're going to zoom into that more closely. And these red arrows correspond to the direction of groundwater flow in that aquifer. And what you can see is the arrows are all headed towards the river. Okay, groundwater is discharging into the river channel all along this stretch of the river system. And if I would measure flow up here, okay, I would find out that it would be, significantly less than if I measured flow down here. And there isn't any major tributary coming in. It's just because all along this reach, the river is gaining stream and groundwater is coming in. And so now what I want to look for is it's a gaining stream, and I want to kind of show what that means in a diagram here. A gaining stream happens when the water table in the aquifer is higher than the water level in the stream or river that's that the aquifer surrounds. So, groundwater wants to flow from high elevation or high potential to low potential. And so the flow naturally is under most conditions in the Great Miami into the river channel from the aquifer. Now, the greater that difference is, the higher that proportion between the level in the aquifer and the height of the water in the channel, the more flow you're going to get, okay? So this is what we have, a gaining stream. Now, there's one situation where this system reverses during a flood event. If we have a flood event, stream flow is going to rise up here, and for a short time, it's going to be higher than the water table. Then we're going to have a flux of water into the aquifer in close proximity to the stream channel. But for most of the year, the Great Miami River under natural conditions is a gaining river, except when we have pumping wells, okay? Pumping wells change things all around. Okay, here we normally have that flow going into the river. We put a pumping well or a well field on the floodplain along the river, and we start pumping it at 1,000, 2,000 gallons per minute, and we start to change those contours, those potentiometric surface lines, and now we begin to get flow from the river into the aquifer towards the well. And now you can imagine in this situation, okay, normally groundwater is discharging into the river, okay? So groundwater is going to be having a big influence on surface water chemistry. Whatever that groundwater is carrying, it's potentially going to the river. But when we get to a well field, now river water is mixing and being drawn into the aquifer. Whatever that river water has, if it's not being filtered out by the sand and gravel, that's potentially coming into our public water system. So that's the kind of the situation, the dynamics that are playing out every day in this watershed. I want to talk some more about those potential interactions. I'm going to introduce a new term here called base flow. And base flow is if we're looking at a hydrograph or stream gauge on the Great Miami River, okay, it hasn't rained in a while, this is the flow, it's relatively low.
But all of this flow coming in is basically groundwater, okay? It's groundwater or it's wastewater that's being discharged into the river. And if you think about it in the Great Miami River watershed, almost all of our wastewater originated as groundwater. It all comes from pumping wells. They pump to a water treatment plant. It goes out to the distribution system. It returns to the wastewater treatment plant and then goes out into the river. It's all groundwater, okay? We have a runoff event. We get storm flow, okay? Base flow goes up a little bit, but here it is, okay? And what I want to do in this diagram is look at for these different sub-watersheds of the Great Miami, how much of the annual flow is derived from base flow versus surface runoff. And so what I did for each of these, Miami Conservancy District works with USGS to co-manage a number of stream gauges in this watershed. And for each one of these yellow dots, that's where there's a stream gauge location, I calculated what's called a base flow index. Okay, I looked at the ratio of, did a base flow separation. I looked at the ratio of the base flow to the total flow. It came up with the percent of the flow, the annual flow that goes past that gauge that is derived from base flow or groundwater. Okay, and so if you look up here on Loramie Creek, it's less than 30%. Okay, all right. Most of the annual flow there is, direct surface runoff. Okay. Same here for this little urban watershed called Coles Creek. But now when I begin to look at Stillwater River upstream of Pleasant Hill, it's more in the 30 to 40% range. Still relatively low. There's not as much Berry Valley aquifer in that watershed. When I get over here to graph, you can see I've got the light blue. I've got the Berry Valley aquifer zones on there. It's a little bit higher, and same for Twin Creek. We're in the 40 to 50% of the annual flow. We're still talking about a large percentage of the annual flow being groundwater, okay, 40 to 50%. But now I get to the Mad River. Look at that. Over 70% of the flow in the Mad River is base flow, okay? And that's coming from the Berry Valley aquifer system, and it's also coming, there's some places here where the Silurian limestone is in close proximity to the river channel and is also contributing there. All right, so 70%. When I sum it all up for the entire Great Miami River watershed, it's close to 50-50. All right, just to show this same concept another way, I'm gonna look at 3 flow duration curves here, and all this is doing is this is showing what. I'm going to look at the Mad River here first, okay? And if I look at the higher flow, okay, this is the percent of time that this flow is exceeded, which is only 10%. It's around 8,000 cubic feet, maybe 700 cubic feet per second, all right? If I go to the 90th exceedance, it's 200 cubic feet per second, all right? There's not a lot of slope between the 10th percentile and the 90th percentile. It's pretty flat. So what that's telling you is that high base flow stream like that, there's not a huge, there's a lot less difference between high flow and low flow. It's evened out across the spectrum. When I look at the Stillwater River, on the other hand, there's a much bigger difference. The 90th percent exceedance is somewhere around 80 CFS, whereas the 10th percent exceedance is about 1,000 CFS, a much bigger difference between those two. And the Great Miami River is kind of intermediate, okay? So kind of showing how high base flow has a way of evening things out and making sure that we've got decent flow throughout the whole spectrum. Another way to look at that is, this is for the entire Great Miami River watershed. This is for calculated this at the Hamilton gauge, which is close to the mouth. If we look at this on an annual basis, half the flow coming out of the Great Miami River roughly is base flow runoff, okay? Now, a profound effect, groundwater influence, is sustaining flow. So you won't see rivers like the Great Miami or the Mad River go dry during droughts, okay? I mean, we can not have rain for 3 or 4 weeks, and the Mad River will still have a lot of flow going through it, as will the Great Miami. And I got to think that has a big effect and is really helpful in terms of providing good quality habitat has to affect the fish and the macroinvertebrate scores. The other thing too is looking at water quality, all right? When I look at about 13 monitoring wells that we have in the Buried Valley Aquifer, and I look at the distribution when we measure specific conductance in those wells. Specific conductance is just kind of a measure of how well that water conducts electrical current, and it's kind of a surrogate for how much dissolved anions and cations it has in it, dissolved mineral matter. Okay, median of around 700 microsiemens per centimeter. All right, here's our gauge on the Mad River near Dayton, and here we are at base flow. Okay, we're at about 300 cubic feet per second. We look at the specific inductance, it's around 650. It's kind of getting close to that 700 number. We get some rain and it drops way off, okay? But then as we're on the recession of that runoff, we see that specific inductance is climbing right up. And I just show this to show that the dissolved stuff, what that groundwater has in it, that's moving into the river is having a big effect on the chemistry of water in the Mad River. So here's what I think, summing it up, the benefits of these groundwater surface water interactions are in the Great Miami River. I think we get higher sustained flows, no doubt about that. Okay, so so when you're looking at macroinvertebrates and fish, they're not going to be subjected as much to in a drought condition. You know, having the stream channel go dry and go into just a few pools and things. You're going to get all the things being equal. You're going to get dilution of pollutants from point sources. Okay, as long as your groundwater quality is relatively high, it's going to help dilute other things out. All right. Big benefit here is the cooler temperatures. The mean annual temperature for groundwater when you get to depth, it's about what the mean annual temperature is for the region, around 56 degrees Fahrenheit. So if you have a steady influx of that cool water, that's keeping the water temperatures, helping keep water temperatures in July and August down. Cooler the water temperatures, the more dissolved oxygen the water can handle, okay? Now, water in the Great Miami River and its tributaries is way over enriched with respect to nutrients, all right? Typical total phosphorus at low flow on the lower Great Miami, it's not uncommon to see 0.3, 0.4, 0.5 milligrams per liter, all right? Under those conditions, we'd expect to see the river get, you know, kind of eutrophic, where we'd have big daily dissolved oxygen swings, high amounts of chlorophyll, things like that. I think with our high base flows, where it's helping buffer some of that. I'm not saying that's not going on, but it helps serve as a bit of a buffer. And I think that's the reason why we can get some of the scores for IBI and macroinvertebrates that are possible is largely due to this effect. Finally, I've read and looked at some of the research in zones where there's a high flux of groundwater helps may help increase some of the biodiversity. Now I want to switch gears a little bit and talk about our groundwater, the aquifer. How are we using it? Well, I got this data from Ohio Department of Natural Resources, their water withdrawal database, and here's how much. This is the groundwater total going back to 1990. And you can see we peaked with around 320 million gallons per day back in the early 2000s. Since then, it's dropped off some. And this kind of reflects a national trend of we've gotten perhaps better as a society, more efficient. We use more efficient plumbing fixtures. Business and industry has maybe gotten a little more efficient at using water. The other thing is we've lost some of our manufacturing base. And so water use for all of those different reasons has trended down recently. We're now at about 230 million gallons per day or so in terms of using groundwater. We look at surface water use, it peaked back here in the early 2000s as well, then plummeted. That's largely because of 4 thermoelectric power generating stations were closed on the Great Miami River. They used a lot of water for cooling. When we look at how that water is used, we see about 75% of it is used for public water supply, okay? about 12% industry, and 11% miscellaneous. You say, what the heck, Mike? What's miscellaneous? It's largely open loop geothermal systems that we have in the Dayton area. And I'm going to get into more of that a little bit. That's how we're using it right now. Now, we've seen a decline in water use. At the same time, we see an increase in the amount of water coming into the watershed. All water that comes into the Great Miami River watershed gets through precipitation. We don't have aqueducts. We don't have snowpack up in the mountains or anything like that. So it all comes from precipitation. If we go back to about 1970, mean annual precipitation was about 37 inches a year. Now we're above 42 inches a year. So we're seeing a climate change kind of signal in the amount of precipitation that we get on average. When we look at long-term records of the depth of water in the Buried Valley Aquifer System, and I'm using Ohio Department of Natural Resources and my organization, MCD wells, and these are the average annual depths to groundwater. We see over the long term that these are pretty stable. There's no strong upward or downward trends. You say, well, how can that be? We're using less water. We're getting more rainfall. We expect to see the amount of water stored in the aquifer systems going up. And I think, the answer may be here when we look at what's happening with the 7-day low flow in the Great Miami River and in the Mad River. They are both trending up. Okay, so I think one hypothesis here I would throw out there is that what we're seeing is the Buried Valley Aquifer System is shunting more water off to rivers and streams. It's so transmissive that as it gets more rainfall, it just sends it to the rivers and streams, and we're seeing low flows going up, trending up. I mentioned open loop geothermal systems. Most areas of the Buried Valley Aquifer System, we are not. We're certainly not mining groundwater. It's sustainable, but this is one area that's kind of interesting. Each of these red dots is where there is an open loop geothermal system that's in the early 2000s, there were incentives to install these. It's a lower carbon emission kind of way to cool the building. And when these are running in summertime, peak summer heat conditions, the combined withdrawal here is about 40 million gallons per day, okay? I mean, put that into perspective, it's equivalent to one of Dayton's well fields, municipal well fields, okay? We're pumping a lot of water here. And this is just showing the lowest annual depth to groundwater in one of ODNR's observation wells right here in downtown Dayton. And we're seeing that now groundwater levels in the wintertime when we're not running these recover quickly, but we're seeing a depletion here. And the concern is that we get into a drought situation, we get into a really summer heat wave sort of thing. And if we install any more of these, one concern would be that these wells will start to interfere with each other and some buildings will begin to lose their air conditioning. So that's something we're keeping an eye on. We got to talk a little bit about groundwater quality. The groundwater in our neck of the woods, it's hard, extremely hard. It will have some iron and manganese commonly. And we find that about 1 in 5 wells will have elevated arsenic, above 10 micrograms per liter, which is, 5 micrograms per liter, I think. No, it's 10 micrograms per liter, which is the drinking water standard. So we encourage private well owners, get your water tested, all right, rule that out. More human origin contaminants are nitrate, chlorides. We have some legacy contaminants from gasoline solvents. We have a number of Superfund sites in the area that are at various stages of cleanup. And then more recently, a lot of interest towards these micropollutants, where we see things that largely of wastewater origin being discharged into the river, things like personal care products, pharmaceuticals, and lately PFAS, or per and polyfluorinated alkyl substances, originate in areas where firefighting foams were maybe used, or where a lot of them are common in consumer products. Just looking at nitrate in groundwater, the chart on the right or your left shows data for 13 MCD monitoring wells. I generally say if you're looking at nitrate levels above 3, and I'm being generous, above 3 milligrams per liter in the aquifer, you're definitely seeing a human signature. We've got 3 wells that are into that. The MCL for nitrate is 10 milligrams per liter. Some of our wells are above that. The chart on the right shows an multi-agency data, and you can see everywhere there's a red dot there. There was one sample collected that was above 10 milligrams per liter. You can see in this part of the Buried Valley Aquifer in Champaign and Clark County a lot of elevated nitrate. Again, sandy soils, agriculture going on top, very vulnerable aquifer to whatever's going on at the land use. We see evidence too. I know a previous presentation talked a little bit about road salt and elevated chloride levels. We see that too in our aquifers, looking at Ohio EPA ambient data and my organization's data. Everywhere there's a yellow dot there's a well in the Buried Valley Aquifer system that has chloride level that's indicative of human impacts. If you want to see what some of this data looks like, this is a municipal production well in Hamilton, and it's just kind of showing, going back to the 90s, sodium concentrations and chloride concentrations. Now, none of these levels are any kind of a human health threat. The concern here is that, this water is discharging into the river, and some aquatic ecosystems are very sensitive to salinity. And so changes in salinity, increasing salinity like this could impact the quality of the biological quality in our rivers and streams. The other concern is, all other things being equal, the more salinity in your groundwater, the more corrosive it is. And so it's a water treatment kind of hazard to deal with, and have to make sure that that's dealt with in the water treatment process. I mentioned legacy pollutants. We do have some Superfund sites in the watershed. This chart here shows one of our wells, trichloroethene, which is a chlorinated solvent. The concentrations have come down. They're now below detection, but probably a lot of this is through natural attenuation processes. Chemdyne is a site in Hamilton. This is what it looked like back in the 1970s. It is has undergone groundwater cleanup. I just throw those out there to kind of show we're not like any other, or not unlike other urban areas that have these kinds of issues. Recently, we funded a study with USGS. They looked at PFAS in 23 private wells in the Buried Valley Aquifer system. And this is what we found was out of those 23 wells, 11 had one or more PFAS compounds detected. We looked at a list of about 40 different compounds, and only one well had it above a proposed maximum contaminant level or drinking water standard. But I just show this to make you aware that they're out there, okay? So what do we do as far as, what approaches can we use, and what do we need to do as far as managing these groundwater resources? The groundwater and the river, the interaction of the two, it's important that we take management approaches that will continue to sustain these water resources. And I think, proactive strategies are needed. An example of one is Tip City on the upper Great Miami River bought up some land around their well field that was agricultural, and they converted it to prairie and to wetlands in order to remove nutrients. There were elevated levels of nitrate in the aquifer there, and that's helping drop the nutrient levels so that their public water supply is not impacted. I've also got to mention the Hamilton and New Baltimore Consortium in our area. It's a group of water utilities and one brewery in Butler County And they have a very sophisticated, one of their approaches is they have a sophisticated groundwater monitoring program where they are going out there a couple times a year collecting samples and looking at the quality of water that is coming into their well fields. Some characteristics of yeah, and today I'm here in a community of people who are really interested in rivers, streams, and keeping the health of those. And one area where I think the groundwater and the surface water community where we overlap is this, wetlands and riparian zones. These are key areas to protect. And to the extent that you preserve natural floodplains and river corridor areas, and environments like I'm talking about, you're also safeguarding aquifer and helping maintain groundwater quality. Same could be said for wetlands. So I think, as far as proactive strategies, the more wetlands, the more riparian zones we can serve, the better. Other characteristics of proactive strategies should be looking at these kinds of things. We need to recognize that our rivers, particularly for the buried valley aquifer system, the river and the aquifer are a coupled system. And so we can't just focus on the river channel itself. We need to be focusing on the aquifer out some distance from the river channel that is providing a lot of the flow that's in that river. If you have a contaminated aquifer, it's going to impact the quality of the water in the river. We need to integrate these kinds of approaches, good stormwater management, good stormwater BMPs into our building and zoning codes. We need to have offsets from development that protect natural floodplains to the extent possible. We need to set aside areas that we recognize that there just may be some land uses in certain areas that are not suitable. If we are on a sensitive aquifer, close to a well field, close to the river, that might not be a good place to have a lot of underground storage tanks. And so in our economic and our development plans, we need to recognize that that kind of a land use could go other places. And in these areas, we need to look at kinds of development and economic sorts of things that are more, less impactful on water quality. Finally, I think communities need to recognize that, contamination of the aquifer and in vulnerable aquifer settings like this can happen. They need to be thinking ahead and setting aside areas that they would utilize as an alternate source of water should their current well field be impacted. So we need to have areas set aside that can serve as areas to utilize groundwater in the event of an emergency. And finally, groundwater monitoring. Can't say enough for it. I think there needs to be more of that. We need to be keeping closer tabs on what the quality is of the water in our aquifers in these areas. There's more work that can be done there. When we look at the big picture beyond local communities, one thing that I will throw out there is I think the surface water community has done such a good job of coming up with a beneficial use designations and a system to go and look at rivers and streams to assess their health in terms of whether they're meeting those beneficial uses, and then communicating the health of that to the public. And my question is, why can't we do something similar for groundwater? We have beneficial uses like protection of aquatic life, recreation, and water supplies under surface water. Can't we come up with something similar for groundwater? Okay, and can we designate, a primary drinking water aquifer, something like that, where a large percentage of the population is relying on it? And then can we have a monitoring or assessment of that aquifer system and reporting on it and charting it and looking at it over time? So sort of modeling some of the concepts that are used with surface water. Can we take that kind of approach and do it for our aquifer systems. We have the beginnings of it, I think, with Ohio EPA ambient program, but we can do so much more. And with that, I am happy to open it up for questions.
We got time for a question or two,
One or two.
then we'll get, I know,
Past lunchtime.
yep, real quick.
Somebody had their hand over here.
Hamilton and Butler County are number 1 and 2 for gravel mining. Huge gravel pits exist along the rivers. And I wish you'd address that issue because we have no mechanism for what we're going to do when they're completed.
Yeah, the comment was made that there's a lot of gravel mining going on, but what can you do about it? I think the answer is kind of what some of your community does. Conservation easements, land acquisitions, things like that. With that, you control the land and you protect it from those kinds of future developments. There's other things that can probably be done with used gravel mining. We probably can manage them in their post-mining life better and do some things, but that's a whole other story.
We're going to take one more question, and Mike, will you be here the rest of the afternoon for folks who have additional questions?
Yes.
Wonderful.
How you doing, Mike? It's not PFAS. What are the most common industrial legacy pollutants found in this area?
Okay, so the question is, what are the common legacy pollutants in the area? All kinds of chemicals associated with the use of gasoline and diesel. So benzene, toluene, xylenes, things like that. I mentioned chlorinated solvents. So solvents that were used to degrease metal parts. So it'll be, those are common, perchloroethene, trichloroethene, things like that. In some places, PCBs, but those would be some of the common ones.
Okay. Thanks, Mike. Okay, we're gonna break for lunch now. My understanding is our host from Drew Blank, Bill Milano, sorry. Drew blank there. Our host from Bill Milano are gonna release the table. And then you got 2 aisles, right? One on each side? Buffet style? Okay. recently retired from EPA. Greg worked as an aquatic ecologist in the agency's Division of Surface Water. Greg still works as an independent consultant for the Ohio EPA, as well as Spring from the Source LLC. He serves as an adjunct professor at Kent State University, focuses on the ecology of primary headwater streams, and his research interests include thermodynamics of headwater streams and determining predictive habitat indices to predict biological communities in Eocene streams. So, Greg, welcome. Greg's going to talk to us about what it takes to make a cold water stream.
All right, good afternoon, everyone. Before I begin my presentation, I would like to first say thank you, Bob and ODNR, for the opportunity to speak at this year's Symposium. And I'm honored because I get to talk about one of my favorite subjects, which are streams. And hopefully, if I do my job right today, you all agree that when it comes to streams, it's pretty cool to be cold. That pun was intended. All right, now before I go under the hood and talk about cold water streams, I kind of like to pull back just a little bit and talk about all streams in general. Go over their nomenclature, their use designations, and how they're protected by the law. All right, and then I'll dive into the specifics of cold water streams. All right, now it all begins with the Clean Water Act. The Clean Water Act of 1972 had a main objective, and that was to improve, restore, maintain the physical, biological, and chemical integrity of our nation's water bodies, right? And out of that came several goals. One was to eliminate the amount of pollutants or eliminate them completely that are going into our nation's body of waters. And also, when it's attainable, to make those water bodies fishable and swimmable. So allow us to recreate as well as to protect the organisms that live in the water. All right, and out of the Clean Water Act came water quality standards, which it defines the water quality uses of bodies of water. Okay, and out of that, the designated uses and the criteria that were implemented to protect those uses were also designed. So what exactly are those water quality uses? Now, the presenters before me talked about them already, but there are aquatic life, recreational, prevalent drinking water, agricultural, industrial, navigation, all of that, okay? So it's important to know that a body of water can have one or more of these uses. Now I'll talk more about the aquatic life more than anything else today. All right, now for those that are familiar with Ohio law, Ohio laws are going to be found in the Ohio Revised Code. So if you look at the Ohio Revised Code under 6111, it says that waters of the state include streams, lakes, ponds, marshes, watercourses, waterways, springs, so on and so forth, okay? And all of those types of bodies of water should be protected, all right? So if you go out to an ephemeral stream and it's got water in that stream that day, the state of Ohio has sovereign authority over that water body. Okay, now the land is going to be, owned by the property owner, but the water within that stream is owned by waters of the state. All right. Now the Ohio Administrative Code are the rules that are used to implement the law. All right. And if you look in Rule 3745-107, those are where the water use designations and statewide criteria are going to be found. And it states that the water quality standards contain two distinct elements. One, distinct and designated uses, and two, numerical or narrative criteria designed to measure and to measure those uses. All right. And again, it's worth noting that bodies of water may have one or more aquatic life usage. So what are those? And there's 5 of them. Okay, there's going to be warm water, exceptional warm water, modified warm water, limited resources, and cold water streams. So if you go out to a site and you're like, what the heck is this stream? Which one of these 5 criteria are going to fit for the stream where I'm at right now? Okay, in order to find that out, a use attainment analysis is going to have to be done. Okay, so when you're looking through the use attainment analysis, the attributes, Species composition, diversity, and functional organizations will be measured by first an IBI, or Index of Biotic Integrity, the Modified Index of Well-Being. Those are two indices that evaluate fish, all right, and the Invertebrate Community Index, and that's one that's used to evaluate the macroinvertebrates in the stream, all right? So, one of the accepted methods, standard methods to evaluate fish is by electrofishing. All right. So basically, you're going to have an anode, a cathode, and in the stream, it's going to generate an electrical field. As fish pass through that field, they're going to go through kind of a state of galvanotaxis. You know, the muscles are going to lock up, and they're going to be drawn towards that electrical field. So those fish are going to be scooped up, put in a live well, and afterwards, they're going to be sorted, taken down to the lowest taxonomic level, and you can generate your IBI, or if needed, your MIWB. Okay, you're going to get those scores. All right. These pictures show some of the different apparatus that are used to collect fish. It's going to depend on where you are in the river continuum. So in these headwater streams, a backpack shocker, especially the really small ones, a backpack shocker is reasonable. And headwater streams that have a greater drainage area, a long line is used. So basically, it's going to be a generator on the bank, and there'll be a long line to measure, that's measured out within the reach that you're sampling there. And wading streams, depending on where you're at, they're going to be anywhere from 20 square miles to 300 square miles in drainage. And a roller beast is going to be used. I kind of liken it to a snowmobile. You know, basically the generator and a live well are placed on this contraption, and they're pushed and pulled and what have you within the reach, and fish are collected, put in a live well, and again sorted out later. And last but not least, those rivers that are deep enough where you can't wade, a boat is used. Okay, so again, once these fish are collected and taken down to the lowest taxonomic level, sometimes they're even weighed and what have you, depending on your data quality objectives, they're put back into the stream and they live happy lives, hopefully. All right. Now, some of the standard methods for collecting macroinvertebrates are twofold. One, for those streams that you're evaluating that have a drainage area greater than 20 square miles, a quantitative analysis is going to be performed. Okay, and one of the methods that are used to collect macroinvertebrates is by the use of artificial substrate samplers. Okay, this is just an example of Hestrodendines. You place several Hestrodendines on a cinder block, you know, in a pool of a river. They're placed in there for about 6 weeks or so. After they're collected, you know, because a lot of the macroinvertebrates are going to colonize on those substrates, they'll be pulled out, preserved, taken back to a lab, and then, you know, as these bugs are picked off in the lab, again, they're going to be taken down to the lowest taxonomic level, and an ICI can be scored there. All right. Now, when you're evaluating those streams that have a less than 20 square mile drainage area, a qualitative collection of macroinvertebrates can be done. So in those streams, basically you have like D-frame kick nets. You're going to search pretty much all the different types of habitat within the stream itself. The riffles, the runs, the pools, undercut banks. I mean, anywhere you're going to find macroinvertebrates, they're going to be collected. So the biologists, they go out there and just pick, you know, rocks. I'm sorry, pick organisms off rocks or leaf pack material. You know, wherever you're going to find them, they're going to be collected. Okay, and then a narrative score is going to be given under these qualitative samples. All right, so you may wonder, you know, the stream that you're at, which category am I going to put this particular stream? This could be warm water, sector warm water, limited resource, modified, what have you. So once you've gotten your ICI score, your IBI score, or if relevant or important, your MIWB score, you're going to compare your stream to streams of relative size, the least impacted streams within our ecoregion. Okay, so just for an example, say I'm evaluating a stream that's a tributary to the Cuyahoga River. It's a wadable stream. All right, so I'm going to be in the Erie, Ontario Lake Plain. Oops, didn't mean to do that. I don't know what just happened. Oh, there we go. Okay, so there's the ecoregion I'm in right there. And it's a wading stream. So my IBI score, again, I compared it to the least impacted sites within the Erie Ontario Lake Plain ecoregion. I should get an IBI score of a 38. And I think you can, be plus or minus 6 numbers down from that 38. So if I have a 34, there's non-significant departure from being a warm water body. Okay, those numbers in the bold are going to be your warm water body scores. All right. My MIWB should be a 7.9, and my ICI, when calculated, should be a 34. Okay, so this narrative evaluation is going to be for those streams that have, again, that have a less than 20 square mile drainage area. All right, so if I'm meeting these numbers in bold, it tells me I've got a warm water body. Okay, you can see some of the exceptional, when they're really, really high, you may have an exceptional warm water body. So these types of streams, the assemblage of macroinvertebrates and fish that are found there are really, really, really good. They're going to be very sensitive, and there's going to be an abundance and diversity of those species. All right. All right. Going down to modified warm water habitat. These are streams that are incapable of meeting that warm water habitat criteria due to irretrievable modifications of the habitat. Okay. Now I put in there that it's not always true, because in some streams, the reason why they're designated as being modified is because there's a lot of siltation or sedimentation within that stream. So it's covering up the habitat. All right. So in those instances, if there's restoration or there's work done on those streams where the habitat can be greater quality, it can be designated as exceptional or warm water again. Okay, so historically speaking, they may have one category, but if work is done on them, they may be put up into a different category, like warm water, exceptional warm water. Okay, I've done, a use-tail analysis. It's not warm water, it's not exceptional, it's not modified. I may get limited resource water, it's my category. And these water bodies are said to have no potential for any aquatic-like use at all. Okay, and that's due to either background or irretrievable human impacted or anthropogenic conditions. All right, so an example of something that something that we've done to our stream. It could be, I think one of the other presenters had one that was lined with concrete. The entire reach was lined with concrete. Well, clearly, if there's no habitat within that stream, or at least within the reach of that stream, you're not going to necessarily find any biology in that stream. Okay? Some natural conditions may include just those streams that prohibit the migration of, say, fish, mostly fish, but potentially even macroinvertebrates, due to just natural conditions, like waterfalls. It's going to impede their movement. Okay, there's nothing wrong with them. They're unmodified, they're natural, they're beautiful, but because of natural conditions, it just doesn't allow for the migration of fish. Now, it's important to know in the state of Ohio, the 2 biological communities that are evaluated to determine which of these 5 choices you're going to pick are macroinvertebrates and fish. Okay, we don't have, and I'll talk about cold water habitats here in a minute, it's going to give you a better definition of where I want to go with this. First of all, cold water habitat has 2 definitions. Okay, one is these are those inland trout streams. Okay, these are the ones that are managed, they're stocked and managed under the auspices of ODNR's Division of Wildlife. Okay, mostly for steelhead and what have you. Okay, the other definition is those waters capable of supporting populations of native fish, other invertebrates, and macroinvertebrates and plants on an annual basis. Okay, those ands are very important in this definition. Okay, and the reason I say those ands are important because historically speaking, primary headwater streams have been excluded for one of these categories, or if they were included, they were considered a limited resource water body. Okay? Now, I know my friend and colleague, Kelly Capuzzi, taught at this symposium last year, and she went over a lot of detail about primary headwater streams. I won't do that today, but I'll just remind you that these are the streams that have a drainage area of less than 1 square mile. Okay, so they're really, really, I shouldn't say tiny, but they are tiny, you know, and if there are pools found in these types of streams, they're very, very shallow. Okay, they're very important because again, they provide a great ecological service, but they just don't allow sometimes the passage of fish. And again, they're typically going to be groundwater fed, so this is where that cold water is usually going to be generated, but they can't again support that migration due to waterfalls, and there may be other habitat characteristics that prevent an abundance or diversity of, or a great assemblage of fish in these reaches. And that's just, again, it's just natural. It's just usually because of their flow conditions. All right. I understand now that there are pathways to get these types of streams in our rules, and if that's the case, that's a great success for the state of Ohio, for sure. All right. These headwater streams, these primary headwater streams, especially the class 3 ones that are spring fed and perennial, are extremely important because they're the ones that are the precursors for those streams that are designated as cold water habitat streams. Okay, so depending on where you are in the river continuum, and usually these primary headwater streams are way, way up there, but if you have a network of them, just downstream of them, those are the areas where that particular segment of the river is going to be designated as cold water. Okay, and we do have 91 streams that do have that designation, and those are the watersheds where they can be found. All right, let's just go back to cold water streams in general. They are ubiquitous across the United States. They're going to be cold water for a couple of reasons. The primary reason is definitely because they're groundwater fed. But there are instances where you're going to get glaciers melting or snowpack material from mountains, coming down the gradient, and they're going to be cold water fed as well. All right. In this diagram, this illustration to your right, just want to show you, obviously when that groundwater is connected to the stream itself, when you have a high water table, it's going to feed into the stream. And you're going to kind of get an exchange, not only from the groundwater going into the stream, but vice versa. You're going to get some material from the stream going into groundwater. Okay, so when that groundwater table drops a little bit, specifically in the months of like July, August, September, what have you, you will notice that most of the water is going to be a one-way path, but it's still perennial. You're still getting some groundwater influence. So you may have some pools within that stream, and those pools are still going to be connected with what we call interstitial flow. Okay, so you still have that connection, and that's important. That interstitial flow is important because those macroinvertebrates or those obligate salamanders that live within these cold water streams, that's where they're going to be found. So if you go in the stream bed, you may not see a lot of flow on top or within above the bed of the stream, but if you just move some of the coarse material within that stream bed, you'll see groundwater flow. All right, and that's where that biology is going to be found. Then you have disconnected streams. Those are not only going to receive, water from, say, these cold water streams, but again, further down the continuum, you will also get stormwater, okay, or melting snow, what have you, that fills that. It's not connected to the groundwater, but it's going to receive the majority of its water from outside sources, or above where they're at. And over time, say in these warmer months, these seasons where it gets really, really dry, you may still have pools in these streams where you're going to find warm water biology, and these pools are not going to be connected to each other. So there will be flow connecting to each other. So again, you're going to find warm water biology within those streams. Now, some streams just go completely dry, okay, and they're called ephemeral streams. Okay, I like to call ephemeral streams more seasonal streams because they're like vernal pools. They still provide a great function They're still important to the biology. It's just you don't see the diversity and abundance of biology when you compare it to cold water streams or warm water streams. So that hydrology is very, very important. Now, I've talked about the river continuum concept several times already. For those that aren't knowledgeable of it, it's a well-accepted theory from Van Noten and others that provides some insight to the organization of streams, basically from their headwaters all the way down to the main stem. Okay, as you look at the land use adjacent to the stream, as it changes and the stream gets wider and wider and wider along its gradient, there's going to be predicted biology changes within the stream. So if you look at this illustration that's just right out of Van Noten's work, you'll notice in these headwater areas, okay, the orders of the stream are going to be on the y-axis, and the channel width is going to be on the x-axis there. So in these headwater areas, most of the energy is going to be provided from outside sources, okay, like organic material from leaves and twigs and logs or what have you. And the biological community that you're going to find there predominantly are going to be shredders. All right, so they're going to take this coarse particular organic matter, these leaves and what have you, and they're going to break it down. So that energy source is going to go downstream so organisms like collectors can receive them. Now, the shredders themselves may be dislodged because of high flows, or they die and flow downstream. So again, those collectors and predators are going to be further down the continuum. Okay, and you'll notice as you go down the continuum, you know, the stream relies less on what's adjacent to it, and the energy source is going to come from within the stream. Okay, so that's where your periphyton, your algae, your macrophytes, things like that are going to be what kicks off the energy source. All right. So why are these cold water systems so important? Quite a few reasons. One, they're the most prevalent within the watershed by far. They're great for, again, that transfer and conversion of energy from the coarse particulate organic matter to the fine particulate organic matter. They're going to assimilate nutrients, pollutants. Again, they're unique ecosystems because there's going to be organisms that are found in the headwaters, okay, these cold water systems that are going to be found no other place on our planet, you know, let alone other places within the river system. Okay, so typically when it comes to the vertebrate species, you won't find necessarily an abundance or diversity of or great assemblage of fish. Basically, the vertebrate that you can find in these headwaters are going to be salamanders. Okay. All right, and some examples of the fish that you will find in cold water bodies include those from the family of the salmonids, like your brook trout, or if they're stocked, your rainbow trout, your cotydids, like the mottled sculpin, the cyprinidids, like your red-bellied dace and red-side dace, and the gastrosteatids, like your brook stickleback, are going to be found there, amongst others. Now, some of the salamanders that you're going to find in these cold water systems are going to come from the family of the Plethodontidae. Okay, now these aren't the mole salamanders or the amphistamids that many of you may have seen even, well, probably today. You can probably see them. But these are the mole salamanders that come from the forest. They go to vernal pools. They do their thing and they go back underground. Okay, these obligate salamanders are obligate, and the reason why they're called obligate because they have to be in perennial cold bodies of water for 1 to up to even 4 years of their life stage. Okay, they're gill larvae, and before they morph into adults, you know, when they absorb their gills, they have to be in these perennial bodies of water that are cold. Some examples that you may find are the longtail spring salamander, the midland mud, the northern southern two-line, cave, and northern reds. So if you ever get into hunting for salamanders, these are some phenomenal ones to find. Needless to say, the macroinvertebrates are critical. Again, they're going to be the most abundant of all the organisms you're going to find in these cold water systems. They're going to comprise of worms and leeches and mollusks, crustaceans, but the most sensitive are usually going to be the most, are coming from the insects, all right? Especially the Ephemeroptera, Plecoptera, and Trichoptera, or your mayfly, stonefly, and caddisfly group. The great naturalist E.O. Wilson once stated that if we were to wipe out insects alone on the planet, the rest of life, and humanity included, would certainly be gone in a matter of months. And I would argue the same thing in these aquatic systems. Again, they're the ones that kick off their energy source in these cold water systems. Without them, everything else would fall apart. And that, again, is due to their ecological significance in these bodies of waters. All right, so the threats to our cold water bodies. Well, one, there are some natural, but most of them are anthropogenic. What do we do to these streams? Everything under the sun. We feel like we got to make them poker straight. We channelize them, we cover them up, we put them through culverts, we dam them, we obviously discharge pollutants to them. We change the landscape, the land usage is next to them. We put up our row crops there, we deforest for whatever reason to make a suburban area. The list goes on and on and on and on. So, and unfortunately, because these streams are the smaller ones, these are the ones that are found everywhere. They're the most ubiquitous, and they're the ones that we want to change so much. A big one, as one of the speakers before me said, is salt. I collect samples of salt and some of the tributaries that go to the Cuyahoga River through one of the metro parks where I volunteer. And I do it annually, and you'd be surprised at the concentrations of sodium and chloride in these streams, even in the summertime. It's not just something that's a problem during our warmer months, but it happens all year round. So, and that does change the water chemistry for those organisms that live within it. Some of the natural threats include fire, floods, windstorms. I just put in brackets, kind of, because as we all know, that the intensity and frequency of these events are somewhat kind of our fault too, right? Which brings me to a point of climate change. All right, the increased temperatures, now let alone all the other variables that impact these streams, but these increased temperatures definitely can alter their metabolism, organisms that live within the stream, their feeding, their growth, oxygen availability is going to be low, and again, some of these species are very, very, very sensitive, especially to oxygen. And because of climate change, these changes in the precipitation conditions are going to change. Sometimes we get too much water. Okay, that's going to alter the thermal regime for sure. And sometimes we don't get enough water. All right. So when you don't acknowledge these cold water systems, the impacts are clear. Okay. Again, especially in a lot of the headwater streams, they're going to impact what's happening downstream of them. Okay, so if we alter them, we're screwing up, what happens downstream of them. I liken these headwater streams, these cold water streams, to the capillaries within our bodies. Okay, how much damage can we do to our capillaries before our entire circulatory system's jacked up? Okay, so look at it like that. Okay, this is just an example of a stream that's a tributary to the Cuyahoga River in Cleveland. It's Mill Creek, and this came from the Saltwater Conservation District, and that's what they said that the watershed looked like in the early 1900s. You go out there today, that's what it looks like. So that headwater network is completely shot. All those cold water streams that it used to be there are gone, and most of it's because, it's urbanized and what have you. But can you imagine being in that mainstream right now, especially when it rains? One, the water's going to shoot out there like a cannon. So the habitat's going to be altered. So are you expecting, that stream to meet warm water habitat or exceptional warm water? Nah, there's no way. Okay? And those accumulated effects, without a doubt, are irretrievable over time. Okay, so that's just a mine site, then obviously urban sprawl and just all the different things that we do to our watersheds. Okay, so without a doubt, unless we care, no one's going to care. I do recognize that there are a lot of people that are out there doing a lot of great work. There are land trust organizations, metro parks, scenic river, folks, what have you. There's a lot of people doing stuff. So the way we reverse, some of the damage that we're causing is one, get involved with those groups that are doing it already. You don't have to reinvent the wheel, But things that you can do in your own backyard are, you know, when you're applying salt on your driveways and sidewalks, what have you, reduce that, you know, plant native. If you own property, don't mow adjacent to a stream. You know, it's amazing what 10 feet of riparian protection would do to a stream. Okay, especially in these cold water systems, in these headwater systems, that 10 feet is just one, it's going to take out a lot of the nutrients, a lot of, you know, other bad things that are running off into the stream itself, but it's the energy source that's going into these headwater streams. So again, most of the things that we can do are low-lying fruit, but we've got to do it. Okay. These are some great resources that you can look up for finding the organisms that live within cold water streams. If you go to the Ohio EPA's website, you'll get a list of just about every macroinvertebrate as well. Actually, macroinvertebrates and vertebrates, whether it be salamanders or fish that can be found. Fishes of Ohio is a great book. Obviously, DNR's Field Guide is a great one. This is the jam right here. Fishes of Ohio. I think one of the authors of Fishes of Ohio, Brian Zimmerman's here. He's going to be one of the speakers today. This is your Bible right here. Take that out. And Bo Shell's book on macroinvertebrates is a great resource as well. So I know we're running out of time, but I just want to say thank you to, again, Bob and ODNR and WMAO for the opportunity to speak this year. I put Dr. Peterman and Greg Lips because, man, the knowledge I've gained from them when it comes to at least these amphibians, just by sitting next to them and talking to them, I probably learned more from those guys than I have in years of training academically. These are some of the folks from the Ohio EPA that have carried the torch for protecting these streams. On this side are what I call the OGs. These are the ones that have kind of set the pace for those to follow, especially when it comes to these primary headwater streams. And others that I've been able to collaborate, especially last year, evaluating some of these cold water systems. So with that, just want to say thank you. Appreciate the opportunity to talk.
Thank you, Greg. So in order to keep time here, we're right on time. We're going to go to our next speaker, Paul Pira. And we got 2 more speakers, and we'll have an afternoon break. So maybe before that afternoon break, we can take some questions for all these speakers. Greg, Paul, and our next speaker, Brian Zimmerman. So Paul Pira serves as a geographer, district biologist, and supervisor of natural resources management. He's been with the district for 20 years. Paul has a MS in biological sciences from John Carroll University. And he has developed and implemented ecological restoration and pursued funding to research and peril native plants and species, plants and animals such as the Ohio brook trout. Paul currently serves as the chairman of the Native Ohio Brook Trout Advisory Committee and represents Ohio to the North Central Division of the American Fisheries Society's Salmon Technical Committee. So welcome, Paul, and Paul's going to talk to us about Native Ohio brook trout.
All right, thank you. Appreciate the time. It's an honor and a privilege to be up here with so many great folks. Thank you to DNR and Scenic Rivers. Nice to see a couple of the rivers, Cuyahoga and the Grand River here behind me. The county that I work for, and I live up in Northeast Ohio, way up there, and we're the headwaters for the Cuyahoga, the Grand, the Chagrin River. And this is a picture. I'm going to get to talk about some special things here today. I've got lots of stories. I'm a fisherman. We're going to talk about fish, so be ready for stories, okay? This is what I'm talking about when we're looking at Northeast Ohio and cold water streams. Look at that, beautiful, huh? Sharon sandstone conglomerate. That we're learning so much about geology this morning, and that's it. That's the key. That's the ticket right there for these cold water streams. And of course, with that, you get these little beauties here, male and female brook trout. And so, unfortunately, though, there's only a few streams left in Ohio that have these special fish. And you can see a very isolated population, and has been for quite a while. Believe it or not, about 30 years ago, we were down to 1 stream
left in Ohio. And that's scary. That's a scary thing. And unfortunately, we had a lot of people that were very passionate about it. And I can't stand up here. I'm not going to pretend to stand up here and say like I'm the person responsible for anything with brook trout. I'm standing on, as the saying goes, the shoulders, right, of giants that worked on this. There are many, many people, and I'm going to mention quite a few of them here today. But you know, brook trout are a poster child again for cold, clean, pristine waters as they can be so in Northeast Ohio. And some of the best water quality in Ohio is from our neighborhood. So I'm pretty happy about that. Unfortunately, though, like we have watched, as I said, some of the numbers of streams with our brook trout have been going downhill. And we changed that status in 22 from a threatened species to endangered the Ohio Division of Wildlife. I sit on something called the Ohio Brook Trout Advisory Committee, and we recommended to the Division of Wildlife, and they've been really good about that and very involved, obviously, with this program. Now, I want to go over some of the history of brook trout real quick. To know where we're going, you got to kind of know where we've been. So I like history. I'm a history buff too, but so when the early back, you know, when the settlers first came to Ohio, they did have documents. There was a man named Jared P. Kirtland, very famous naturalist, and he wrote about speckled trout being found in some streams, one in Ashtabula County, and a couple in the Chagrin River in Geauga County. Now, one of his contemporaries, this guy here, Theodatus Garlick, Dr. Garlick, was also interested in trout, brook trout in particular. And these guys were, by the way, I think they were medical doctors, but they really were interested in natural history back then, and they did this as a hobby, but they were unbelievable. They were like the best naturalists ever, right? And I mean, this guy even built, I think, like the first camera in Cleveland, took the first picture of Cleveland. I mean, this is like, these guys were unbelievable naturalists. They don't make them like this anymore. It's, the old saying goes. Anyway, Theodatus Garlick was very interested in brook trout too. And I don't know if you can see, this is his tombstone. You can find that if you go up the hill from Little Italy. Anybody know where Little Italy is in Cleveland there on Murray Hill? Okay, you go up Murray Hill to the Lakeview Cemetery up there. And if you look in there, that's actually a pretty good name for being just up the hill from Little Italy, Garlick, I guess. But if you look on this tombstone, I think what it says on there is he is the first man in America to breed fish by artificial methods. Did you know that? In Cleveland, Ohio, he was breeding fish in the mid-1800s, brook trout in Cleveland. Can you imagine that? Pretty cool. Talk about changes in watersheds, huh? All right, so fast forward about 100 years, famous Milton B. Troutman wrote The Fishes of Ohio. That's the Bible for, you know, fish nerds. And you know, he basically, he thought in that book, the first edition, that most populations were probably wiped out, gone, and any habitat also kind of presumed extirpated. Now, he had a friend, Dr. Andy White, at John Carroll University. Andy White was my advisor in grad school. And they talked back and forth quite a bit with the writing of the book, but then he was out in the early 70s, 1972, in some little tiny headwater streams in Geauga County. And lo and behold, he seined up some brook trout. He didn't know whether or not, he wasn't sure whether they were the native ones from Kirtland's writings way back when. So they talked back and forth about it, and there's some really funny, hilarious stories that I'm not going to get into now because they'll take me an hour to tell you about Andy White and his stories with that. But I have talked before about them, but if you want to talk about them, come see me later. How they figured out basically that these were probably native brook trout from and the neighborhood kind of let them know about it. But Andy White, you know, they kept it kind of under wraps for a little while. And another man got involved too, Mr. Terry Hartman, who actually I just talked to him 2 days ago. He's in his 80s. He's still teaching at the university school, biology up there, and he's still obsessed with brook trout. but he was involved too. And they did send tests off in the early 80s, early 90s, I should say, to some universities in Canada. And they were that he got a phone call. He told me the whole story of getting a phone call from the professor. He said, you better sit down because we got news on the genetics on these fish. They are totally unique to Ohio. So you've got something worthy of conservation. So that started the ball rolling. We had some other tests done over the years too, and that only confirmed the uniqueness of these fish. And so that started our reintroduction program in 1996, about 9 years with the Ohio Division of Wildlife leading that. And the goal was about 15 streams. We tested, we went out and looked at all kinds of streams for a number of years and decided there were about 15 that were pretty good candidate streams. And so we released, we started a stocking program and released fish over a number of years. Some of them did okay, some of them did not. And right now, this is a little outdated, but it's pretty much stayed the same. We have, like I said, about 3 streams in the state of Ohio right now that have brook trout that I'm feeling pretty confident are self-sustaining good populations. There's a couple others that are so-so, and the other ones didn't do so hot. So why? And that was a big question, and we did a bunch of research on that called the Habitat Suitability Index. And these folks were, again, back in the early, let's see, this would have been like 2005, 2006 maybe. We did this work. Paul Anderson up here with the Ohio EPA, he led some of that charge. So many people have been, like I said, involved with the brook trout. I have to mention Vince LeConte and Andy Burt, Phil Hillman here from the Ohio Division of Wildlife, and Kurt Wagner is heading up, for fish now in Northeast Ohio, very much involved with the brook trout. And then again, there's Andy White looking at this character here, trying to he looked like that a lot at me over my graduate school years. He kind of looked very puzzled there in that picture. I thought, so, what exactly are you trying to say, Paul? So, all right, that's a little bit of the history of brook trout. Now, threats to our populations, we've already talked about some of them. So we do know, of course, right? Siltation's one for streams. Oh, you love to see septic systems functioning like that, right? What else? What else happens? I'm going to tell you a couple things. Here's our beautiful spring brook trout stream, right? How about, I got a phone call in like 2005. And I was pretty new to the park district. And Paul, you need to, the neighbor in the neighborhood of Spring Brook called, you need to come down to the stream immediately. I said, why? He said, you won't believe it. There's like soap or something, foam all over the whole stream. I said, what? And I got down there. This is what I found. I said, what in the world is going on? You can't tell the, I guess, proportions. That's probably about 4 or 5 feet of foam on the stream. I couldn't even see the stream. Like, where the heck is the stream? So anyway, I raced up the stream in the ditches and found a crew of guys working. They were drilling gas lines in the ditches. I said, what are you guys doing? Oh man, this has really been heck. It's been hard here this afternoon. We can't get through all this sandstone. All this rock is difficult. We're using this surfactant, drill turge. I said, how much of this stuff did you go through, guys? I don't know, about 5 or 6 of these buckets. I said, well, you need to stop. You're like ruining one of the nicest streams in Ohio. Please. Oh no, that's somebody doing laundry in the neighborhood. I said, I don't think it's somebody doing laundry, unless they have college girls that come home from college every now and then. My daughter's sitting over there. She's broken the washing machine twice now on us. So, anyway, I said, I don't think so. They wouldn't listen to me. So I called Paul Anderson at the EPA. Paul, you won't believe what's happened to our brook trout. He raced down, and he luckily did put a stop to it. So that was good. We dodged a bullet with that one. Now here's a bullet that we didn't dodge. Pettibone Stream, another beautiful brook trout stream, self-sustaining for probably 15 years. We got one of those hellacious rainstorms, 3 inches of rain in an hour. And it looked like a bulldozer went down that stream. We came about a month later to do our brook trout assessment, and there wasn't a brook trout to be found in the stream. They were gone. So anyway, that's what happens. The other thing too, I don't know if you noticed this, look around on there's like no leaf litter around this stream, no forest floor, none of that duff. So I kicked the soil and all these worms started wriggling out. Really bizarre. And I don't know, these are Memphis worms. And I don't know if you know about alien earthworms and the effects on forest floors. You should read about it when you leave for the night. Read about them maybe this weekend. Boy, they can really change things. They compact the soil. They make it hard like a Walmart parking lot, right? And there's no natural absorption of all that rain. So you got a Walmart parking lot and 3 inches of rain. What do you think is going to happen to that nice little stream? Right? So that was a nail there in the coffin for that stream. The other thing too, with all the warm water, now we start getting some influx of warm water fishes. I mean, it's a native fish, but hey, these are big predators too in streams, and I think they are competing with some of our brook trout. This is a creek trout. Well, now I'm going to say something here. I hope nobody throws anything at me or gets me tarred and feathered and let out of here. But you know what? We've had this debate with the Brook Trout Committee. This is a culvert pipe at the end of Spring Brook, our one and only stream that had the brook trout 30 years ago. And we talked about taking that thing out. Like, hey, this isn't a good thing. We probably should. This is a trend. You know, we need to get rid of these things. Now, maybe we just let's not tinker with something that's not broken here. We're not going to try and mess with this. This is actually, we think, might be helping the brook trout upstream. Here is a wonderful population. Below it is the lake, natural lake with lots of predators, other undesirable fish species, things we don't maybe want coming up. So there's good and bad, I think, to some of these barriers. And with the project I'm going to talk about here in a minute, we're actually going to work in maybe some waterfalls to keep and limit unwanted species from migrating up into our brook trout streams. So Spring Brook, we did a brook trout stream restoration project here funded by Ohio EPA in 319 program a few years ago, 2021. About 500 linear feet of this stream was impacted. There was some erosion issues going on there. And the neighborhood put in a dam a long time ago, 50, 60 years ago at least. Actually, it was in the 1950s, so longer than that. To divert cold water into Bass Lake to flush out their little lagoon area where they would put the boats in during the summer months. And so that set the level for the stream, but it deteriorated over time and started head cutting in the stream, and a really bad erosion problem started, and it was down to hard pan clay. I just watched it every year. We would watch it and it would just deteriorate and work its way upstream. So we had to do something about it. And the EPA was very nice, like I said, and funded the project and wanted to solve our problem with erosion. And we hired GPD Group and a team of these folks, EnviroScience and River Reach, to solve our problems here. And yeah, what they came up with was they were going to do something called aggradation. They were going to raise the bed of the stream back up with bringing in lots and lots of material, which I'm going to show you, and keying in using riffles basically to stabilize the stream. We're also going to put in all kinds of great brook trout habitat too. And so we actually took fish out beforehand, obviously out of the 800-foot section of stream we were restoring. And look at this, I want you to note this. Look, we only had 16 fish in that whole 800 feet of stream, brook trout, adults. So that's kind of sad. Again, we brought in lots of material, all local sandstone quarry right around the corner from where we were at. And amazingly, you know, they did a really great job with equipment. You could barely tell a year later that there was anything that ever went on here. I've been very pleased with the work that we've done. So you can see just how much before and after kind of the pictures here, how much we brought the level of that stream back up and stabilized. More pictures, nice deep pools for brookies, nicely installed riffles, good food, macroinvertebrates, those bugs are starting. It was pretty interesting, really neat to watch how long it took bugs to re-enter, come down into the stream. Beautiful woody habitat put into the stream, big teeth pools for those adult brook trout. Spawning habitat, that was one thing I really insisted on, was we gotta make sure, obviously we need good spawning habitat for these fish. So you want those quartz pebbles about the size of your thumbnail. And I'm gonna share with you an awesome little video here. Hopefully it works. All right, take a look at this, see if we can get this thing to work. Here's the male, here's the female. Brook trout. This is in mid-October. All right, how about that? Is that not cool? That's brook trout. That is native brook trout spawning in Ohio. Can you believe that? You are the first people, I want you to know, you were one of the first group of people in the history of the world, right, to be able to witness native Ohio brook trout spawning. I was about flipped. I can't tell you how happy I was to see that. I mean, I've looked for quite a number of years, and I can't take all the credit. A guy in the neighborhood took the video, and I met him there that day, and we watched these brook trout spawning, and it was just amazing. All right, so I don't know. Yeah, we're going to move on real quick here. This is a new project that we're just kicking off here, and we're actually going to start this coming summer with the actual construction, which I'm real excited. It's going to start in July. One of the cool things that I get to do with the park district is they send me out to look at new pieces of land for potential acquisition, turn into a park, right? And so I went out they said, hey, go take a look in about 2020 at this old golf course just south of Chardon on Route 44. I said, okay, I'll go take a look at it. So I met the landowner and they showed me around on a golf cart, and I was kind of, all right, I've got some old fairways and golf carts and some kind of not so nice looking streams here, whatever's going on here. Some kind of nasty looking ponds. Wasn't super impressed. But then he said, hey, wait a minute, Paul. I got one place I gotta take you. I think you're gonna like it. So he took me here, showed me this. This was a spring of water just gushing out of the ground. I couldn't believe it. And I said, oh my God, this is beautiful. Of course, being the biologist that I am, I jumped off the golf cart. The guy thought I was nuts. I dove in the stream, started flipping rocks, And I came up with these little beauties, huh? Red salamanders were all over the place in there. I'm like, oh my God, this is great. This is it. This sold me on it. I'll take it. And I said, what else probably popped into my head? I bet you know. Yeah. What about, man, wonder what in the world what could I do for these things? How could we do something with brook trout? And so I got on the phone with a couple of biologist buddies, and I said, unfortunately, this stream, it kind of starts up here, hits a little pond that they have in the fairway, and then dumps out right here, and it's only about 50 feet of cold water stream until it hits another warm water stream right here. And it's just ruined, and it goes into those nasty ponds and everything. And the water quality is just trashed. And there was no way of really getting a good way of like trying to fix it or something. I thought for all night long, like, how the heck can I fix that and do something? Couldn't come up with any idea. And I'm like, well, I'm gonna call some people and ask them, have you ever heard of like just disconnecting a stream from, and let's just dig another one, a brand new stream. Let's just make a new one with the water. I'm like, what the heck? I don't know, Paul. I don't know about that. I'm not sure I've ever heard of that. That's what we're going to do. Took me a few years of convincing, but Ohio EPA, again, they're funding me through the WRRSP project, Watershed Resource Restoration Sponsor Programmers. And man, they're gonna give us over $1 million to build this stream, cold water stream here this summer. And I'll tell you, I'm super excited. We got a lot of people super excited about it. We're also gonna remove those ponds and do some things. That's kind of our own little graphic, my graphic. This is a little bit better graphic. The engineer is actually sitting out here in the audience. He's probably a little happier with this one than that other nasty one I just put up there. But this is the spring water. We're going to do about 18, maybe 1,800 linear feet almost of new cold water stream. And so we're really excited about it. It's something we're going to work in. Here's that little pond I told you about where the stream comes out. Spring water just gushing out of there. And something that they came up with, their team came up with, a biologist, and I love it. I'm like totally stoked about it. It makes total sense when I think about it. They're proposing to make this more into something like this, a beaver pond. Have you guys ever, who's a fisher? Anybody fished for brook trout or in native little brook streams? Some of the best brook trout that I've ever seen, beautiful streams in Pennsylvania, have like little beaver ponds in the headwaters. And there's big brook trout sitting in them all the time. It's really cool. And so we're gonna try and mimic that with this project. And we're gonna have it, we're gonna enhance it a little bit. We're gonna put a berm up, get a little more water in here, about 2 feet, and then it's gonna naturally spill out here and form that stream. We're also going to do, undercut banks and deep pools and riffles and all the good stuff that we did at Springbrook. So I'm really excited about this. Plans for the future. Now, this is something interesting to talk about. So, like, what's in the future of brook trout? And I'll tell you, I'm writing right now a conservation plan for the state of Ohio. I was just talking to Division of Wildlife a little while ago, and we're working on it together. And I don't really know. I mean, we're not sure what things are going to look like in 50 years, do we? I don't think anybody does. Like the old philosopher there says, no man ever steps in the same river twice. He's not the same man. It's not the same river, right? We don't know. Things are going to change. We know that, right? Things are definitely going to be changing. So I think we need to think about that. Fish are going to need to adapt. We're going to need to adapt. Stewards, people like me that are stewards of these beautiful resources, I think we're going to need to start thinking creatively about this stuff, more adaptively, more out of the box, right? I manage over 10,000 acres of land for the park system. We just got done doing prescribed fire management. I'm a burn boss, right? We intensively manage pollinator habitat, meadows, 100-acre meadows with pollinators for butterflies, which is great. Monarch butterflies and milkweed and all that. I love it. What about, we manage the forest, tree diseases. We're working on tree disease problems. We're managing those. What about managing cold water streams? I mean, we're going to have to figure it out. Like, I think we need to talk about, what's important. Is cold water and brook trout important enough to manage and have active management in the future? I think so. I want to see these fish around. So like I said, we're writing out the recovery plan right now. Protection of the water key is the whole ticket. The brook trout streams, the 3 that we have that are surviving, the whole entire watershed is pretty much protected by parkland. And that's it, man. That's one of the big key, protecting that land around that water. Getting a diverse team of folks involved is always good. Positives for brook trout and some of the fish, these special fish. We know they're suited to adaptation. They can change. We do know that. Biologists call it phenotypic plasticity. That's something for my daughter to talk about in her college classes over there or something, right? Hey, maybe these little streams are going to be refugia when things change here in the next 50 years, 100 years. Who's going to say? We don't know. There's a lot of questions. But I think, you know, we can help ourselves increase the chances of survival of these things. We need to, again, think about innovative restoration. Some of this out-of-the-box management and restoration is important. I don't really know, you know, again, like we said, these fish are not trophy fish. We're not creating a sport fishery here necessarily but these are a biodiversity, these are the gems of Ohio that we're holding on to. We used to call it in our brook trout advisory committee, we used to call them the aquatic bald eagle, right? The brook trout. Couldn't think of a more beautiful fish. I dare you to try and think of a more beautiful fish, but I don't know all the answers to things that we're talking about here with brook trout. I try to understand some of the things, but and sometimes I don't even know the right questions to ask. I'll tell you that. But I do know that I want to see these fish around and survive for the next 50 years. I want my grandchildren to be able to come to the park district and see these fish. And so I'm going to leave you with a beautiful little video, hopefully here, of brook trout swimming. Oops, let's see if I can get this to work. This is what I want to give my children, my grandchildren, my great-grandchildren. Beautiful fish like this. So with that, I want to thank you for having me. It was a pleasure, and I'll take any questions if we have any time. So thank you very much.
Thank you, Paul. We'll take some questions right before the break, like I mentioned earlier, for all three speakers in this session. Next, we have Brian Zimmerman, who's working his way out of the crowd here. If anybody in Ohio could be titled Mr. Fish, this is the man. So Brian first became interested in fish. Your grandmother gave you a book of Troutless Fishes in Ohio a few years ago, and that all started from there. So Brian received a BS from Heidelberg. He double majored in water resources and environmental biology before completing a master's in aquatic ecology at Bowling Green State University. Brian was able to pursue his interest in surveying Ohio's fish. He began the Fishes of Ohio Inventory Project through the Ohio State University in 2011, which led to the 2019 publication of the Naturalist's Guide to the Fishes of Ohio. And I think that was pictured up there in one of the presentations earlier. Right. So Brian, welcome. And Brian's going to bring us up to date on some fascinating fish finds in Ohio and maybe some cold water fish species.
All right, well, thank you. Okay, so yeah, Bob invited me to come here today and talk about some sort of recent finds or just things I found fascinating, recent discoveries of species in Ohio. So I'm going to start with a couple of slides of things that are exactly that, and I'm going to talk a little bit about some of my reintroduction projects I've done too. So it'll be kind of two parts to this. But we'll start out with some of those sort of recent finds. Let's see, make sure I do this right. So that was how the next record was found. Literally just a cinder block pulled out of the Ohio River. This guy fell out. So that was our third record. That was the most recent one. So we do have these. We know nothing about their distribution, whether they're just in the Ohio River, maybe the lower Scioto. So I'm actually going to spend a little bit of time this coming field season to actually see if I can go find any more. Actually actively look for these because that's never been done. So I'm going to do that and see if we can find out a little bit more information about them. So that's my first kind of new fascinating find of a species in Ohio. All right, here's another one that's interesting. So alligator gar. Alligator gar are native to Ohio. People don't realize this, but we had this giant predatory fish in the Ohio River historically. All of the historical records, the last documented one was in 1946, and it was at the mouth of White Oak Creek. This is basically a backwater off the Ohio River, and these are found in kind of those, a lot of times you go further southwestern cypress swamps and other backwater areas off of large rivers. So that was our last known record. there has been an active reintroduction project going on further down the Ohio River in Kentucky since 2009. So they've been actively stocking this fish for quite a while in the Ohio River further down. So it's possible that we could get an occurrence. They're also sold in the aquarium trade. So my photograph I used in the book, this was in my local pet shop in Knox County, Ohio. That's where I found that. So that's where that photo came from. But we got this record in 2017 of one caught in Short Creek. That's really far up the Ohio River, probably outside the native distribution. I suspect that was a released pet, because they are sold in pet shops. But we did get this bigger one in 2018. This was kind of at the upper end of what the natural historic range would have been, near the West Virginia, Kentucky line on the Ohio River. And we don't know because it was released. It was actually this one up here. It's a pretty big fish. All those stock fish further down the Ohio are pit tagged, I believe. So if you could get a hold of one that's caught, you could probably scan it to find out. But this was just released pretty quickly after the fisherman caught it. So we don't know for sure. But that one very much was within reasonable thought of it could have been from that reintroduction effort. We've had another one here. This guy was caught in the Great Miami River below the last dam on the Great Miami. So that one also would be within maybe that expected historic range, that's right at river mile 34. So it's probably as far up as anything can get from the Ohio River in the Great Miami. So that's a possible one from the reintroduction effort too. And then we've had a couple others just last year that were within lakes within Ohio. So those are people's pets that they let go. But at least that would be my assumption is how those got there. So move on to another one. So this one I've got an active reintroduction project with as well. So the longhead dart. These guys historically were found from a couple sites by Milton Trotman in the Wahonding River. So that's where these black dots are right here. They were pretty close together. And I'll talk about this more in a second. I have an active reintroduction project here in the Muskingum Basin. So there's stuff going on there. But as part of this project, we go collect these fish from the Allegheny River in Pennsylvania. And so they seem to be increasing a lot in the Allegheny. It's definitely the largest population of this fish in the world. And so every time we go over there talking to the non-game biologists in Pennsylvania, we had this discussion of why aren't they in the upper Ohio? The water quality has improved. They should be in the upper Ohio River itself. This population is huge in the Allegheny. And we've seen several other species make this range expansion, sort of natural re-expansion, where they're showing up on the eastern edge of Ohio and coming down the Ohio River. We had this discussion. I was doing something else and I got a text message from one of our state fish biologists. He didn't even have any words. It was a photograph. He sent me a picture. Before he said anything else to me, I said, you're doing a tailwater survey at the New Cumberland Dam, and that's a longhead dart. He didn't know what it was, but I guessed where he was based off the fish before he said anything else. And so that was the first Ohio record in the upper Ohio River. Since then, we've seen a few more, and I've actually, for the last 2 years, been able to catch these in the lower end of Little Beaver Creek. So they're actually naturally re-expanding into the upper Ohio River and tributaries. So right there's Little Beaver, and these are actually some of the ones caught in Little Beaver Creek, those ones right there. So I thought that was really cool to see that this fish is actually recolonizing the state on its own. So again, this range, any of this is all new, so none of that shows up in my book. I did put these ones in there. This is a little tributary to the Ohio River in Kentucky. I figured it's close enough. It's not in Ohio, but at least shows that there's this little population adjacent to Ohio down there as well. And then we have this active project up here. So here's more about that. So we've been, since 2018, actively trying to reintroduce the species around those historic localities in the upper Muskingum River as well. We've moved a lot of these guys. We're starting to see a little bit of results. The original plan was to move these for 5 years. Our first year, we didn't meet our goal. We were trying to have a goal of moving 1,200 a year. The first year, we weren't able to accomplish that. We had a lot of high water on the Allegheny River, so we extended it 1 more year. We've had kind of intermediate success of where we've gotten recaptures. We have these 6 original sites. 3 were seeing them and 3 were not. And based off that, we added a new one in the Tuscarawas River last year because that was one of the areas that we're seeing intermediate results where we're getting some recaptures, but not a lot. So we added another site to the Tuscarawas River last year. So we'll stock that one for the next 4 years as well and keep going with this project. So I think these guys are moving around a lot. You'll see, I'm going to talk about a couple other darters we've done projects where we've got much higher success rate. I think part of it with this species is they're really mobile. We think of darters as being these fish that stay in a riffle and just stay there. These don't. This one moves a lot. We tag all these guys that we released. We found some of the tagged fish several miles from where we released them. So I think that's part of why our results haven't been as good with this one, is because they're moving more. So, okay. But also, I've been doing some work with trying to do captive propagation. So with a lot of the darters, we're catching them and moving them places. So I wanted to at least throw one of the species in here that we've done some captive propagation work. This species is just one of quite a few. I guess we've actually got 9 species that we're working with that are kind of glacial lake or wetland oriented, that we're trying to actually breed these at OSU and a couple other places at this point. The black chin shiner was considered extirpated from Ohio. The last record was from Myers Lake in Stark County, which is actually right in Canton, so the glacial kettle lake, if you're familiar with where that is. And they haven't been seen there since 1983. So we began this captive propagation project at Ohio State, and we started this species in particular in 2019. We started some other ones as far back as 2015 that are glacial lake species. And then here even more recently, I've gotten 2 other county park systems to join in, and they have their own little breeding facilities. So I'm interested in trying to find a Northwest Ohio group that may be interested in participating in this. So I guess that's a little bit of an advertisement there. Contact me, maybe, if you're in Northwest Ohio. Because a lot of our wetland and glacial lake species are in kind of Northwest and Northeast Ohio, and right now we're basically have been focused on Northeast Ohio. So we could use some more partners with this. We've raised quite a few of these already between these 3 facilities and released at 5 locations. We definitely have natural reproduction at 2 places. So probably the next time the state list is reviewed, I would probably make the suggestion of this being, instead of considered extirpated anymore, to move it back to endangered. So that's pretty cool to be able to say that. Okay, another darter. So this is one of the other darters we've done a lot of work with. We actually have been working with this species, the same 6 sites in the upper Muskingum Basin as the longhead darter. These, we fortunately, the record is not quite as old. I think the longhead darter records from the Wahaning are from the 1930s. These are from 1962, so it's not as old, but relatively old. And we kind of looked for these sites across the Muskingum Basin where maybe they would survive today. And a lot of this is based off other species re-expanding within that watershed. So you're seeing a lot of other water quality sensitive fish re-expand within that watershed, which kind of gives you an idea that maybe something even more sensitive can now live there again, because we've seen this recolonization, respreading out of other species. So we chose these 6 sites kind of around that historic locality. Had the same goal of about 1,200 a year. With this one, unfortunately, we did not have to go outside of Ohio. This species is doing really well in the Scioto drainage south of Columbus. They've become very abundant within the Scioto River itself and a lot of its major tributaries. So they're pretty easy for us to get without having to travel as far. So we've moved and stocked a lot of these over the last 6 years plus now. So we stopped stocking the original 6 sites in 2022, and yet even though we had stopped, I like this right here, because 2023 follow-up survey, we caught even more still. That shows that they're reproducing at these sites pretty substantially. And this is the tagged individuals that we caught versus the natural recruits that we captured. So these are untagged fish that are not ones that we so, and that number has gone up every year. So a lot of times with fish, we use catch per unit effort. So I'm gonna have several of these graphs, so I'll talk more about the first one. But essentially what this is how many fish you catch per minute of sampling. So our backpack shocker we're using has a timer on it. So when we're done, we can take that and you can divide it by how many fish you caught each minute. So that's what this is showing. These are those 6 release sites within the Muskingum Basin for the tip canoe darters. And you can see we kind of have 3 that have been maybe not so great. But 3 of them, we seem to be increasing in numbers as far as the catch per unit effort is going up over the years. The other part that's really good to see is this is taking just the catch per unit effort of all of those sites combined, but we're combining looking at the tagged fish. So these are the fish that we moved, and you're going to expect that to drop because we stopped releasing fish. So eventually those are going to die and they're going to disappear. They don't live forever. We've actually found this species lives a lot longer than what was thought to live based off this project. But what is really good is see those untagged natural recruits is continuing to go up. It really jumped last year, which is really cool to see. It was thought that this species maybe lived 2 years, maybe. From doing this, we had 5 years of fish we tagged. We had a site in the Kokosing River where we caught 5 different tags, meaning we were catching at least a couple tip canoe darters that were 5 years old or older because we don't know how old they were when we originally captured them. So that's pretty cool to see. It's something not intentional, but we learned about this species by doing this project. One of the cool things I've done with this so far is we stocked these wrong button. Here we go. We stocked these originally at just 2 spots in the Kokosing River. They're about 1.5 miles apart. Those were the green ones there, our original stocking sites. So I thought, well, how far are they spreading? If they're reproducing in here, how far are they actually spreading out within the stream? So we had done these pretty quantitative surveys at the actual release site. I wanted to look outside of this. We just kayaked down the Kokosing River and started looking in every riffle as we went. And we captured them in almost every riffle we looked at so far. I haven't looked beyond this stretch. So next year I'll keep going further down. I'm curious to see just how far our established population has spread in 6 years. So all of these outside of those original stocking sites, none of them are tagged. So these are all naturally recruited fish. We've basically established a population of these there and they're spreading, which is great to see. So how do we change the overall distribution in the state? Well, here's our historic record right here. And it is one location in the upper Muskingum Basin. So we did take a little bit of an assumption that they would have been further out within that area. I think that's a pretty safe assumption because there is not a lot of people running around looking for fish all over the place historically. And that record came probably right when water quality was pretty bad, and yet they still found one. So you have to kind of assume that these fish were more widespread than what we even know that they were. What's cool is you can see that the Saito populations do great. There's another one of those, you're getting that expansion down the main Ohio River. These are out in the Ohio River itself. And then here's where we're hopefully getting this new population reestablished. The one spot left where there's a historic locality was the lower Olentangy River. And there's a dam blocking that, Green Lawn Dam, and it's blocking them from getting back. So this past year, we started releasing some fish there in the lower Olentangy too. Because we had success in the Muskingum Basin, decided why not try this in the Olentangy as well. We're making that more of a class participation project. Some of the OSU classes are actually getting to help do some of the follow-up surveys since it's right there on campus. Okay, a lot of this being set up by Natural Preserves and Scenic Rivers program specifically. And I've been working on this project with that group for almost 6 years now. We're starting the 5th year of releases for this project this year. We just went out on Wednesday. So I figured this would be the best project to spend more time on. at this meeting. So Bob brought this up, I guess it has to be at least 6 years ago, maybe longer, that I was doing these reintroduction projects elsewhere in the state. Said, well, what scenic river has a really old record that we could maybe do this on? And the Stillwater River has this 1899 record of a bluegrass starter. And they're not anywhere near there presently at the time when we had this conversation. So we decided, why not? Let's try it. Variegated darters are present in the Great Miami Basin, but they're mostly much further downstream, close to the Ohio River. And there's some historic records kind of scattered throughout the Great Miami Basin as well. So we decided we'd try this same design of project in the Great Miami and Stillwater, and try the same thing there, moving these two species over there. So this will actually be the last year for the Stillwater, and we'll finish up next year on the Great Miami, and that will be 5 years on each of these for 3 sites in each as far as moving these guys. Here's what we've done so far. Although I didn't add it, but I said on Wednesday we moved fish here. So I think we had 130-ish on the first day of trying variegates and 60 some bluegrass. So there's some missing numbers already for this spring, but that's how many we moved. And again, these are all tags, so we can tell that the fish that are released are ones we put there versus ones that grew up there. Here's our recaptures so far, and we're doing better with the bluegrass starter and better in the Stillwater, but that's also where we've had the most effort. So, and again, we're increasing every year. Bluegrass starters last fall in the Stillwater, total 302 captured, but look at that many that are untagged natural recruits. So this is working really well, a lot like our tip canoe project. We seem to be establishing this species over there. So here's some more of these catch per unit effort graphs. Now, one thing to pay attention here is the scale changes. So variegated darter, we're not getting as many. And but last year we definitely had an increase, so that's good. Our catch per unit effort is going up. I've been looking at a lot of these. I thought, well, it'd be interesting to look at the species that are already there. So we catch other darters, of course, right? The ones that are more common that should be there. So I was kind of curious. We had this big jump in 2020, which you would expect right off the bat. We just released these. So let's look at a common species the same year. Should be the next one. Oh no, sorry, I had the bluegrass next, but. So we're seeing a more continuous increase with the bluegrass darter and our higher fish per minute. So the scale is a little bit different there. All right, so this is the most common species in the riffles as far as darters at this site. These guys have always been there. We had nothing to do with this. But look at the scale with this. These things it's crazy abundant, how abundant the banded are. This one's up there. It's like upper 50s of individuals per minute caught. So there are a lot of banded darters at these sites. But what I thought was kind of interesting, even as this common one, we're seeing this quite a bit of variability. And remember, this is nothing we stocked there. It definitely is going up and down. And so it seems like you have good years for even the species already there and bad years for the species that are already there, as far as with a similar amount of effort per year, which is kind of interesting. So I have one other one. So here's the rainbow darters. So again, we started this in 2019, so our second year apparently is just a good year for darters in general. It was just fascinating that we had that high of a catch rate for a common species at one of these sites. And even with this one as well, it seems like 2022 was not a great year for this whole group of fish. So we put all 4 of these species together. We got our 2 recently stocked species. Just for scale, they're much lower. But it is kind of interesting to see we're getting kind of close to the natural occurring rainbow darter with the bluegrass darters. It's starting to come up and getting close to it. So I think that's pretty neat to see. But of course, the banded darters are just way above everybody as far as how many of them are there. And like I showed with the tip canoe darter, you want to see the natural recruits, so those untagged wild fish, you want to see that get above the catch rate of the stock fish over time. And we have already seen that with the bluegrass. We're not there yet with the variegate in this system, but hopefully we will get there in another couple of years. So here's statewide range of those 2 species, kind of show how we're affecting it. Here's that historic 1899 record of bluegrass darter, and here's our little red dots up above it are the stocked locations that we're trying to establish the species. And same thing with the variegate. You can see there were more variegate darter records in that system, but they're all older. The only place we really currently have them is down here in the lower end of the Great Miami. So we're trying to get them back up in the upper part where we have higher quality sites. So, okay, so this is probably why all my interns like me, right? Or at least they claim to, so they take photos of them with lampreys on them. So this is in the Allegheny River. This is actually, so a lot of people think of lamprey as a bad thing. These are actually, in Ohio, a state endangered fish. These are Ohio lamprey. But the Allegheny has really good diversity of a lot of things. This would be a state endangered species there, but here in Ohio, state endangered species, but they're really abundant in the Allegheny, and it makes for a fun photo of a lot of my past interns. And it's a good way to thank them too. Thank you for helping me with all these projects. It takes a lot of people to make these things happen. We get to see a lot of other cool fish too at times. So I always like showing pictures of fun things we catch and showing all of my past helpers too, because I've had a lot of help. Okay, and with that, I can take any questions at time. I think I went faster than I needed to, but we were behind overall.
Thank you, Brian. So we can take questions for the last three speakers now. So questions for Brian, Paul, or Greg. And Heidi's out there at the microphone. Here we go. So go ahead. Any questions for the last three speakers?
I think they need some sugar.
Okay, we have a break at 2:45. Here's a question. Heidi.
This is for Paul. Could you tell us more about the barriers that you've got proposed as part of that old water stream system to separate it from the warm water it's discharging to?
Yeah, sure. Thank you. We are going to design. We have designed, I should say, about a 2.5, 3 foot tall, natural looking waterfall, sandstone waterfall. And again, the purpose of that is to try to keep out any undesirable warm water fishes from migrating and coming upstream and potentially competing with our brook trout. So, thank you.
Any other questions? Bill?
Yeah, and he's asking about, you mean like the stream gauges, right? Like the USGS flow gauges? Yeah. Whether or not the annual flow gauge has anything to do with the reproduction of these various darters. And like I pointed out, it seems like across species we have years that were better and worse. I thought about that. It could have to do with flow. I think we did have higher water in 2022. It could also be that because of the higher water, we're not as good at catching them. It may not even be the fish themselves. So, I've been thinking about this a lot as I put this together. What is causing this? Is it something with my data, or am I actually seeing this change? I don't know if I have an excellent answer, but we did have more consistently higher water in 2022 versus 2023, which was much lower throughout the year. So that could be the factor there, yes.
Yes. I had a question for Brett. I know he mentioned during his talk that when they shot the fish, they inventory them, they return to the stream, live their life. But I didn't hear what happened with the mackerel bird.
Okay, so for the mackerel,
after they're in.
Yeah, they're usually preserved, taken back to the lab, so they can, again, be taken down to the lowest taxonomic level, so that takes time. So they'll usually be preserved for months before the biologists can get.
Sacrifice?
Are they what?
Sacrifice?
Yes, they would be sacrificed. Yes, if you want to use that term. Yes.
It's very tedious work.
It's
right?
tedious work, yeah. When you're looking at it,
tiny
you know, exactly, a lot of animals, and usually, I'll speak for consultant groups, the EPA. You're looking at several streams a day, and you multiply that all over the summer. You've got a lot of streams, so a lot of that work, especially for the mangrove rivers, can't be done in the field.
Paul's putting in culverts to stop other migratory species. And Brian, on the other hand, I want to know how many barriers like culverts and Mohead dams are preventing the movement of your newly introduced or relic populations.
Yeah, certainly dams are a big barrier to fish for sure. Yeah, even with some of the species I talked about, with the longhead darter, they might be able to come back up to the Muskingum themselves if they are recolonizing the Ohio. But there are 10 dams on the main stem Muskingum that date back to the 1840s from our canal system. So they're not coming back up the Muskingum on their own. There's a lot of dams in the way. And same with the tip canoe darter in the Olentangy. Well, they're only 2 miles downstream or whatever it is. But Greenlawn Dam is pretty big in Columbus, and they're not getting past that. They're just one example. I mean, Greenlawn Dam, someone asked me how many fish are below Greenlawn Dam but aren't above it. It's close to 40 species. That dam is a major barrier within the watershed. The Scioto is our most diverse large river in the state. There's over 100 species of fish in that system, but there's a huge drop at Greenlawn Dam. It's the first dam on the system. So on a river of that size, when you hit the very first barrier, everything's stopping. And there is a reduction of almost 40 species of fish from below that dam to above it. So, and below it is our longest stretch of free-flowing river in Ohio. It's 128 miles of free-flowing river from Greenlawn to the Ohio River in Portsmouth, which is great. It's our best large river in the state by far, but that's a major barrier.
Yeah, I was wondering, is the Greenlawn Dam retaining water for drinking water supply, or is it just recreation? And if you do know, and if it is just recreation, I think I read that 2024 there's a rehabilitation project that's planned for that dam. You know if there's any discussion about actually removing it? Thank you.
I've talked to people about trying to get it removed, but I've been told, I don't know the details of the dam real well. I have been told that, and there may be somebody here that can answer this better, that there's a large sewer line going through it. So it cannot be removed because it's keeping that from being destroyed. So I think in something like that where it's needed to be there, the compromise is somehow figuring out some sort of fish passage rather than complete removal of the dam. And I think there have been some discussions about potential for a fish passageway of some sort around Greenlawn Dam. I've seen some really cool looking projects like this outside of Ohio where there are essentially fish ladders or fish passageways for all species, not just large fish that can move through a large amount of flow, but even small fish do use those as well. So yeah, I think that would be the compromise there.
Brian, I was wondering if I recall correctly that darters use mussels as part of their reproductive cycle. And so when you're reintroducing fish, are you doing surveys to see that the mussels are already there?
So it's the other way around. The mussels use the fish. So the fish are often, mussels need a fish as a host species for reproduction. So if the fish aren't there, the mussels can't reproduce. The fish do not rely on the mussel. So it's the other way around, yeah.
The mussels in?
I'm not. Maybe someone else can. Yes, it may facilitate the reintroduction of a rare mussel if the host species is now back there too. That is a possibility. but I can't even identify most of the mussels. I'm very much a fish guy. So.
We'll ask Weasel to get back with you.
Yes.
Anybody else? Okay, other side of the room. Okay, nice and loud.
Here's Brian. Sorry. Go ahead, John. We'll get to Kelly after you. Go ahead.
I'm just wondering what else might be coming our way from the Allegheny.
He asked what else might be coming our way from the Allegheny River. We've documented quite a few species that have probably come out of the Allegheny. So think of it, I guess a good way to explain this is Big Darby Creek is often thought of our sort of sanctuary stream, if you will. There were a lot of species that when water quality was at its worst were only found in Big Darby Creek. The Tippecanoe, the blue wrest, a lot of these I talked about are good examples of that. These species are now throughout the entire Scioto watershed south of Columbus. They're not only in Big Darby Creek. It might have been that sanctuary spot where they re-expanded from, but we've done a pretty decent job at cleaning up a lot of our large rivers thanks to the Clean Water Act and other regulations. So these things are re-expanding naturally on their own. In the Allegheny watershed, French Creek was a tributary to the Allegheny, is their Big Darby, right? So it's a very similar situation. A lot of these fish were only found in French Creek, and it's a lot of the same characters. So the blue wrest, Tippecanoe, spotted darter, gilt darter, longhead, all these were for a long time only in French Creek. All of those that I just listed are now throughout the entire Allegheny and are actually showing up in the Upper Ohio. I've seen in the Upper Ohio, I've seen gilt darters, which are state endangered. We thought they were gone from Ohio. The last record was in the 1880s, and all of a sudden we're finding them in the Ohio River. I've seen them in Little Beaver Creek as well. So gilt darter, longhead, Tippecanoe, blue wrest, variegated, streamline chub, big-eye chub, all of these eastern sand darter, all of these are in the main stem Ohio River now. And we think of these as pretty water quality sensitive species, but they're migrating down from the Allegheny and showing up in the Upper Ohio River.
What's the genetic, or where are you getting your black chin shiners from?
Yeah, the black chin shiner, they're completely gone from Ohio. So she asked where they're coming from. We're getting these from glacial kettle lakes in northern Indiana. Indiana has a lot more glacial kettle lakes and larger ones than we do in Ohio. So there's a pretty endless source of these over there. So what we've been doing is we actually get them from a different lake each year, so that we're varying that genetic stock, and we don't keep using the same brood stock year after year after year. We get new brood stock each year. So hopefully when we're releasing these, we're mixing some genetics from a couple different populations that have a better founding population.
Okay, anybody else?
So thank you again, Brian, Paul, and Greg.
So we have a break now at 2:45. We have some refreshments up there, cookies, soda, coffee. So if you thought you got cheated out of dessert at lunchtime, here it is. We just thought we'd kind of level out the blood sugar levels throughout the day rather than get you all cranked up at once.
Okay, everyone. Oops, mic's not on.
Okay, everybody, break time is over. You can take it back to our seats. I'm actually a minute over schedule here, so I'm going to rush you all back to your seats. Okay, everybody, you can get back to our seats. We're going to convene the last session of our symposium. We're gonna finish up here today with some program updates and program news about different things we have going on in the state. Okay, our next speaker, Sarah Hippensteel Hall, Miami Conservancy District. So she works with Mike Eckberg, who spoke to us later. So we have two representatives from MCD today, traveled all the way from Dayton. So we appreciate that. Sarah said I didn't need to read her bio, but she wanted to remind me that she got started in this business doing stream quality monitoring as a volunteer at Camp Kenjockney on Big Darby Creek. So that's a good story. I like that. But Sarah serves as the manager of outreach, education, and stewardship for the Miami Conservancy District. She's raised more than $20 million to protect, restore, and preserve rivers and streams and aquifers, promote river recreation, sharing a BS from Ohio State University's School of Food, Agriculture, and Environmental Sciences, master's from Antioch University, Seattle, and a PhD in leadership and change from Antioch University. So I read your bio, so I've known Sarah for a long time. I don't see her again very often because she's in Dayton, I'm in Columbus. But good to see you and welcome.
Thanks for having me.
Yes.
I appreciate it. I see some friends. I appreciate you sticking around on a Friday afternoon. And probably some of you are going to be going into spring break. So even better that you came to this and stayed all day. So I appreciate that. I've got some cool stickers if you're into watersheds. I'm going to set them over here. You can come get them later. But I brought some souvenirs from the Great Miami Watershed in case you want a sticker or two. I'm going to say that now, otherwise I'll forget about it later. So I had, like Bob said, I went to Ohio State and I was going to be an English major. Doesn't that sound fun? And I got closed out of every class my freshman year. How many of you went to Ohio State? First quarter, I probably turned it in late, I don't know. But I got closed out. As I recall, I took gymnastics. I got an A. It's probably one of the only A's I ever got at Ohio State. And I was forced to take Geology 101. And the professor, I don't know who he was, I can't remember his name. I do remember a lot of my Ohio State professors. He talked about how groundwater and surface water were completely interactive. And in the high school I went to, I thought there was a shelf. So I don't know what we learned in science, but I remember being amazed that ground and surface water were completely interactive. And when I tell you about what I do at the Conservancy and what we do, and Mike, of course, has talked about groundwater already, that one little piece of knowledge changed my whole career path, and obviously it's something I still work on today. So at some point I became a volunteer for Ohio Scenic Rivers. I was an employee of the Girl Scout camp during the summers in West Jeff, and had a great time and learned all about bugs. When I graduated from Ohio State, I went to Indiana, and I don't know how some of you felt, but in Ohio State grads seemed like a dime a dozen. But in Indiana, they were like, wow, you went to Ohio State? They were very impressed by that. And I worked for the Indiana Department of Natural Resources for several years, and I created their statewide volunteer water quality monitoring program. And then came back here, and over the years have done a number of other things. I worked for YSI when I first came back to Ohio. And then I was recruited by the Miami Conservancy District because of my knowledge in watersheds and rivers and streams and monitoring, and that was 22 years ago. So happy to have had this wonderful long career and doing what I love. So all that knowledge I'm going to share a little bit about what we do at the Conservancy, how it's related to watershed planning, what I feel like works and what doesn't, in regards of a watershed planning as a tool to get us to improving water resources, right? That's the goal. The goal is not to write a plan, although I'm going to share a couple stories where there were plans written that never went any farther than that. But the goal is that that's a catalyst to making some kind of change in your community. And so I've just got some examples, a little bit of words of wisdom to share with you, and hopefully the idea is that we can do better as we go forward in regards of improving and protecting water. She told me what button to push, I immediately forgot. Okay, it's not me.
There she is.
Okay.
It's been a little finicky. It's not you. It's
How
IT.
many of you are from Southwest Ohio? My friends, okay. How many of you are for Central? Northern? It's like lump the whole, like the whole half. We divide the bottom half, but then it's just all, once you get past Columbus, it's just Cleveland to me. Because I'm from Athens. How many of you are from Southeast Ohio? Thank you. Townie here. Maybe some of you just went to OU too and never left, but I'm a townie, so that's where I grew up. Okay. So a lot of times when I start presentations and talk about water, I actually ask people what watershed they're from. And because I can do a lot better if you tell me what river you grew up next to than whatever town. I probably never heard of it, but I know where all the rivers are. So I grew up near the Hocking, actually near Margaret Creek, if you know where that is. I was born next to the St. Joe River in South Bend. I lived next to the Whitewater. Actually, my office overlooked the Whitewater for 3 years. And now I live on the Mad River. I live off Chapman's Creek, which is one of the major tributaries to the Mad River, which of course flows to the Great Miami. So I want to know what you love about water. So just shout it out. This is not, you're not going to get a grade. You don't have to worry about raising your hand. So what do you love about water? Oh, that sounds really fun. It's a universal solvent. What do you love about water? Paddling. Woo! Well, muscles, yeah. Okay, what else? I can't always hear everybody because you're talking. You gotta yell either louder or not on top of each other. Drinking it, yeah, we can go 2 weeks without food, or 3 days without, 2 weeks without food, but only 3 days without water. Or whatever it is. It's Friday. Birds, it's migration time. Is everyone excited? You know, I had my little Merlin out this week, and all I got was the cardinal, but they're coming through soon. Okay, what else? Fish are fun. We eat them. I raise rainbow trout at home. Well, my husband does. He's retired, so this keeps him out of trouble. We have a groundwater fed pond, and we raise rainbow trout. What?
Waterfalls.
Falls, yes. Very good. Love those. Very peaceful, calming. Water is very, so it's not just that it does all these things for us, you know, technically or industrially, some of you suggested, but it can be very calming and peaceful. Paddling, what else? That's it? You didn't say my favorite one. Okay. Well, these are all the reasons that I love water. And sometimes I do joke that the reason I want clean water is just because I want to be able to water ski on a clean river. I water skied for Ohio State. I learned how to water ski on the Hocking, where the Hocking meets the Ohio. And I have fished before. Joke gets less funny maybe as we get older, but I was only trying to land a husband on that bottom left. It worked. He loves fishing, so anyway. The Great Miami down in the bottom, top, your right, that's Port Clinton, or not Port Clinton, Put-in Bay. I done some triathlons in Lake Erie. Bottom right, she was 3.5 when we bought her first kayak, of course. bottom left, whatever that is. And there he is with his big fish. Does a lot of fishing. So the Great Miami is Southwest Ohio. Some of you know this. There's 6,600 miles of rivers and streams, but I'm not going to talk about what lies underneath it. If you hadn't heard from Mike already today, I certainly would be focusing on that because it's a big part of why our water resources are special in Southwest Ohio. We have about 1.5 million people that live in this green area, or the green blob is all the land that drains to the Great Miami. Minus the blobby part in Indiana, and since we don't have any jurisdiction over there, I pretend like it doesn't exist, but there is actually a river that flows partly through Indiana, but it doesn't dump into the Great Miami until almost its confluence with the Ohio. Yellow is where everybody's living, and green is over 70% row crop agriculture. So now you know everything there is to know about the Great Miami. Except that's just the water part. And so when I'm talking to non-water professionals, I'm certainly focusing on all the fun, active, exciting things, including workforce and job retention, that the water helps us have. And we have all this fun stuff. You know, you probably don't think about Frank Lloyd Wright, for example. There's one of his houses in Springfield, Ohio. When I'm selling people on the benefits of the watershed, I'm not always talking about water, and I'll talk about this in a little bit, in a few slides too. Doug, that picture on the right, I'm gonna have to change it. That's yeah, it's not there anymore. That whitewater park is a flat water park right now, but there is a lot of whitewater in the Great Miami. So it's not so great when it looks like this. And we think of algae blooms happening in still water or lake situations. But this is where I say, algae blooms, not just for lakes anymore. So this is the Great Miami River. This is not a toxic algae bloom. It was a vegetation. Actually, I think Mike went out and tested it that day to reassure our community members that it was something that was not normal, but certainly not something, terrible, toxic. It's a low dam, and when there's a low dam, it slows down water, backs it up, the nutrients come from those farm fields upstream, and in times of low flow, when it's hot and dry out, we get things like this. And if you're a rower in Dayton, this is the pool, one of the pools that you're rowing in, and I wouldn't want to be there during this time, even if it isn't toxic. I don't have to tell you that this is what we're dealing with. Point source comes from a pipe. We can point at it. The Clean Water Act did a great job of cleaning these things up. If you own a pipe, you have to get a permit. If you don't follow the permit guidelines, you could pay a fine. They can find you. It's your pipe. It's very easy to deal with these things. And non-point source is a lot of what most of you in this room are probably dealing with. It's polluted runoff from land. It's not easy to find the owner, right? I always joke about people who don't pick up their dog poop in the winter or anytime, but it's not like we can find you and come to your house, right? There's never gonna be a law about picking up dog poop. Although I think there are laws in European cities, but that's only because they're going on the sidewalk. And anyway, I digress. So non-point source is a big part of what we're thinking about as water resource professionals. Now here's where I get a little preachy. So technical challenges are things that are easy to solve. I know Bill's heard me say this a million times. If you break your arm, you go to a doctor. You don't know how to fix your arm. You don't know if your doctor knows what he's doing, but because he has a diploma on his wall, you trust that he can fix the arm for you. You give all of your trust in that she. Actually, all my doctors are she. I should never use he as an example. If your car breaks down, probably most of you are gonna go to the mechanic. My mechanic is also a woman. She wears these really long fingernails. It's a Honda dealership. I'm just telling you, it's a whole new world. You trust that, I trust that she knows what she's doing. She can tell me anything. right? It's a technical problem. It's easy to solve. I can find a professional and deal with it. That is what point source pollution is. We wrote some laws, we found the owners, we cleaned them up. Okay, it's not perfect, but it certainly has done a better job of what was happening in my watershed before the Clean Water Act passed, which was the river was running whatever color the paper was being dyed in Middletown that day. That doesn't happen anymore. But what we're dealing with here is not easy, and it's not technical, and it cannot be solved with a cookie cutter approach. So non-point source pollution is something that might be different in every situation for every community. It requires people to change the way they're thinking. They might think to themselves, well, there's nothing wrong with putting fertilizer on my lawn. There's nothing wrong with not reading the bag and making sure that I'm applying the right amounts. Why would they be wrong? They're selling me that at the corner store. And all my neighbors have a green lawn, so why can't I have one? I feel like I need to have, it's going to change a real shift in their behavior. I don't need to tell you. But it's certainly not easy. Even I am freaking out, Doug. The Star of Bethlehem is taking over my yard. I want to use the chemicals, but I'm not. Really big. I live on a farm in rural Champaign County. We have about 10 acres, and we're slowly turning it into more natural things, but there is some grass, and it's now mostly invasive species because I haven't used chemicals in 20 years. Okay. Adaptive. It's hard. It's messy. It requires a lot of people to change their behavior. So what I'm going to tell you is that this isn't a water problem. This can't be solved by water experts. It can't be solved by watershed people. And when I go to a meeting, and I'm very guilty of this, because half of you in this room are in the same meetings that I'm in all the time, we cannot solve these problems. This is not a water problem, it's not an environmental problem, it's a leadership problem. And so this is just a representative headline of something that when I talk to people, I tell them, although I gotta find a different way to say it now, when you look on TikTok, no matter when you're looking, I used to say, you can open any newspaper, any magazine, any day of the week, I don't care what it is, you will find an article about something bad about water. It could be too much water, it could be polluted water, it could be not enough water. Any publication. Now I gotta talk about the TikTok. Probably find those too. I learned how to make tamales on TikTok. It's useful. It's a useful thing. Okay. This is what my watershed looked like when I started working at the Miami Conservancy District. These colors are all the different community-based organizations that were representing different sub-watersheds of the Great Miami. Isn't that awesome? Little community groups had sprung up, and they were focusing on these geographic areas. They were making goals, they were writing grants, they were holding festivals, they were installing signs, they were seining for macroinvertebrates. How many do you think are left? There's a few. I counted them up today. Most of them are gone. And they didn't get replaced with anything. At least one of them kind of turned into a land trust. And a couple of them are still active. And the one that was first is still there. So who is going to do all this work? And was it really working to begin with? Can I tell you the secret about the Stillwater River? How many people know Stillwater? How many anglers are in the room? Come on. What's the #1 sport in the world? Soccer. It's fishing. More people fish than any other sport in the world. So, if you've been fishing on the Stillwater, do you fish? You should. You know the river's better than anyone.
It's been a while since I've been to Stillwater, yeah.
It's a really, really healthy river and incredibly well known for smallmouth bass population. And so they had a very active watershed group for years and years, I think probably 10 or more. And they wrote a 600-page watershed action plan. 600 pages. And they spent $10 million. They raised $10 million to install buffers, vegetative buffers. At the same time, the agricultural community was furiously installing tile. Completely unrelated, but they were getting incentives to install tile. So now, $10 million so everything could run right under those new buffers. I don't think, this is me personal, you come after me later if you want. I don't think any of those 600 pages got implemented in the way that they were meant to. Didn't work. Didn't work. Now, Indian Lake is a shining example of something that was working. They got, and if you had told me their setup, I would have said it is doomed to fail. They have, and I'm making this up, Greg, you know the number. They have they had 27 people on their board of directors. Oh, you'll never get anything done. Forget it. Get it down to 9, 11 maybe. 27 people, and they did get it done. They got grants, they raised money. They got one of their elected officials to put a line item in the state budget, and they got money every year. They got money from Bob Evans. They had someone come back to be the watershed director that was the retired USDA person in Washington, but he happened to be from the area. He was the person who used to walk the farm bill when there was an actual real farm bill from one of the buildings to another when it needed signed. He got stuff done along with everyone else that was involved with that. But we took that approach and we tried to do it other places and it didn't work because cookie cutter approaches don't work. They just can't. Every neighborhood is different. Every political situation is different. Every pressure that we're feeling is different. Every problem that we're feeling is different. We, Conservancy, Southwest Ohio, we don't have a water shortage problem. It's literally bubbling out of the ground. The aquifer is so full. Our communities don't talk about water conservation. Now, when you get up into the upper headwaters where the aquifer is not as deep, then yes, we're seeing some problems. But I put a well in next to not even a major trip. It's a third order, however we go. What do you go? 1, 2, 3, 4, 5. Anyway, it's a middle order stream. It came in artesian. We had to bring equipment over from Indiana to put enough pressure on it to cap it. It's capped about this high. We put a piece of brown turf over it so that it won't be a target for shotguns or something. You know, I told you I live in rural Shreveport County. And it runs artesian 24/7, 365 days a year, uphill to fill our pond up. I'm just saying there's a lot of water on the aquifer. So our problems are not your problems. So we certainly can't use the same approach to solve what we need to fix. But we tried that. It didn't work. What time is it? I'm almost done.
We started a couple minutes late.
I can go on and on. Okay, so this is what I joke, but I do work for a government agency. So sometimes the trust building takes a while, and Mike and I have just experienced some positive feedback from a county that we've literally been working for 20 years to mend relationships that were broken before we got there. So sometimes it takes a really long time to heal some of that stuff. So when I talk about the watershed, I don't necessarily, to non-water people, I'm talking about all the things that they think about every day, that they appreciate every day. They don't think about the water being clean when they open the tap. So we've also not just built a robust water quality and quantity monitoring program so that we can tell that story very specifically in technical reports, but we've also built a tourism and travel campaign around the river itself. We don't have an ocean, we don't have mountains. What we do have is this river, and we're gonna make the very best of it. So wore my I Love Great Miami Riverway pin. We pulled together 250 people at a summit each year just to talk about how great our river is and how we can build more access points and how we can keep it clean and how we want development in our urban core so that we're not sprawling out into our green space. So we do a lot of encouraging of redevelopment of our urban areas. No one else has this, so sorry about your luck. We have surfing on the river, you can sleep in a floating tent, and that anytime any of my social posts go viral, it's because we're talking about floating tents. Oh, and they literally opened up registration today. If you want to go sleep in a floating tent, you better get onto Float Troy's website today because they will sell out in the next week for the whole summer. And yes, you have to get up in the middle of the night and paddle to shore if you have to use the restroom. That's it. That's the first question I always get. So we monitor not just how clean this water is, we monitor visitation. We want to see, is tourism increasing as a result of the work that our riverfront communities are doing? And we have 20 riverfront communities that are working together to make this river better. So I don't want to say I trick them, but we trick them by bringing in the door, talking about workforce attraction, retention, and economic development. And then while they're there, we say, oh, by the way, you would never want to do that next to a polluted river. We're trying to take out low dams that are unnecessary when we can to make the river safer. We do a lot of marketing. We do a smallmouth bass fishing challenge. More trophy smallmouth sized fish have been caught on the Great Miami River in the last 10 years than any other river in Ohio. Better get your fishing pole over here. And that's the guy who won last year. So I would just say that the other thing we talk a lot about is we have 225,000 college students in Southwest Ohio in our watershed. And guess what they do after graduation? They leave. And Ohio is the top 5 state for students who leave and go somewhere else after. We all know that there's great stuff here. I went to Indiana, I came back, it was okay, but it wasn't as good as Ohio. So the reason they leave is because they're looking for something active, exciting, and fun, and they just don't know that it's already here. So we're trying to tell that story through the Great Miami Riverway. Okay, 2 more slides. Any questions? I am also the president of the Ohio Watershed Professionals Association. And so we want anyone who is interested in watersheds, rivers, streams, water health, water quality, all of those things. We have a professional organization where we get together, we do networking, we share ideas. We have an annual conference that nobody beats because we paddle and we have an awesome campfire. And we also do a lot of learning and education and workshops throughout the year. So if you're not already a part of WAMO, Water Management Association of Ohio, and part of this division, we would really love to have you. And we're about to send out a survey to all watershed professionals to just gauge what they're doing, how they're doing it, how we can support you, because this organization is here to help everybody. So this is what I want to leave you with. Stop just inviting the same people to your tables every time, the people that know about water or fish or the environment or soils or whatever it is that you're focusing on. You've got to reach out to diverse organizations because everyone needs to care about water. And the people around these tables can't solve it. You know how I'm gonna solve water problems in our watershed? By getting the land use plans better aligned with water protection. I need all those comp plans to be saying that water is the highest priority for protection. That when we do development, we are not digging up prime farmland right over sensitive aquifers. I cannot do that by just getting Bob with me. I've got to have those developers. I've got to have the land people. This is not about water and it's not about environmentalism. The people who have been successful are the ones who had good leaders. Leaders build good partnerships. So reach out to those, get those people at your table. If you're not one of them, you focus on the fish and the bugs and the technical stuff, then you need somebody who will speak up and start recruiting for you and getting people all working on the same direction. The mission is ultimately get clean water, but along the way, you might end up building a travel and tourism campaign. That's it. Thank you.
Thank you, Sarah. You tricked me. You asked for questions. I thought you were done. Real quick, any questions for Sarah? Mike? Do you have one?
Yeah, Sarah, you did a great job. Kids' education, school districts don't get out to the water anymore. Parents have got to do it, and most of them don't because two of them are working. And we need to get more child activities on water.
Yeah, that's a whole thing. We could talk about K through 12 education and what they've done to environmental empathy. There's a book written by an Oberlin professor called Earth in Mind. It's a little book. Everyone needs to go read that. Earth in Mind. And it's how our traditional K through 12 system has prevented us from knowing anything about the environment.
Do you know any challenges behind regional watershed planning? I know you said on that one image that, oh, we just don't think about Indiana. Well, if we began to plan on, a larger level besides focusing in on watersheds, do you think there could be benefits?
Well, yeah, you just got to get them to the table and you got to keep them engaged, set goals, make, set small goals and large goals. And so that people want to be participating in something where they feel like things are happening. So you set these little goals so you can say, oh, we did it. We got something accomplished. Okay, great. Let's keep moving. Environmental work is so hard and it's so depressing and it can be so dejecting sometimes when, the problems are so massive. Got to set the little goals so that you feel like, that you are making a difference just little by little.
We have one more question over here. Oh, okay. Last call. One more question for Sarah. Anybody?
Stay over there, maybe?
Thank you so much.
Thank you, Sarah. Our next session is a bit of a tag team. Who's going first? Mark? Yes, sir. So we have Mark Johnson with Ohio EPA and John Horn with ODNR. They're going to talk about H2 Ohio Rivers Initiative, right? Yep. For both agencies.
Like you're going to work.
We'll give a little background on you here, gentlemen. Mark Johnson served as the chief of Ohio EPA's Division of Surface Water since 2023. He joined Ohio EPA in 2012 and has worked in the agency's Division of Surface Water, Division of Drinking and Groundwaters, and Division of Environmental Response and Revitalization. He's also served as Deputy Director of Business and Regulatory Affairs, where he was the primary contact for regulated entities to help coordinate permitting activities within the Ohio EPA. Mark graduated from Kent State University with a BS in Conservation Biology. John Horn joined ODNR in 2023 as the program manager for the agency's new H2 Ohio Rivers Initiative. He's a freshwater ecologist, biology educator, fly fishing instructor, and general outdoorsman with a passion for Ohio's waterways and the life they support. In his new professional role, John is an advocate for Ohio's rivers and streams. His favorite river is the Cuyahoga, and his favorite stream to paddle is the Rocky Fork of Paint Creek in southern Ohio. So
Thank you, gentlemen. So Mark, I guess you're going first, or?
Yeah, kick it off.
However you'd like to do.
Thank you, guys. Appreciate it. Late in the day, but we'll try to keep it lively, try to engage everybody. I have to pre-apologize if my entire team over here, they're a bunch of shenanigans. If they do anything, throw anything at me, please let me know. Please throw things at them. Just kidding. They're a great team. You know, this picture right here, I wanted just to touch base on H2 Ohio. A lot of folks probably have heard of H2 Ohio. This was the Governor DeWine's kind of brainchild when he first started in the administration. Governor DeWine is a conservationist from his roots as a child, and he has water quality on his mind right when he came into his administration, and we created H2 Ohio program across the state. Ohio EPA's portion of that H2 Ohio program, historically, we received money, the lowest amount as compared to our partners at ODNR and ODA, but we were able to spend that money on water and sewer infrastructure projects across the state, help leverage federal funds to help solve problems and ensure that people had access to those utilities. Luckily this year, we were able to start in partnership with DNR, H2 Ohio Rivers. We were very excited about this. H2 Ohio in general, I think this picture here, this was one of our staff members. I won't call her out by name, but she's over there. She took this picture at Stroud's Run down in Athens. This really sums up what H2 Ohio is, what water quality. Ohioans enjoying how great Ohio is to live. The governor often says, Ohio is a great place to raise a family, do business, and work. Couldn't be more true with that photo, and we'd like to kick that off with this photo. So thank you, Rachel, for that. H2 Ohio Rivers, there we go. So there's kind of four different types of, 4 pillars of the H2 Ohio Rivers program that Ohio EPA is working on. River restoration, road salt management, dam removal, and emerging contaminant sampling. And I'll go into some more details on that. Oh boy, might have fat fingered that one. Sharon, don't even say anything. There we go. So I'll start out with the novel contaminant sampling, emerging contaminant sampling. We started this last fall, late summer, early fall. We are sampling 151 locations in all of our large rivers across the state. Ohio EPA, this great team has been sampling those locations for decades. We have a lot of sampling results from those over the years. So we have contracted out with a company, and they are going to these same locations and sampling for fish tissue, macroinvertebrate tissue, and water column sampling, primarily for PFAS. We started in the southwest region of the state. We got about 20 sampling locations completed last fall. Those sampling results are starting to come back now. As of right now, they're pretty low on the scale of PFAS. We are using the draft aquatic life use criteria that US EPA currently has out there as kind of our standard. Those numbers are very high compared to like the drinking water, MCL, and some of the things you see in the news. So far, the hotspots, pretty cool. We're gonna have all that data available, publicly available with an interactive map. The work will start up as soon as the weather cooperates, probably April, late April, early May. We'll have the contractors back out there collecting the rest of the samples across the state. And that data will be available and done, and all the sampling will be completed by the end of 2024. Also, with that sampling, we're partnering with DNR to do some mussel survey work in those same locations. You want me to talk here?
Sure. Thanks, Mark. So DNR's end of the program, as we join up with ODA and EPA to implement this program, we're focusing on some other areas. Mark alluded to our mussel survey, but there are 5 other parts of the program. We're focusing on a large chunk of our budget on preservation, but it's also a program focused on remediation of acid mine drainage areas in eastern Ohio. We've got funding for dam removal, as does EPA, and you'll hear more about that from both of us. We've got money for litter cleanup. We'll talk about this morning, Director Mertz shared the preliminary announcement of a litter cleanup program we've been working on for the last several months. We're excited to share more details about that here in a bit. So we've got many different parts of the program. Of course, in this, ODA will be partnering with DNR to implement CRP practices in Southwest Ohio and the Little Miami and Great Miami River systems. So we'll be working with them to incentivize more enrollment of, hopefully, we're aiming for 60,000 acres of additional conservation practices on current farmlands in Southwest Ohio. So that's
the program in a nutshell. And Mark and I are going to talk about each of our respective parts of the program in a little greater depth here. So, did it double?
There we go. All right. So I talked about that emerging contaminant sampling. This map shows all those 151 locations in our large rivers throughout the state. You can tell it's a statewide approach, statewide sampling result of what PFAS could be out there. Again, the main goal is to identify if there are hot spots in these rivers. Ohio EPA, that's kind of part of our other pillar of our state program. We'll go out there, we'll try to find those sources, try to remediate them. Again, try to clean up the problem and fix the problem with our state money. We're really excited about this program and seeing where kind of the results come. I wanted to spend a few minutes on dam removal. As John had mentioned, we, in 2023, as part of the Rivers program, Ohio EPA funded a dam removal in Troy and 2 dam removals in Piqua. Actually, the one dam in Piqua is a full removal. The second one is a partial removal because Piqua uses the intake for their drinking water plant behind the dam. We also have applied for National Fish Passage money with partners with U.S. Fish and Wildlife, ODNR, MCD, everybody to try to help leverage federal funds with the H2 Ohio program. Again, connecting people and nature and improving water quality. We're really, really excited about this. You can see some of the photos there. Future projects, we're certainly, you guys will see some handouts there. John will talk about those later. We're currently trying to kick the bush to try to get ideas for future projects. Right now, I've been in deep discussions with the city of New Philadelphia on the east side of the state. They currently have a dam there in the city. The dam has been there a long time. There currently is a 20-inch gravity sanitary sewer line that runs right through the middle of that dam. We were talking about that earlier. They haven't touched that sanitary sewer line in 84 years. Big problem. So those are the types of projects that really gain my attention, the director's attention, the governor's attention. That's why we want to try to leverage these state funds to get those problems addressed, to get those cleaned up, and again, open it up for a lot of people. We are also talking with New Philly. They also have some larger plans within the community to connect a lot of nature trails, some canoe liveries, some river cleanups that we're partnering with ODNR on. You know, early stages, we're preliminary discussions about that. We want to try to have good partnerships with our state partners and the communities, again, holistic projects to improve Ohioans' lives. I also wanted to spend a few minutes on our SALT grant program. Of those 151 locations that I had showed earlier, over the years, Bob Miltner back there in the back corner, great longtime employee with Ohio EPA. He's been helping analyze a lot of these samples, and we have seen a big increase in chlorides in our rivers across the state. We attribute that mostly to road salt application. So when we've looked at other states throughout the country, some states have a very robust salt reduction program. So we started kicking the tires on this. We've been partnering with Department of Transportation, and we come to find out that ODOT has a very robust internal program on salt reduction. They have immense diverse training for all of their employees. They've also have put a lot of capital to updating their salt application equipment, whether it's live edge blade plows, brine mixers, all that jazz that I have no idea about, but I get to talk about it. And so we decided to have a grant program. So we started a grant program, and the first round closed in January of 2024. We have close to 300 applicants across the state. And these are government entities, cities, municipalities, counties, those folks that manage road salt, even large park districts. And they have, all the applicants are currently in, we're starting to review them, over $14.5 million in asks. We do not have that much money to spend on this yet, but we're very excited on how much interest there was statewide in this program. So we're gonna start awarding those grantees some money here over probably the next month or so. The way the state budget works, we get our next slug of H2 Ohio Rivers money July 1st. So we're just gonna continue down these programs and these initiatives, again, to try to help clean up water quality across the state. We're very excited about this. Part of the H2 Ohio Salt Grant Program is education. You know, we just don't want to throw money and have folks buy new equipment, upgrade their facilities, and then still apply a ton of road salt. So ODOT, you know, we've been really rolling up our sleeves with ODOT. One of the issues that we come across in Ohio is, you know, these municipalities have to have contracts with salt suppliers, and you have to buy X amount of salt or you get fined. So they have these piles of salt. You don't want that sitting around all year. So what do? They apply it all over the roads as much as possible. It's not the right methodology. So we're looking at ways and areas where we can help as a state fix those problems, but also as part of the grant program, anybody that applies and is awarded money, they have to go through the training that ODOT currently has. We're also going to set up regional workshops to really try to expand statewide. We're really, really excited about this. Big shout out to my team on the work that they did here. I often push them pretty hard. Like I said, they turned around those almost 300 grants, review in about a month's time frame. And Jessie Langton on our team, who's not here, so I think she's tying in remotely. She did a lot of legwork on this. So thank you to my entire team for this. We're really excited. With that, I'll turn it over to John.
Okay, let's jump into some of what DNR's cooking up with respect to the Rivers Initiative. For clarity, ODNR's budget's a little over $30 million over the next couple of years to implement this program. And I wanted to show you how we are allocating that. More than half the funds are intended for high quality riparian area preservation. So things with oxbows, wetlands, forested bluffs, that sort of thing, along rivers and streams around Ohio. We're hoping to put into preservation. So after we dive into 55% of the funds, we have CREP program support. We intend to allocate a large chunk of the budget to that, followed by a small portion for supporting additional surveys and studies associated with mussels as intended this year. Share more about that in a minute. But fish, mussels, those traditional ICI things, so macrobirds, some of these bioindicators have been studied for a long time. We'll be tracking that in key systems as well. An area where we overlap with Ohio EPA's endeavors is largely in the dam removal area. Much of today is going to be a discussion or exploration activity about flowhead dams in Ohio. Our intention to hopefully target high quality opportunities for removal. We are funding some specific projects associated with acid mine lands or abandoned mine lands, in Eastern Ohio. And then we have a small slice of the pie dedicated to a litter program. Though it's the smallest slice, has certainly been quite a bit of work, and it's going to be a lot of fun to implement here the next couple of years. So that's how we are spending our portion of the budget. And I'm going to start with the river trash cleanup program, which Director Mertz announced this morning. There are two parts to this program. First is we're trying to clean up large litter sites, legacy dumps, old scrap tire piles that haven't been able to be cleaned up by some of the other programs the Ohio EPA has been implementing for years. So areas that nobody else has been willing to dive into, we're trying to clean up. Statewide, anything that's in the flood zone would be something we would consider. And if you know places like this, let me know. We have about 10 sites in our queue right now that we're working through. They look like this. They look like this as well. This is a big one that we're trying to figure out how to get this work done, but large accumulation of love seats and mattresses and suitcases and all sorts of things there. That's the sort of stuff that we're looking to try to accomplish. And then, of course, scrap tires. This site's getting cleaned up very soon. We've ID'd the contractor to take care of this one. So whether big or small, we're interested. But I would say that it's these sorts of situations that we're maybe most excited to be able to find solutions where nobody has found excellent or easy solutions before. Then the other part of the program is the Libraries Grant Program. Oh, there are 10 sites. Sorry, I forgot that I put the map in here. So you can see our large trash sites, they're scattered all across Ohio. So happy to work in Northwest Ohio. We've got a big hole there right now. Maybe there are no trash problems in Northwest Ohio along our rivers. I've heard otherwise from some liveries owners. So please let us know if you are aware of an area. The Libraries Grant Program is available right now, but we're planning for it to grow legs this summer. So it's a public-facing program where we hope a lot of canoeists, whether they're passionate canoeists or floaters, Floaters and paddlers all across Ohio can interact with this program. But it's a small grant program available statewide to any livery owner. So if you have local liveries you are in contact with on a regular basis, they should know about this by now, but by all means, please feel free to plug the program. We're calling it the Healthy Rivers Liveries Program. Livery owners can apply for up to $10,000 in funding to offset the costs of cleanups. It could be for equipment. It could be for small incentives for folks to participate. It could be advertisement of ensuring they get volunteers there at a cleanup type event. It can be for more than just volunteer-based events. Maybe they need to, I don't know, rent a cutting torch in a small John boat to float down the river, cut a car out of the bank, and get it out of there. So they can be pretty creative with this. And the application for that can be found online. There's the direct web link to it, or URL to it, but I always like to tell folks, Google ODNR grants, and then search for H2O or H2 Ohio. It's one of the top 2 hits. So a lot of these activities have already begun. This activity, we've got the website running. You should see a lot of activity associated with that program this summer. We're excited about that. That's what the website looks like. If you go to find the application, basic guidance can be found there. Hopefully it's self-explanatory, but if folks have questions, I'm the contact person. Those applications, soft close, but they close April 30th. So make sure folks know that deadline is on the horizon. There are the locations of the various liveries registered with Parks and Watercraft at ODNR around the state. So they're all across the state. We're hoping this leads to a lot of cleanup all across the state. I promised a lot of our dollars are going to preservation. A lot of our land holding divisions are driving a lot of these purchases. Right now, DNR is purchasing this property, and whether it's DNAP, scenic rivers property, or wildlife property, or it's forestry property, ultimately DNR intends to retain these lands. We're trying to prioritize things found along larger rivers, but anything that's got rich natural habitat, excellent forest, some interesting species, sensitive species, interesting microhabitats, that's the sort of stuff we're looking to purchase. Ideally, we're hoping to protect some of those floodplains, protect some of those areas that lead to better groundwater interactions, and hopefully provide a lot of habitat for the critters that use those areas. So we welcome leads on if you know of a landowner that's interested in selling that kind of property. These are the sorts of things that we are working to get in contract. Earlier this morning, Director Mertz, we're looking by end of fiscal year 24, so here in a few months, we hope to have 1,700 acres squared away, and 8 miles of stream bank protected, and things that look like this. Not a row crop buffer or some small strip of riverside habitat. We're looking to put some really nice pieces into long-term protection. CRP program expansion. There's been an enhancement program, Northwest Ohio and South Central Ohio, for quite some time in the Maumee, Sandusky, and Snyder watersheds. We're looking to expand that to Southwest Ohio. Can anybody fix the farm bill situation for us? There's some significant hurdles to clear here in the next year or so with this program, but ultimately we want to see more farmland end up in conservation lands. For filter strips, wetlands, there are like 8 or 10 different CRP practices that would apply for the additional incentive payments. We're hoping that enrollment can start late fall of this year. Again, there's some farm bill complications, so anything you can do to help move that along, please do. And wanted to give a quick shout out to MCD. Folks there kindly, the folks there kindly have signed on to help support this program. They've also put some money in the pot to advance this program along. So we're excited to work with them in developing some partnerships in the local watershed areas to grow this program quickly once we're able to. Other part of the program, many parts of the program, in the biological surveys realm, a lot of folks are really excited because they're already aware of this survey. We have a big mussel survey around the state planned for the summer in our large rivers areas. So 151 large river sites sourced from Ohio EPA. We're sampling for mussel diversity there, trying to set a baseline for what's there now. And so that we know in the future, when we go back to these sites, what we expect to see there. This is a monumental effort. We're really excited about it, and we hope that it leads to spin-off projects in the future based on our understanding of diversity around the state. That said, again, this is for large river zone. There's lots of opportunity for other extensive mussel surveys around the state, targeted watershed surveys, and we hope to be involved in that sort of thing in the future. For you fish lovers, we're not forgetting about the fish. We have our eyes on some projects for fiscal year 25 associated with some large river movement studies, and we have some expanded monitoring intended for areas where we're putting projects on the ground, whether it's abandoned mine lands work or it's dam removals work. So making sure that we keep well documented the progress that our various projects might create in a watershed. Mark's team's got a few more dam removals going on than our team at this juncture, but we are actively looking for more. We've got a dam on Stillwater River in Covington that we are planning for removal this summer. We're happy to be able to fund that project, and thanks to U.S. Fish and Wildlife Service and other players from around the state who've been involved in that project. So we're excited for that one. We've been looking for other prospects. We have a couple of good ones, all down in, there are two of these in Southwest Ohio, one in Eastern Ohio. We're working with folks driving those projects to talk about how to advance them along. But largely today, we want to talk more about dam removal prospects. So we're going to hand down a little activity here planned in a second. Almost there. Acid mine lands remediation. We have a couple of sites around the state that we're going to be doing some of this work. If you haven't seen the great impact that remediation can have on a watershed or on the landscape, we're looking to fund work that takes low boy and makes it go away, regrades areas that are full of gob piles and areas that are devoid of vegetation. Wildlife can't use it and turn it into areas that ultimately can support a variety of uses and redirect water so that you don't see some of this type of effect. So the areas of those two projects are in Southeast and in Eastern Ohio. So we're funding Upper Rush Creek remediation site. There's a lot of work that needs to happen in that watershed. We're going to be able to fund one component of that remediation plan that's there in that watershed, but it's an area that needs a lot of love, and we're happy to be able to offer some of it, some of what they need to clean that area up. And then over in Little Short Creek, we're planning to fund some of the preliminary study to eventually be able to do remediation work in that region. Ooh, that was a lot. So lots of different parts of the program. The end goal is to create make sure that our riverways continue to look like what you see here. Clean water, clean places for everybody to enjoy, recreate, and places for our wildlife to thrive. Which brings us to the next part of the program. So before we do that, 4:02, we're doing okay. Are there any questions about the program you all have before we wade into our activities?
On the preservation of riparian areas with that, will creating access points be a part of that?
Generally, the answer is yes. These are going to be largely public lands. There are some conservation easements involved where public access is not a focal point, but yeah, anything that becomes a wildlife area, a public area. Anything on scenic river property, there's intended light, fishing access, birding access, hiking, that sort of thing is intended long term. Does that answer your question?
Well, I'm looking for boating.
Boating infrastructure is a whole different deal. I think that there ultimately will be some of that's possible in those locations, canoe launches, kayak launches, but it's not necessarily an initial, expenditure plan for those properties.
Is there a project study plan developed for that survey?
The question was, is there a project study plan developed for that muscle survey? Yes. If you'd like, we have EnviroScience is going to be doing that work. They put together the plan for us. We have that in hand.
Are you mapping before and after dam?
The question is, are we mapping habitat before and after dam removals?
So we'll get change.
The term mapping may not fit my typical schema for what that would be, but there's lots of pre and post surveying and monitoring that's going to happen with the biota in the system. And then, of course, designs, diagrams, et cetera, that come along with the restoration component of that, of the channel. Those exist and will exist. Hopefully, before and after photos will be very self-evident, some of the benefits there.
So what sediment get an increase of usable habitat?
You bring up valuable points that maybe Mark wants to weigh in.
Yeah, great question. Part of the dam removals that Ohio EPA has worked on, and Eastgate's here with us as well. We've partnered with them along the Mahoning River on a lot of dam removals. Part of it's the sediment removal. Testing those sediments, seeing what contaminants are in there, removing that contaminants from the stream, and then taking the dam down. And certainly all the engineering studies, which are way smarter than my dull brain, they can anticipate what the transport would look like and what the end result is. Certainly there's continued monitoring from start all the way to finish and after the dam removed, to ensure success. So hopefully that answers your question. Okay. One more question, and then we're going to move on to the next thing if we can. Oh boy, trouble. Just kidding.
The river trash cleanup, can you have volunteers cleaning up the trash and then ODNR would pay for disposal of that trash? Or...
I'm sorry, I was having a side conversation with Bob.
For the river trash cleanup, can you have volunteers clean up the trash and then ODNR would pay for removal of the trash and disposal of it? Or is it just contractors collecting the trash in the river that you're paying?
The former is certainly, there's opportunity there. We haven't waded into a lot of those types of partnerships yet, but we're open to having that conversation if there's an opportunity.
And who would be contacted to?
Me.
Thank you.
Okay, folks, I know there are a lot of questions. Happy to field those after we're done. For the sake of time and for the sake of ensuring we get through this activity, I want to redirect your attention. On your table, there are some handouts. Now, there are 2 or 3 per table. This is a little activity we want to do. We know there's a lot of knowledge in this room, knowledge about ecological factors, anthropogenic factors. We want to get your input on this list that we put together. So we have what we think is a relatively comprehensive list of all the lowhead dams, and then a map to go along with it across Ohio. We want you to work in pairs or as a group and identify which dam you think is best to remove. If you could pick any pie in the sky dam to remove in Ohio, lowhead dam, on that list, which would it be and why? So work through those 3 questions and then we'll quiet things down in about 4:12.
You wanted to do that, Doc. then when we got to like when it transitioned to your side.
I'm not supposed to be talking.
Yep.
Yeah, that's fine. And being able to adjust on the fly is all part of the gig. So,
Hey, John, you been over tapped.
not in.
I've heard the, we got a specific question.
I'm not familiar with the context. I might be able to speak to this better if I can geographically place the context.
I've heard the director shared your thoughts on it, so understandable.
We're taking water out.
Yep. And I know, like, from a highway use perspective, like, for example, where retail is sending all the way to Columbus, we have a lot of biological water data here. Columbus has to sample it. On the Fayette side, I'll have to go back and look. I know we have data within, but the new discharge location for Honda might be a new location. So we'll have to take a look at it. I think it's something we should certainly talk about. Yeah. I don't think there'll be any muscle where Fayette's destructive. It's going to be way up. It's very small body.
Baby bears. Big bears. Fish.
Yeah. Yeah. We'll have to ask them. Yeah.
I know there was a lot of thought in.
I know you got an answer, Mike. Ecological importance.
What's an ecological? I heard something yelled out, but I couldn't make it out. Connectivity. For what critters?
For anything that's getting blocked by that dam, you're gonna reconnect the great stretch of new habitat.
Connectivity. What was it? Ecological importance? What else? Is it already falling apart? Public support. Is there public support for it? How complex is the ownership situation?
Along the lines of public support, can you create recreational access that improves public support?
Can you create a scenario to improve public support, possibly through access? Creation of a county park or township park or something like that. Any other ideas out there that folks want to share? You touched on a lot of things I've heard before, and things we definitely will consider to help us understand how the relative importance of each of these factors. If you would, when you depart today, please leave your handouts in the middle of the table. We're going to collect those. Just give them a read, take some tally of what folks think is most important. So thank you for participating in that. Do you have any follow-up questions about the activity or about the dam?
So I recently read an article about a dam removal that happened, and they did no water quality sediment testing and no sediment removal, and a massive fish kill downstream after the removal as a result, and I just wanted to get your take on what were your thoughts when you read or heard about that article presenting that came to your level too. It wasn't in Ohio, I think it was in California.
I did not read that specific article, but it's a less than ideal scenario that it's probably a result of some larger dam removal.
The article states that they didn't set aside money to do it.
Well, I'm glad that we have protections in place to make sure that we protect. We know what's there, the muscles that are there, move things around that need to be moved before a dam is taken out. Mark, do you have anything else to say to this?
Yeah, I think it's important to add that, whenever we're looking collectively between our agencies for dam removal, we ensure that they have the proper process and the proper funds in place to avoid those situations. I mean, we've been partnering with US EPA to take down the Gorge Dam on the Cuyahoga. That's a massive, massive project all the way to a smaller low head dam. So we have our safeguards in place to ensure that protection of public health and the environment is still there during these projects. Any other? There's one.
We brought fish back into the Mill Creek in Cincinnati by putting rock riffles in front of low-head dams that can't be moved because they're sewer pipes. And the fish have come back dramatically with some big water act and consent decree. And I thought, these mitigation projects are every bit support as a dam removal.
Couldn't agree more. So if you have some more of those ideas, please pass those along so we can spend the river's money on those types of mitigation projects. So I think we're short on time. John and I will be here for the remainder of the day, so please continue the questions or reach out to us and we'll turn it over to Bob.
Perfect timing, gentlemen. Thank you.
Thank you.
Thank you, Mark. John. Okay. Well, thanks everyone for staying this long and late into the day on a Friday. I'm the anchor man here. So I got the baton for the last lap. So
Ron Burgundy.
Try to make good time on the last lap. So I just wanted to provide everybody with an overview of the Scenic Rivers program and some of the things we've been working on, some of the successes we've had since the last symposium 2 years ago. For those of you that don't know us, I got a little background on the program here in the beginning. So some of you may already know this, but try to go through this fairly quickly. I'm Bob Gable. I'm the Scenic River Program Manager, Division of Natural Areas and Reserves. Why do we exist? So basically to work with local communities to protect Ohio's remaining highest quality streams for future generations. So despite the name, Scenic Rivers, this is not about aesthetics. It's not about just, scenic views and vistas. It's about the highest quality streams with regard to water quality, biological diversity, natural stream corridors, undeveloped watersheds. So these are really we'd like to say the best streams remaining in the state. Our mission is to identify those, designate them, have them designated as wild scenic recreational rivers, and then work with the local communities to protect them. So the designation is a legal designation that rests, the authority to designate rests with our Director of the Department of Natural Resources. We've been in existence for over 56 years. The program was founded in 1968, which actually predated the Clean Water Act. We currently have 15 designated river systems, just over 831 miles. So if you think about this, 15 rivers in over 56 years, this doesn't happen real frequently, and it's quite an honor for these rivers to achieve designation, and it's quite a task to get a river designated. It's just not, we just don't go out and pick a river and designate it by signing a piece of paper. There's work that goes into that. 3 different levels of designation: wild, scenic, and recreational. We also have 3 nationally designated scenic rivers. So the wild rivers, we have 4 of those in this sections of 4 of the rivers in the state are wild. So these different designations, they don't offer any more or less protection for the stream. It just different levels of designation recognize the degrees of natural integrity that the stream possesses. So the wild rivers are the most remote, least developed, like Little Beaver Creek here in Columbia County. If you're down in the stream, you look up, it's on the edge of Appalachia, you see nothing but forest. So it's almost like You're in little pieces of wilderness when you're floating down Little Beaver Creek. So very remote, very undeveloped, outstanding water quality. Most of the designations are actually scenic rivers, so they still maintain high water quality, outstanding biological diversity, good intact riparian forest buffers or other natural stream corridors along the stream. However, they may flow through predominantly agricultural land use, watersheds, and even a little bit of urban environment. Then we have two sections, section of the Maumee and the Stillwater from the Inglewood Dam downstream to confluence with Great Miami. They're designated as recreational. So again, same level of protection. Those sections of those rivers just lower degree of natural character within the corridor, but they still have other attributes, high water quality and biological diversity and things that made them worthy of designation. So here's some of the criteria we look for that I've been talking about. A contiguous riparian forest or other natural buffer, that's one of the most important criteria. Doesn't necessarily have to be a forest. If you go up on the Pontuning Creek, sections of the Wild River sections of Pontuning Creek, it's surrounded by vast areas of natural wetlands. So doesn't necessarily have to be forest, has to be the natural corridor that should be along the river. Limited human intrusions. We do look at development, levels of development, imperviousness in the watershed. And we have criteria for all these different parameters. I'm not going to get into the numbers, but we have specific criteria. Of course, local support is very important, and I got the hell vendor down here. I like to say that we'll focus on systems with federally and state endangered species, but it's not mandatory. So they're kind of like extra credit points when we start talking about the designated stream. Okay, so we'll go back and talk about the origins of the Scenic River program here. So you can say this gentleman here is the father of the Scenic Rivers program in Ohio. He's Glenn Thompson. He's editor. He was the editor of the Dayton Journal Herald. And back in the late 60s, he loved paddling the Little Miami River. So he began his efforts by going to Washington, D.C. and working for a national program to protect the Little Miami River in Southwest Ohio. Original legislation, first passing legislation died in the House at the national level. 1967, he created the Little Miami Incorporated, now the Little Miami Conservancy, to help protect the Little Miami River and foster the creation of the Scenic Rivers program. 1968, ODNR Director Fred Moore supported the idea. And that same year, Senator David Holcomb sponsored the legislation along with Senator Gilmore and Representatives Corwin M. Nixon and George Winovich. So there's some familiar names up there. I'm sure you folks have heard of some of those people. Corwin M. Nixon is a covered bridge on the Little Miami named after Corwin Nixon. And February 28, 1968, the legislation passed out of the House in Ohio, and March 6, 1968, was signed by Governor Rhodes. So the program was created. And justly so, the Little Miami was the first state scenic river designated in 1969, and sections of it were the first nationally designated scenic river in 1973. Another gentleman that was very important to the creation of the Scenic Rivers program, Mr. Charles Purvis, Speaker of the House, from 1967 to 1972. Unfortunately, we just lost Mr. Purvis here this year, March 2024. Sad to hear that. He was a supporter and friend of the Scenic Rivers program. Even in recent years, in 2018, he spoke at our 50th anniversary celebration. It was held at the State House Rotunda. That's an image of Speaker Purvis from that event. And in 2022, he was awarded the Glenn Thompson Award by the Ohio Scenic Rivers Association. So I'll jump back to a little bit about what we do and some of our recent successes. I have an incredible staff. I have basically 10 people across the state. We have 15 rivers designated across the state. We have it divided into five scenic river regions, 2 staff per region. So we get a lot done with the 10 staff we have. I'm in Columbus, try to help them out as much as I can. Sometimes I think they think I'm just getting in the way, but I try to help them out. But there's a lot of demands if you're thinking about river conservation and you're thinking about trying to protect a section of a river that's maybe up to 100 miles long. Longest one, Little Miami is 108 miles. There's a lot of stuff that can come up and a lot of things that need to be addressed. Obviously, our highest priority is to protect that riparian forest corridor along the stream, or that natural buffer that exists along the stream. We focus a lot on increased educational opportunities, getting people to the stream through our stream quality monitoring program. We implement the Ohio Scenic River Law, which basically gives us the director of our department approval authority over publicly funded projects within 1,000 feet of the state designated wild scenic recreation river outside of municipal corporation limits. So that's all I'm gonna say about that. Don't want to get into that. Dam removal, we do that whenever we can. Those opportunities don't come along very often. And each scenic river, designated river has a local advisory council appointed to advise our staff back with regard to issues pertaining to the conservation of that system at the local level. So riparian conservation efforts, like I said, this is one of our primary focus. This is our success year to date. Statewide, Division of Natural Historic Preserve Scenic Rivers Program, we own or manage 2,500 acres, fee simple, and another 3,600 acres of conservation easement. So we have over 6,000 acres protected, corridor protected along these rivers across the state. Plans to acquire 1,000 more by 2026. We'll talk about that in a little bit more in just a minute. So one of our successes I wanted to focus on here recent successes, Little Beaver Creek. I got too many animations in here. I'm clicking myself to death. So it was designated wild and scenic in 1974. It's the third river to be designated in the state. We have 4 rivers this year, as marked by these banners up here that are celebrating their 50th anniversary. Little Beaver Creek's one of them. National scenic designation in 1975, was second after Little Miami to be nationally designated. Outstanding biological diversity. Now this is where we've had a great deal of success in Little Beaver Creek. We just recently protected 3 parcels totaling over 110 acres, which added to our total. We have 2,700 protected through conservation easements, brings us up around 2,800. And if you add in Sheepskin Hollow State Nature Reserve, that's over 3,200 acres we have protected along Little Beaver Creek. We also have other ODNR divisions that own land in the corridor. Division of Forestry, Beaver Creek State Forest, Beaver Creek State Park. So we have more corridor protected in this scenic river than any other in the state. So we just recently dedicated some of those acres as Little Beaver Creek State Nature Preserve. There's a couple of outstanding properties. I said we just recently acquired 2 parcels. We're working on some additional acquisitions adjacent to those parcels that could be later on amended into the nature reserve. So these are outstanding properties that have extensive riparian corridor, tributary streams, ravines. You saw the small waterfall there. High biological diversity to the spring salamander here. And we also found a little population of running buffalo plover when we walked the site. I think it was maybe 2 summers ago. Didn't expect to see it there. We had Britt Gardner along, our botanist, and we're just kind of walking along. Oh, here's some running buffalo plover. So okay, cool. We'll add that to the list for the site. It was federally endangered. It's been delisted, downgraded. I don't know what its current listing is, but it's still rare. Big and Little Derby Creek, recent successes there as well. So background on those streams, designated scenic in 1984. National Scenic 1994. So every National Scenic River, the 3 in the state, they're designated for what they call they're outstandingly remarkable values, the ORV. So I know it's kind of a mouthful of a term, but basically it's what characteristics does a river possess that makes it unique and worthy of designation as a National Scenic River. Little Miami has 8. I think Beaver Creek has 4 or 6. I'm looking for Matthew, he probably knows. Big and Little Derby have 1. One reason it was designated as a National Scenic River, and that's the mussel diversity. It's outstanding mussel diversity. 44 species known from the system, 5 federally listed, 4 endangered, 1 threatened. We have a lot of issues we're dealing with in the Derby watershed right now. And, mussels are declining, so that's one of our biggest concerns. The fish, water chemistry, and everything's doing great. High biological diversity in those taxa, but the mussels are slipping. And we're seeing that everywhere. And we're not sure why, trying to figure that out. But this is a concern in the Derby Creek system. So we've done a lot of land protection in the Derby corridor as well. We focused primarily in Little Derby corridor. Here's these different colors represent different agencies that hold land. The scenic rivers are the green, the blue here, dark green. This is all metro parks. Some Franklin County metro parks. They've done an outstanding job of protecting corridor along Big Derby. The Nature Conservancy owns a few pieces here on this map along Little Derby. They own more land up in the headwaters. Years ago, we kind of had a gentleman's agreement between us. We all sat down at a table and we agreed that, metro parks would work in this area here, Franklin County, Big Derby. TNC would work in the headwaters, and we said, okay, we'll work in Little Derby and upper Big Derby, downstream of the headwaters. And that was quite some time ago. And we all kind of shook hands. There's no written agreement or anything. And for years now, we've functioned that way and all managed to work on land acquisition without getting each other's way and bidding against each other and things of that nature. So it's turned out to be a very good deal. So altogether, we have over 1,100 acres currently protected in Little Derby, another 400 in Big Derby. And we got significant frontage on Little Derby, about 7.5 miles, and almost 12 miles overall on those streets. So we dedicated Little Derby Creek State Nature Preserve as well. I have them out of order here. Little Beaver Creek was the more recent dedication. So it was actually State Nature Preserve number 147. So this was the previous, Little Derby State Nature Preserve was Nature Preserve number 144. Little Beaver Creek was 147, I'm sorry. So we dedicated these parcels here, kind of in the core of that map I showed previously. We're in the process of transferring these properties here from the Nature Conservancy to Scenic Rivers DNAT Management. In exchange, we'll give them some property that we hold in the headwaters. So we're kind of consolidating our holdings for management purposes. When that happens, these parcels can be amended into that dedicated nature reserve as well. These sites are phenomenal. You never know what you're going to find in Derby. You get the rare fish, you got standing fish communities, you got the mussels in here, and you also have the chance of coming across the prairie remnant. So we found several natural prairie remnants in here that we're working to restore, and one of them has just an outstanding population of this little scaly blazing star. Switching regions of the state here, another recent acquisition on the Ashtabula River, William Budd Hill property. Entirely wooded property, 54 acres on the Ashtabula Scenic River. Another phenomenal property. It's got these steep ravines with tributary streams. Got some wetlands, category 3 wetlands down the floodplain. The site was named in recognition of William Budd Hill, who was a long time Scenic River Advisory Council member on the has to do with advisory council. He passed away and he wanted to see the property be protected by ODNR. So we worked with his family to make that happen. And we had this dedication ceremony last September in 2023. Our stream quality monitoring program, this is our educational outreach program where main goal is to take people out the stream, have them do macroinvertebrate monitoring, and talk to them about stream ecology and how we can use macroinvertebrates to monitor stream health. So these are some numbers of the last 2 years. We have what we call reference stations on all 15 rivers. So that adds up to about 117 sampling sites across the state. So between 2022 and 23, we took 821 assessments. Our goal is to get volunteers involved, so we recruit them and get them trained, give them the equipment, and then they can go out and monitor a reference station for us. So we have about 300 volunteers that are working with us to sample these sites across the state annually. And that totals up to about 6,000 volunteer hours. We also perform QHEI, Qualitative Habitat Evaluation Index, evaluations at these reference stations every 5 years. So we rotate that. So we're not doing, all the rivers every 5 years. We'll do one river and then the next year another one. So we got them staggered. So we did 26 QHEI assessments in 2023 with volunteers coming along to assist with that. We're also starting down the path for some level 2 monitoring, which is more sophisticated monitoring technique. The stream quality monitoring program traditionally has been just a kick seine. We go ahead and identify the macroinvertebrates on the bank. This requires a more sophisticated sampling methodology, collect more macroinvertebrates and take them back and identify them at the lab later. And so far we've sampled 18 sites, including continuing education on the level 2 monitoring with our volunteers. Some of them are interested in learning more and moving up to that level as well. Just some of our numbers for our statewide education efforts. Last 2 years, 316 events, over 24,000 attendees. We have our state fair stream tank. If any of you have ever seen that, we estimate we interact with about 12,000 people at that tank for the duration of the fair. It's a rough estimate, of course, but we actually did have one of our interns stand there with a clicker and count everybody that came to the tank one day. So there's a little bit of actual analysis behind it. In March 2023, we did an urban school program for 68 students. And of the 68, 16 went to the river to do some stream quality monitoring. And those 16 folks had never been to a river, period. So that was their first time. That's something we hope to be able to do more of in the future, is outreach of that nature. Dam removal, I mentioned that doesn't come along every day for us, but if we get the opportunity, we will certainly pursue it. The Brinkhaven Dam and the Mohican Scenic River just came out last fall. Here's some statistics on that. It was kind of busted up, had some holes in it. I think there had been a couple accidents, severe boating accidents on it. So there was a lot of support to take that out. It was a good project. Nature Conservancy assisted us with that using some mitigation dollars. So Senate Bill 156, I'm not going to go deep into this, but I mentioned our Scenic River Law earlier. We have this approval authority over publicly funded projects. That's not going to go away, but we did have some language in the Scenic River Law that was kind of intimidating, we'll say, to local landowners. So when you designated the river, the designation included 1,000 feet on either side of the river, and that was proclaimed as wild scenic or recreational river area. So in some of our recent attempts to designate rivers in the last few years, that did not sit well with with some of the local landowners and local property owners. There's also paragraphs in the law that say that that designation doesn't affect or interfere with private property rights, give any governmental agency any authority, blah, blah, blah. But they still, you know, you read that to them, they still weren't convinced. So we're going to go ahead and we're going to take that language out. And in the future, the designations will just be the water course itself. Also creates a definition of what we're going to call scenic river lands, some of these properties I was talking about in previous slides. That's what we're going to call them for just, again, sake of clarity. We have rules for those properties that, you know, tell you what you can and cannot do when you're on the property, like light a fire, hunt, whatever the prohibition might be. And again, landowners were looking at those rules and thinking it applied to the scenic river area. And that they wouldn't be able to have a campfire on their private property along the river it was designated. So trying to clarify that. Passed the Senate unanimously in January. Our sponsors were Senators Reineke and Hackett. Reineke has the Sandusky Scenic River in his district. Hackett has the Miami. And it's since been introduced into the House, and it's in the Energy and Natural Resources Committee, and we're waiting for word on when it might go to committee hearing. Thank you to those of you who testified on behalf of the bill in the Senate. We had 5 representatives from different organizations come in and testify for us. We'll probably be reaching out to you again to do the same in the House, so you're willing to help us out again. And John and Mark talked a lot about the H2 Ohio Rivers Initiative. So we are trying to take advantage of that opportunity and capitalize on that as best we can. So right now we've submitted riparian protection projects, acquisition of conservation easements on roughly 1,000 acres on 8 of the 15 scenic rivers statewide, an estimated cost of about $3 million. So we're really trying to, like I said, trying to capitalize on this opportunity and protect as much corridor as we can. I told the director my goal was to have at least one acquisition project on each of our scenic rivers. So I'm better than halfway there. So got 7 left to go. This is one of the properties that we recently looked at on the Mohegan River. 155 acres, all wooded, forested hills, ravines again, tributary streams. Phenomenal property. That tree right there, that's a white pine. That's a huge white pine. And when we first went out there, landowner says, "Well, we've got a white pine plantation. We'd like to cut it, harvest it before you guys buy it." I'm like, okay, we'll come and look at it. We went out there and looked, and I expect to see rows of white pines, maybe this big around. No, this looks like a natural population of white pine intermixed with hemlocks. So we told them, no thanks, we'll buy it intact. We don't want you to harvest it. So we're still in negotiations with that family, but there's 13 family members involved. I think he's the one holdout. But the rest of the family, they said, well, we'll take care of him. So we're waiting for that to happen. That's not my words, I'm quoting them. So here's the 8 rivers that we have currently have projects on. So the other 7, if any of you have any ideas, let us know. Let your regional scenic river manager know. Some of these are going to be tougher than others. The Chagrin's a tough one because land is very valuable in the Chagrin River corridor. But we got projects there, so we got one tough one out of the way. The other one's going to be the Olentangy River. Olentangy River corridor is some very high price real estate. So get projects in one of those 2 corridors. Please let us know potential acquisitions. Big and Little Derby is getting pricey as well. We're also working with John to facilitate some river cleanups on 5 scenic river properties on 4 different rivers. That's about $150,000. So that's a past cleanup, but again, that's kind of stuff we're talking about. And we've also, John and I and other H2 Ohio Rivers Initiative team members, we've talked about funding for future mussel surveys. We've got some other mussel surveys in the works. I'm not going to
say which river yet. And funding for what we call an integrated prioritization system, IPS analysis. That's very complex. I'm not going to go into that here, but for the upper Southern River Basin, which would include Olentangy River and the Darby Creek system. So I forgot to mention this. One last topic I want to talk about is potential future river designations. So I forgot to mention it when I showed the first map. You'll notice that in our distribution of our wild scenic recreational rivers across the state, we have this big void in southeast Ohio. And that's not because there's not rivers worthy of designation down there. So we're trying to solve that. And we'd love to get some rivers designated in this region. Here's some folks that have expressed interest to us in having their stream designated possibly. Right now, the one we're working most closely with are the folks in Raccoon Creek. Yay. Hopefully we can get this done. So we've actually started looking at the designation criteria along Raccoon Creek, the outlet criteria. Raccoon Creek is a phenomenal success story. And I don't have all of the data in here showing the work that you folks have done, but basically it's 112 miles long, very undeveloped watershed, 75% forested, flows through 6 southeast Ohio counties. Basically the stream was dead in the 1980s, right, guys? Parts of it, okay. Not a lot of aquatic life, not a lot of high biological diversity. Suffering from impacts of mining, acid mine range, and with all the work that the Raccoon Creek Partnership has done in this system, over 100 miles now meet or exceed warm water habitat, aquatic life use designation, and lower 40 miles meet EWH. So the map here, this is the EWH section. Comes up, there's a dam somewhere in there. And if it wasn't for that dam, this is the warm water habitat section. If it wasn't for that dam, we'd expect the EWH aquatic life use designation would extend further upstream. So again, they've done a lot of outstanding work down there. Working with them right now. I'm trying to move this designation forward. And because of all their work, you can now find fish like this paddlefish, which they took in the mouth of Raccoon Creek. So with that, I'm going to leave you with that image for the day, and we'll call it Big Fish Friday, and we will be done. So thank you very much all for attending. I don't know if anybody has any questions for me or John and Mark are still here. We're willing to hang out if anybody has any other questions. If not, safe travels. Again, we appreciate your attendance. Look forward to seeing you all in 2026. Next year will be the Ohio Botanical Symposium, so hopefully we'll see some of you there as well. So, thank you.